Now that we've covered validation and basic CRUD inside of a MongoDB with Mongoose on top, maybe it's time to stop worrying about just a single model inside of our application. After all, it's not incredibly frequent that we would end up with just a single user or single user model with no other type of resource inside of our app. So I think maybe a good practice or a good way to extend this application would be to add in another type of resource on top of our users. So not only have users, but some other type of resource. Maybe, to stick with our theme of post count down here, maybe we could have a list of or a collection of different posts. So like a user could create a post, and once a user creates a post, they would kind of like belong to them in essence. So we might say that a user has many posts because a user can create many different posts. And by the way, when I say post, I mean specifically like, say, a blog post or something like that. So let's think about how we would add in a collection of posts, or just like I don't even really want to use the word collection right now. I want to just think, how would we add in the idea of posts inside of our application? So your first intuition might be, well, let's create another Mongoose model to represent a post, right? Right now we've got a Mongoose model for a user. Let's make another one that will represent a post. So if we did that, we might end up with something like this. We would end up with one type of model, like a user, which would have a name. And we would also have another type of model with a title, with something like, whatever the title of the blog post might be. So these would be two completely different resources. This is approach that we're looking at right here that would make a lot of sense inside of a SQL type database or a relational type database. Inside of a NoSQL database like Mongo, we start to kind of like twist this type of relation between these two models in some fashion. The important thing to remember here is that I said explicitly a user has many posts. So whenever there's a post floating around, it is always associated with exactly one user. With that in mind, inside of our Mongo database, a more reasonable type of data structure might be, rather than to have a separate collection of users and a separate collection of posts, would be instead to still have a single collection of users, and then inside of a user model, we could have a list of different posts that belong to them. So maybe our user Joe, with the name of Joe, has a post property which contains 3 posts inside of it, each of which has a distinct title property. This concept of nesting records or nesting associations rather than spinning off completely new collections is at the core of what makes Mongo Mongo. We'll talk a lot more about possible design schema in the future, but for right now, I want to just kind of walk down this path of seeing what it would be like if we had a collection of users where every user could have a list of posts kind of embedded inside of them, so to speak. So every user can have the ability to have multiple posts. So that's our goal. Okay, so just thinking about this in a different fashion, this is our user model, or a diagram of our user model. Right now, our user model has a user schema. The user schema has a name, a post count, and then I'm suggesting that we add to it the ability to have an array, like there's supposed to be a list right here, of posts. Then we'll have a post schema, which contains a title. One thing I'm going to say right now, and I'll repeat it probably several times between now and the next section, is that whenever we embed a document in this fashion, we will not create a separate model, like I'm specifically using the word model here, to represent the nested resource. So we will not make a post model. Instead, we will make only a post schema. So we'll write some amount of code to describe what a post inside of user should look like, but we will not make a distinct Mongoose collection, or a distinct Mongoose model around a post. The reason for this is that Mongoose models, like our user model, are made to represent distinct collections that are sitting inside of our MongoDB database. But in the case of posts, this is not a distinct collection. In RoboMongo, we're not going to have a list of posts on here. We are going to only have a list of users or a collection of users, and inside of that, each user can possibly have a list of posts. So because of that, we will not be making a post model, we'll only be making a post schema. Whew, okay, so lots of talk about post and embedding and all this kind of good stuff. Let's continue the next section and figure out exactly how we are going to make a post schema and embed it in some fashion inside of our user model. In the last section, we introduced the idea of an embedded collection of posts inside of our user model. The one thing that I want to make sure is really clear is that we are going to have a post schema, but not a post model. So we're not going to make a mongoose model out of posts, we're only going to make a schema. The reason for this is that we only create mongoose models to correspond to a collection of records inside of our database. Because these posts are not represented by a standalone collection, we're not going to make a post model, we will only make a post schema. All right, so let's get started and we'll start by creating our post schema first, which should only have a title that's going to be a string. Once we create that schema, we'll wire it up to our user schema. So the user schema is going to be aware that it should have a kind of sub-collection or embedded list of posts inside of it. One last thing I want to say before we get started with any code, in the Mongoose world, this idea of kind of embedding one resource inside of another is referred to as sub-documents. So our user model itself is what we refer to as a document. The post that we're going to embed inside of it is referred to as a sub-document. Okay, let's get started. I'm going to flip over to my code editor, and the first thing we're going to do is create a new file to just house or hold the post schema. So inside of my source directory, I'll make a new file called post.js. Now the one thing I want to say here is that it's a little bit misleading creating a completely separate file to house the post schema by itself, just because all these files we have in the source directory right now, you might think to yourself, well, these are models, surely both of these things are models. It could be worthwhile to rename this thing to like post schema, just to differentiate between a file that only holds a schema versus a file that holds both a schema and an actual model declaration. So just something I want to throw out there. The naming convention that we have here maybe could use a little bit of work. So inside of our post file, we will create a new schema and then export it and then make use of it inside of our user.js file. So we'll start by importing Mongoose. And then off of this Mongoose, and I keep on misspelling it, Moongoose. All right, there we go, Mongoose. We will pull off one property off the schema, or excuse me, off of the Mongoose object, which is our schema. So there's our schema right there. So now we can use this object to create our post schema. So we'll say const post schema is new schema. As we mentioned several times now, a post is only going to have a single property, and that is its title. So we'll give it a title of string. Now remember that we are kind of under the understanding here that these posts are supposed to represent blog posts. I'm only giving it a title right here, but you could just as easily add on some other stuff like, maybe content, and that could be a string. Or you could add on like a created at to represent when it was actually created, all that kind of good stuff. Just for the purposes of this example, we'll keep the schema of this thing or the different properties it has nice and simple, but certainly we could add on some additional schema or additional properties later on in the future. Then after creating the post schema, we'll add on our export statement. So module.exports will be post schema. Okay, so we created the schema now. We did not create a Mongoose model because this is not going to map to a distinct collection of posts inside of our Mongo database. We're now going to flip over to our user model file. So here's user.js, and we need to wire this thing up to we need to wire up our post schema to this user model, this user schema. So first at the top, we will import our post schema. So I'll say const post schema, and I'll require that from in the same directory. So I'm going to do a / find the post file. So now here's the fun part. We need to somehow communicate to the user schema that it should have an embedded list of posts, which are represented by the post schema. To do so, we will add a new property to our user schema, inside of which we will say hey, user schema, you should have a property of posts, and it should contain an array or a list of post schemas. So I'll say post schema like so. So now Mongoose is going to look at this property. It's going to notice that it's an array. So it knows that this should be a list of records. And then it will see that there's a schema here. And Mongoose is just going to infer, it's just going to kind of make the big assumption that, okay, this must be a nested subdocument or list of subdocuments of some kind. So that's all we really have to do to wire up this association. Now, whenever we create a user, we have the option to add a post property. And inside of there, we can have an array of posts. Right now, we don't really have any validation or anything around that, but we certainly could add some in as well. So let's take a quick break, come back in the next section and write some tests and just kind of figure out exactly how these embedded documents work. Now that we've wired up our post schema to our user model, we can add some tests to just see how subdocuments work with Mongoose. To make a new test file, I'm going to find my test directory, and then I'll make a new file called subdocument test. So inside of here, we'll put together a little bit of our boilerplate and then just kind of figure out exactly what it is we want to test inside of here. So we'll start off with our assert statement. We'll require in assert, and we'll also grab our user model. Next, we'll put in our describe statement, and I think a reasonable describe would be just subdocuments. So now, what do we really want to test here? What would be a reasonable first test? I think maybe just to start, we should start off by saying, kind of figure out how do we just create a subdocument and save it? How does that exactly work? So I'm going to make an it block, and we'll say it can create a subdocument. And we'll place our function, and before I forget, I'll add in my done callback. So inside this test, I want to try just creating a user with a nested post. I want to save it to my database, and then I want to fetch that record out and make sure that the post actually gets saved inside of there, and just kind of play around with it a little bit and see how it works. So inside the test, the first thing we need to do is create a user with a nested post. To do so, we'll make our favorite user Joe, say new user. We'll still give him a name of Joe. Now we need to add in our collection of posts, or our embedded list of posts inside this thing. To add in our posts, we don't really have to do anything special. We just have to pass in some amount of data that matches the structure that the user model expects. So what I mean by that is we need to pass in a key that points at a list or an array of records that match the schema of a post schema. If we then look at our post schema, which we just put together as well, we know that we know that our post schema requires just a title that should be a string. So in practice, we can just say, all right, Joe right here, he should have a post property, and that should point at a list of posts where each post is an object that has a title. So I'll give it a title of, what's a reasonable post title? How about just post title? That certainly works. Why not? So now I've got a little bit of a long line here. I'm going to go ahead and do a little bit of new lines just to make sure it's a little bit more legible. Okay, so that looks good right there. So in practice, creating new records with subdocuments is not the worst thing in the world. We can just keep on nesting as many properties as we would like inside this thing. Mongoose is going to see that we are providing a post property here, and it's going to automatically attempt to apply the post schema to this inner object right here. Note that when I say apply the post schema, what I really mean is that if we had written any validation into the post schema or any type of rules like that, that's where Mongoose would come into play and would start triggering some validation over the properties inside of this post right here. But right now we don't have any type of schema, so let's just save this thing and figure out how to work with it. When we have an embedded subdocument inside of an existing model, or an instance of a model to be precise, we can save the top level instance of the model, so in this case Joe, without any other special behavior. Nothing special here whatsoever. Still going to behave exactly the same as what we were doing before. In other words, all we have to do is call joe.save. Mongoose is going to recognize that we have an embedded list of posts here. It's going to automatically save everything inside of here as well. So we can say .then, and we're going to follow a similar testing strategy as we've seen previously, where we're going to save our model Joe. Then we will fetch Joe out of our database, and then we'll finally make an assertion about him. So we'll say user.find1. Let's just go ahead and find Joe. And then we could add on a chained .then, which will be called with a user. Notice I'm going to refer to user here as opposed to Joe. Just because we fetch the record that represents Joe out of our database does not mean that Joe automatically somehow magically gets updated. The user and Joe right here are, like, in theory the same thing, but they're completely separate objects. So inside of our test, we're going to make reference to user, which is returned by this find1 query, as opposed to referring to Joe. So now inside of here, we can make an assertion about the user that got returned. So what would be a reasonable assertion here? Well, we really just want to make sure that our record, Joe, can be saved with a subdocument. So I think that maybe a reasonable assertion would be to look at this user object that got returned and make sure that it has a post title property that is equal to post title. I think it's probably a reasonable assertion. So inside of here, we will look at the user. I expect the user to have a post property, which should be an array. Because it's an array, I want to pull out the first record that's inside there. So I'll say at 0. Oh, there we go, at 0. And on this first record, I want to grab the title property. And of course, that should be equal to post title. Okay, one last thing. Don't forget we need our done callback inside of here, that one little piece of magic. Okay, I think this looks good. Let's check out our terminal and see how our test is doing. All right, looks like we got 17 tests passing now. As usual, I'm going to just make sure that I can make this spec fail. I'm going to say that this should be equal to an empty string. So I'll save, and okay, nice good error. That means that our test is running at least somewhat appropriately. Okay, cool. So as we've seen inside this section, whenever we save some amount of data to a user now, if we provide a post property, this will be automatically nested inside of the user. Now, we've embedded a post inside of a user, but this hasn't really gained us any special behavior just yet, right? Like, as I've said many times, we can arbitrarily add in other properties on a user model. There's no enforcement by my user schema on the properties that do or do not exist on the user model, except for the ones where I've added some validation. So what I mean by that is, we can add in as many arbitrary properties on here as we want. So I can add in ASDF equals 1, 2, 3, 4, 5, 6, whatever I want it to be. So what do we really gain by making this clear association between a user and a list of posts? Let's continue the next section and see how we can now make use of this subdocument idea to get a couple better properties or better features out of Mongoose. So let's continue the next section and see exactly how that works. In the last section, we saw how we could create a document that had an embedded subdocument inside of it. We will look at some of the advanced features or advanced ideas around subdocuments, but really quick, I realized that we're kind of missing one thing here. We've seen how we can create a new user that has a list of posts embedded inside of it at the exact time that we create the user, but we haven't really figured out how do we actually add subdocuments to an existing records that has been saved to our collection. So in theory, once a user inside of an imaginary web application that we haven't built yet has been created, maybe over time they want to come back and add some more posts, right? Totally makes sense. So we need to figure out some way in which we can take an existing saved user and then add in some new documents into their subdocument collection of posts. So I think that maybe a good use of time would be to write another test and figure out exactly how we add or remove subdocuments inside of a user model. So we'll start off first by adding new posts to an existing user. So let's write out the shell of a test, and then we'll figure out exactly how we're going to approach it. So we'll say it can add subdocuments to an existing record. Now we'll certainly have a lot of asynchronous code in here, so remember our done callback. So now we need to think about exactly how we want to test this. This is going to be a little bit more involved test sequence than a lot of the existing tests that we've made so far. In theory, we kind of want to create a record, save it, then pull it out of our database, add a post to it, and then make sure that the post actually gets saved appropriately. So let's take a look at a diagram that's going to help us understand the exact order of operations. So yeah, this is going to be a little bit nasty when you look at this diagram. Our goal is going to be to create an instance of Joe and save him to the database. We'll then fetch Joe from Mongo. We'll add a post to him. We will then save that updated model, the one that now has a post attached to it. We'll then fetch Joe back out of the database, and finally we'll make an assertion. So we're going to have a little bit of extra work inside of here where we're going to not only create Joe, save him, fetch him, which is what we've been doing many times so far, but we're also going to make another update to him, save him, and fetch him again. So this is going to be some more advanced use of promises inside of this test, without a doubt. The one thing that I want to tell you about subdocuments right now, and this is something that we're going to see in practice quite a bit, is that you can only save subdocuments inside of a parent model by adding it to the parent, which for us is the user. Here, let's see a better diagram here. Okay, this is better. The only way that we can save a subdocument inside of a user is by first adding that subdocument and then calling save on the model itself, so on the user. Even though we created a post schema, we do not have a post model. So there's no idea of kind of like embedding a post inside of a user and then saving just the post. We can't save just the post by itself. We have to save the entire user. So we'll see that in practice as soon as we start working on this test. But I just want to mention it ahead of time because that's a very common question to have. Okay, so let's go back to our test. So we know that we first need to create a user Joe and save him. So we've done that many times. Let's get started with that. I'll say const Joe is a new user. I'll give him a name of Joe, and then I'm going to initialize their list of posts to an empty array. Now I don't actually have to do this right here. I don't actually have to initialize posts to be an empty array. The reason I'm doing this is just for the purposes of our test. I want any engineer who is reading this test in the future to be 100% clear that, okay, Joe is starting off with a specifically empty array of posts. So now we can save Joe. So we'll say joe.save, and then we'll fetch him from our database. So we'll say user find one, and just grab me Joe. So as we've seen many times so far with our promises, when this query right here runs, if we chain on another .then, this callback or this .then will be called with the result of user find one. So we'll get a function here that is called with the user that gets fetched. The reason I'm reiterating that is because we're going to add on a lot of .thens inside of here, and so it really pays to address a little bit of extra attention to the return value or the argument that's passed into each of these subsequent .thens. So we have now saved Joe. We fetched Joe. Let's take a look at our diagram just to make sure we're going down the right path here. We created Joe, saved him, fetched him. So now we want to add a new post to Joe. So this is where the real, heart of what we're trying to accomplish inside this test comes into play. To add a new record inside of a subdocument collection, we will say user.posts, which is an array, right? Like we've seen that so far. This is going to be an array, and we will push a new record inside of there. We're going to push in a new post with a title of new post. So the magic here is that there's really no magic at all. Array push is a very common JavaScript operation. This is like something that you'll probably learn on day 1 or 2 of picking up JavaScript. When you want to add an element to an existing array of records, you can say array.push and then pass in the record or whatever item it is that you want to append to your array. And so we are making use of existing JavaScript conventions here by saying, okay, we've got a list of posts already. I want to just push a new record inside of there. Just pushing this new record inside of that list of posts, however, does not actually save the record. So just because we were adding in this new post to this list of posts, this doesn't actually get reflected into our database. Remember, the only way that we can save a record is by calling user.save. So I'm going to call user.save. And with this right here, this will recognize that, okay, we have added in a new post to our list of posts. We need to persist that to our database. So if we look at our diagram now, we have added a post to Joe, we have saved Joe, and now we need to fetch him again and then make the assertion. Now the one gotcha inside of here, we're going to go back to talking about promises a little bit. Remember that with fat arrow functions, which is what we have right here, if we omit the curly braces, like so, we get, or if we do not have these, just to be clear, which is what I just had before, we get an implicit return of whatever is inside of the arrow function. So what I mean by that is what we are looking at right here is equal and equivalent to doing return user find one and placing some curly braces around it. This return right here, like actually returning the promise that find one generates, is what makes this dot then right here actually work. Okay, so because we are returning the promise, we can chain on the dot then and everybody's happy. So just to be clear, that's why we're using a fat arrow here without any curly braces or anything like that. The same thing is applicable with this user.save. So we're now using curly braces in here, which means we do not get an automatic return statement out of this function. But we still want to chain on another dot then to this overall promise structure right here to make sure that we get a callback whenever the user is successfully saved. So because of that, because I have to return a promise from this thing if I want to chain on another result, I will say return.save, user.save. So now that I'm returning this promise right here, I can add on another dot then that will only be called once the user has been successfully saved. So now, inside of another callback, we can pull out the user that was just saved one last time. So here's my find one. Oops, let's do, there we go. And then after the user is again pulled out of our database, we can finally make an assertion about them. So this will be called with the user that just got pulled out. So now this user right here, I would expect to have access to exactly one post inside of its collection of posts, and it should have a title of new post. So we can write in another assertion. Assert user posts at 0 dot title. We'll have a title of new post. And finally, we can call our done. All right, so this was definitely a much more fancy little bit of test setup here. Let's check out our terminal and make sure that our tests are actually running. Okay, 18 passing, definitely looks good. If I delete new out of here, I can save, and fantastic. Okay, so it looks like everything is, we got a reasonable feeling that everything is running properly. So again, the magic inside of this assertion right here was that we wanted to do a series of operations, and we did it by chaining on a bunch of promises with each other. One of the big curveballs here was that inside of this second dot then, we wanted to make sure that the subsequent dot then was only called after the save operation was successfully done. Because we were using a fat arrow function with curly braces, we did not get an implicit or automatic return of user.save, so we had to add in the return statement right here. Just to reiterate on that point one more time, all the other locations where we've been using user.findOne without any curly braces, that means that the find1 statement was automatically getting returned for us, and so the subsequent dot then was waiting for the find1 operation to wrap up. The last big thing that I want to say about adding subdocuments to an existing record is just a reminder, when we push a new record into this collection or list of posts right here, we have to save the user, the entire user, in order for that post to be saved. There's no such thing as saying like, oh, just find this one single post inside of here and call .save on it. That doesn't work. We have to save the entire record and send it off to our database. Okay, so we've now seen how we add subdocuments to an existing collection. Just for posterity's sake, I would really like to go through the process of removing a record as well, a subdocument. In practice, it's going to look basically identical to what we've got right here, but I think that our test suite and all these examples would be really more complete by adding in the process of removing a document as well. So let's continue the next section and get on top of removing a record. It's going to look a lot, very similar to what we did just right here, so we should be able to get through it pretty quickly. So let's take a quick break and then tackle removing subdocuments. In the last section, we walked through the process of adding subdocuments to an existing record. In this section, we're going to do the exact opposite. We're going to create a record that already has a post embedded inside of it, and then we'll figure out how to remove that post. It's going to look in practice quite similar, at least for the testing setup, to the saving or adding a post to an existing user, but there is one big major difference this time around, and so I do want to go through the process. We will get through it pretty quickly though, because a lot of the test setup is going to look pretty gosh darn similar. So let's go ahead and get started. Beneath our existing it statement, I'll add in a new one, and we'll give this one a description of it can remove an existing subdocument. Then we will add in our function with a done callback. So this time around, we want to create a user that has an existing post. We'll save it, we'll fetch it out of the database, we'll remove that subdocument, save it again, pull the user out again, and make an assertion about it. So in practice, nearly identical to what we've got up here, but the big difference will be that this push, instead of pushing on a new record, we want to subtract or remove a record out. All right, so let's get started. We'll start up our Joe model. So new user, give him a name of Joe. And for our list or embedded collection of posts, we'll start them off with one post that has a title of new title. Now we can save Joe to Mongo. So we'll say joe.save. And this is where a lot of the code inside of here is going to start looking pretty darn similar to what we have up here. So we'll save Joe. We will then fetch him out. Name of Joe. Then we'll add in another callback that will get called with the user that we just pulled out. So now inside of here, this is where we're going to want to remove that embedded document. Now, when we added an embedded document, we used some very classic JavaScript function in here, array.push, to add in this new record. So you might be thinking, okay, well, there's got to be, we can use slice or splice to pull a record out of an existing array. Well, we definitely can, but Mongoose recognizes that the use of splice is kind of a pain in the rear. Let's imagine for a second that we had a bunch of different records inside of this post collection or this post subdocument collection. We would have to kind of like walk through that list and find a very particular record that we wanted to pull out. And then, it's such a pain in the rear. I don't know if you've ever done this with JavaScript, but you got to find the index of the record that you want to remove and then call array.splice with that index, pull it out, blah, 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 all that kind of painful stuff. Long story short, it's kind of a pain using raw JavaScript to remove elements out of an array. So Mongoose recognizes that that's a pain, and it gives us a little bit of an alternative API for removing a record out of a nested collection of records. So this alternative API, all we have to do is look at our list of posts. We will directly access the post that we want to remove, and then we'll call remove on it. That's it. So just to be really clear, I'm going to rewrite this statement right here in a different fashion, just to make sure that it's really clear what's going on. I'm going to say const post is user.post at 0. So this is my singular post, the one with new title of new title, and I want to remove it. So I'll say post.remove, like so. So I'm calling remove on the post itself, not like actually on the user or anything like that. So this is a little bit of magic that's injected by Mongoose. You'll notice that again, we're not looking at the array of posts and splicing out or filtering out a record. Now, just like adding a subdocument where we modified the list of posts and then we had to save the overall user, the exact same thing is true here as well. So just calling remove right here, that does not actually save the record for us automatically, which is distinctly different from a lot of other code that we've seen. For example, so we'll say don't write this. Just to be clear, don't add this code in. We've seen previously that we can remove a record out of a Mongoose collection by saying like, user.remove, or more particularly joe.remove. When we called this, it made an actual request or operation on the database. When we remove a subdocument, however, the same is not true. It does not automatically save our record off to Mongoose, or off to Mongo. It just removes it out of the subdocument collection of posts, and the user is still kind of dangling there and just kind of like sitting there and be like, all right, well, my list of posts changed, but I guess I don't really have to do anything about that. So after we remove a subdocument out of a nested collection like this, we still have to manually call save on the parent record, which is the user for us. So we're still going to say return user.save. In practice, this ends up giving it a somewhat similar API to the process we use to add a subdocument. Remember up here, we had said, okay, push on this new record, and then we explicitly said user.save. Now in this case up here, it wasn't really a stretch of the imagination to understand that, okay, yeah, we got to call user.save. In this case down here with remove, yeah, it's a little bit more of a pain to have to remember that we have to save the user, just because, again, we saw stuff earlier like joe.remove, and that made an actual operation on the database. Okay, so in theory, this will remove the post. Let's now fetch the user, fetch Joe out of our database, and make an assertion about them. So I'll add on another .then, and inside of here, we'll do another find one to find Joe. And then we'll add on our last .then with the user. And inside of here, I want to assert that my list of posts is now empty. So I'll say user.posts.length is equal to 0. And then I'll call my done callback. One thing that I want to mention about these big promise chains, a very common typo to make is if you put on a semicolon like right there, and then you don't quite recognize it. Do make sure that whenever you're chaining on all these .thens, that you've only got a semicolon on the very last then. Because essentially what you're saying when you put on the semicolon right here is this is one statement right here, and then you're left with kind of like this dangling statement that is definitely going to throw an error whenever your Node.js or Mocha tries to run this code. So do watch those semicolons. Okay, so I think that we're ready to give this a shot, run our tests. So I'm going to save it, flip over to my terminal, and okay, fantastic. 19 tests, passing as usual. We will change the assertion in here to make it break. And yep, looks good. So I'm going to change it back to 0, and we are left with some very nice running tests. Okay, so at this point in time, we have seen how we add subdocuments, how we remove subdocuments. So I think maybe now would be a good time to talk a little bit more about some other stuff that's going on with subdocuments. Let's take a quick break and then continue in the next section. We've now gotten a little bit of a taste of how subdocuments work, but I want to point out a little bit of an issue that we've now introduced into our application. Maybe issue isn't the best word, but something that doesn't quite make sense. I'm going to open up my user model. So here it is. I'm going to find my user schema, and I'm going to scroll down a little bit to my post count and post properties. So post count right now is a number, and it's supposed to reflect the number of posts that a user has. So we've got the list of posts, here it is. But you'll notice that it's really up to us, the developer, to keep track of both post count and posts. So even though in all of our subdocument test files, we've been adding in, list of posts, blah, 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 at any point in time when I'm adding in another post in here, if I reference the post count property somewhere in here, chances are I'm going to get the incorrect result, right? Because I'm not manually incrementing the post count at any point in time. So our code doesn't quite work too well in relating the value of post count to the number of posts that are actually stored inside this user. So maybe we need to come up with a better solution to this. So this is a diagram of what our user model looks like right now. As you well know, we have a name property, posts, and post count. So in this diagram, we might have 3 different posts inside of here, but the post count is completely separate and not tied to the actual number of posts inside here at all. So clearly, it'd be really nice to have some better solution here, something where this value of post count kind of looks at the number of posts and then returns however many posts there are inside of this array. To do so, we're going to use an idea called virtual types inside of Mongoose. A virtual type is any field on a model, so like post count in our case, that does not actually get persisted over to our MongoDB database. So what I'm suggesting is that rather than storing both a posts and post count property inside of Mongo, we instead only designate or only define the post count property on our server where our Mongoose code is running. Then anytime that we try to access this post count property, we will calculate the number of posts we have by just looking at the length of this array, and then we'll return that number. So the term virtual type or virtual property or virtual field refers to any type of property that we have on our model that does not actually get saved over to our MongoDB database. Whenever you are thinking about a property on a model that is like a derivative or the product of two or more other properties, a fantastic solution is to start thinking about virtual types. So we're in definitely a classic use case of virtual types right now because our post count is very tightly coupled to the post property. You might say that it's like a derivative of the post property, or it's a computed field of the post property. Okay, so let's figure out how this thing works. We're going to follow the similar pattern that we've been going through all through this course so far by creating a new test file. And inside of that new test file, we'll write a little bit of code to figure out how these virtual types exactly behave. So in my test directory, I'll make a new file, and we'll call this virtual type test.js. And then inside of here, we will immediately place a little bit of our test boilerplate. So we'll say const assert is require assert. User is require source user. And then we will describe virtual types. Now for our first test, let's write something around making sure that we can fetch the correct post count. So I'm going to call the test something like, how about post count returns number of posts. And then as usual, I definitely expect this to be an async test, so I'll add in my done callback. Okay, so we've got some idea of how this thing should work. Let's try kind of flipping what we usually do inside of all of our examples so far, where we first write out the implementation and then write in a test. This time around, let's first write the test, and then we'll go and update our code and make the test pass. So we're going to do a little bit more of a test-driven development approach here. So the post count returns number of posts test that we're going to write inside of here essentially is going to work the way you expect. We're going to define a user, we'll save them, we'll fetch them out of the database, and then we'll look at the post count property and we will expect it to be basically the correct value. Okay. So I'm going to create a new user model of Joe. Let's say he's going to be a user. I'm going to give him a name of Joe, and then I'm going to give him a post. So I'm going to say posts is going to be an array with one post inside of it. So at this point in time, with the code as is, I've not actually made any changes to my user model or my user schema so far. If I said joe.postCount, I would expect to get back like 0 or null or undefined. Basically, we haven't touched this property at all. We haven't touched the post count, so I'm going to expect this thing to be some like undefined value essentially. But we have defined a post in the post collection inside of here. So if our model was behaving the correct way, I would definitely expect post count to be 1, right? That is what we want it to be. But at this point in time, post count is definitely who knows what. So let's save Joe. We'll then fetch him out of our user collection. So we'll say find1 with the name of Joe. And then we're going to look at the user that was fetched, and I want to specifically look at Joe's post count property. So we'll say assert joe.postCount. So what do you think post count should be? Well, we definitely know like what it probably is right now and what we want it to be. So we're going to write out the test to assert what we want post count to be. We definitely want post count to be 1, just because we have one post in the post array. So we will assert that post count is 1, and then we'll call our done callback. Okay, so this definitely looks like a reasonable test as we've laid everything out right here. At this point, you might be wondering, hey Stephen, why are we like even saving this model? Like, what's the purpose of that? Well, there isn't quite a purpose here. We could just as well test how this post count thing works without actually saving it to the database. I am saving it to the database and then fetching it out just to give you a very realistic example of how you will probably work with these models in the wild. So it is much more common, or I shouldn't say much more common, but it is extremely likely that at some point in time, you are going to create a model of some type, save it to the database, there we go. And then maybe like 5 days later or something like that, you will pull the model out and then try to access some virtual property on it. So for the purpose of our test, we don't really have to save this and then fetch out of the database. I am just doing so to give you a very realistic example of how this thing actually works. Okay, so we have written a test of how we want post count to behave. If we check our terminal, yep, looks like we got a test that's passing. So clearly this thing is not working, or excuse me, not passing. So clearly this is not working as we expect right now. Let's continue in the next section and try to get our test to pass by defining a virtual type on our user schema. In the last section, we wrote out a test for our virtual property of post count. In this section, we're going to flip back over to our user schema and try to make this test pass. So right now it's failing, and we definitely want to fix it up so it'll actually pass. I'm going to start off by flipping back over to our user.js model. So inside of here, we already have a property on our user schema called post count, and that's supposed to be a number. So what I am saying here is that we no longer want to have a post count property that gets saved off to our database. Instead, we want to, on the fly, figure out what the post count value should be. So anytime that we are using a virtual property or something that should be computed on the fly, we will not define this property inside of our schema. So I'm going to take this property and I'm going to delete it. So we're not going to have it anymore. Now, the instant I do that, we start getting into a little bit of quandary inside of our project here. If you recall, we were using that post count property back inside of our update test file. So I'm going to open update test. So inside of here, we had that post count property. Here it is right here inside the before each. And then if we scroll down a little bit, we can find the test that we wrote where we were testing the post count with the increment operator. So we can no longer use this increment operator with this post count thing because we don't really, we want to remove the idea of saving this post count to our database. So this test that we have right here is no longer valid. It doesn't really make sense anymore. I still want to have an example inside of our entire test suite of the increment operator, however. So I'm not going to delete this test just yet. I think that what a good strategy would be to do is maybe we will introduce a new property besides post count, and we will come back in a little bit and fix this test up. So I still want to have a test around increment, but post count isn't going to work anymore because post count isn't being saved to the database. So we'll just bench this test for now, come back later on. To make sure that our test suite is not ran with this test, we don't want to have a failure popping up. We can just omit this test being ran whenever Mocha runs by changing it right here into X it, like so. So by adding an X in front of the it right here, Mocha will interpret this as meaning, okay, it looks like they've got a test here, but I guess they're probably still doing a little bit of work on it, so I'm not going to execute this test. So by putting the X in there, the test won't run and we won't see any failures pop up, which is definitely what we want to have happen for right now. Okay, so back to our virtual property. We've now deleted the schema key of post count inside of here, and so it's now time to define our virtual property. To do so, we're going to add a couple of new lines underneath the user schema, and then inside of here, we'll say, look at my user schema. I want to add a virtual property called post count. So the thing that you're going to recognize here or notice really quickly is that we are not defining a virtual property inside of our user schema. We add all of these virtual properties as separate declarations on the user schema. By calling virtual, we are telling Mongoose that we want to define a virtual field. Okay, so we just call this with post count, and that tells our user schema, okay, we expect there to be a virtual field somewhere, but we still have to tell it what to do whenever a user actually accesses this thing. To set a function on this thing, or to kind of define this virtual property, we are going to chain on another statement, a .get. And I'm going to pass into this thing a function. I'm going to specifically use the function keyword. So this is really important. Notice that I'm using the function keyword right here. I'm not using a fat arrow function. So let's put it on our semicolon. All right, so this looks good. I'm going to save this file. I want to talk a little bit about two topics. First, I want to talk about exactly what this kind of get right here is implying, or what it's going to do for us. And then I want to talk about this function, why I'm passing in a function keyword instead of a fat arrow function. I'm going to flip over to a diagram really quick to help understand exactly what we're doing when we define this get thing on this virtual property. These virtual properties work by using the getter and setter features of ES6. Whenever we define a getter with a virtual property, which is what we're doing right now, we can then reference a property on our model like joe.postCount. Whenever we reference joe.postCount, something is going to happen that is very dissimilar from the type of JavaScript that we're used to. So with JavaScript that we are really used to, whenever we say joe.postCount, JavaScript is going to look at the object Joe, it's going to look at the property postCount, and it's just going to say, okay, here it is, here's whatever's on that property. When we define a getter, however, the behavior is a little bit different. So when we define a getter on Joe for postCount, whenever we reference joe.postCount, instead of just giving us back the value of postCount, Mongoose and JavaScript are going to work together to very quickly run a function that we define. Inside that function, we will return some computed value, and then that result that we return will be returned, or basically produced by joe.postCount. So what I'm kind of getting at here, the big confusion, the big kind of crazy thing that we're not going to be used to, is that when we refer to joe.postCount, we are going to be running a function, even though we did not actually add in any parentheses or anything like that. So I would like to define this getter on here, and then figure out, I want to do a quick test on this thing at the command line without any tests or anything like that, just to kind of get a better feel of how that works. So let's take a quick break. We'll come back, add in some logic to our get function right here, and then we're going to test it out at the command line. So I'll see you in just a second. In the last section, we defined our virtual field of postCount and then assigned this getter property to it, or we called this getter property is what I really should say. I then started to talk a little bit about, well, when we're referencing joe.postCount, we're not actually just grabbing this property, we're actually kind of running a function or something like that. I don't know, a bunch of confusing stuff. So let's write a little bit of code and get a little bit more familiar with how this thing works by running this code at the console manually. Inside of this get function, or the function that we pass to get, I'm going to just add in a console log. So I want to add something and just say hi, like so. Okay. So let's run our code at the terminal, and then we're going to just kind of see how this whole virtual property thing works. So I'm going to flip over to my terminal, and inside of my project directory, I'm going to run the command node. Okay, so this is going to start up my node shell. And inside of here, we can write any amount of arbitrary JavaScript that we want. So I can say 1 + 1 and get back 2. So inside of this node shell, I want to require in our user model. I want to create a new user, and then I just want to kind of play around with it a little bit and see how this postCount virtual field works. So first, I'm going to require in the user model. So I will say const user equals require source user. Notice that this require right here is assuming that I started up my node shell while in my users directory. So make sure that you started up your node shell while in users, or your project directory. You might have named it something different. And once you're in there, you can do the require source user. So I'll run this right here, and that will require in user and assign it to user. So right now my user, capital U user variable, is my actual Mongoose model. If you ran that command right there, the require statement, and you got an error with the require, that means that you probably didn't run your node shell, the node command right here, from the correct directory. So make sure that you're running it from your project directory. Okay, so now that we've got our user model required in, we're going to create a new user object. So I'm going to say Joe equals new user, like so. And we're not going to give him any properties right now. We're just going to require Joe in. So now I'm going to reference joe.postCount. So when I run this, it's going to look like I'm just trying to print out a variable, right? Like I just want to see what exists on the property post count. But because we have defined a virtual field of post count that has a getter assigned to it, rather than giving us the just like straight up raw value of post count right here, this function is going to execute instead. And so when we access post count, we should see a console log of hi pop up. So let's run this. And okay, well, that's definitely not good. Oh, boy, that's a bad typo. Jost. All right. Joe.postCount. My bad. You got to understand, like, talking and typing, sometimes it's a little bit challenging. Okay. So anyways, Joe.postCount. There's our big console log of hi. So clearly there is some real big magic inside of here. So this is definitely at odds with stuff like, when we access our ID, or if we had a name, which we don't have, where we just kind of like look at this property and just dump the value out. Post count is now a virtual field. And so when we reference post count, we run a function, and whatever gets returned from that function will get logged out. So let's now try to enhance our getter inside of here a little bit. The next thing I want you to think about is when we run this function right here, we need to somehow get access to our list of posts sitting on the user model. So how are we going to like actually reference a user, like the particular user, and figure out what posts they have? Well, I'm going to add in a statement in here. I'm going to say just return this. Okay, it's going to say return this. So let's now test this at the shell again and see exactly what's going on. So I'm going to stop my shell entirely. I'm going to run node again. And I'm going to define users again. I'll say require source user. And I assign that to users. Really, it should just be user. So I'm going to require it in again. Okay, so I've now got user again. I'll make Joe once again. I'll say Joe is a new user. And now again, I'm going to reference joe.postCount. So now when I run this, that's interesting. When I run this, I get back just the same properties that exist on Joe. So here's the real magic behind this getter. Besides the fact that, it's a fancy function that runs whenever you reference the property. If we want to access any of the properties that exist on a particular user, so like in this case, I want to look at this post list right here that exists on Joe, right? I want to look at joe.posts. We can reference this. So instead of saying joe.posts inside of here, I could say this.posts. This will refer to the instance of the model that we're working on. So let's update this now to this.post.length. And now when we reference this right here, it should return the number of posts that are associated with a given model instance. As a quick aside, this whole system right here of referring to this to get access to the current instance of the model is why we use the keyword function here instead of a fat arrow function. If we use a fat arrow function like so, the context or the value of this is going to be bound to this whole file right here. And so this will not refer to the instance of the user model. It will be like, this whole file right here, whatever is equal to this outside here. So this is one of the very rare cases in which you do not want to use a fat arrow function. Definitely want to make sure we use a keyword function so the value of this does not get clobbered. Okay, so let's save this and we'll do one more test, just one last time to make sure everything is working the way we expect. So I'm going to end my node shell with Control-C. I'll start it back up again. We'll say user is require source user. We'll make Joe again. And this time around, I'm going to give him a single post. So I'll give him a title of ASDF. What the heck? So here's Joe. Joe now has a post associated with him. And so this time around, when I reference joe.postCount, I end up getting back 1. Because when I reference joe.postCount, this inner function runs right here. This is equal to Joe. We reference joe.posts.length and we get back 1. Okay, so that's pretty much virtual fields in a nutshell. Let's kill our terminal here, or our shell. Let's flip back over to our test file now, and I kind of expect my test to run now. So I'm going to start up my tests again with npm run test, and let's see how we're doing. So now my tests are passing successfully. So it looks like we are successfully pulling out the number of posts by looking directly at the list or the list of posts in that subdocument array. You'll also notice I've now got one pending test in here as well because we kind of temporarily X'd out that one test inside of our update file. Okay, so this is definitely looking good. We've got a better handle on virtual fields with getters. Let's continue in the next section and we'll flip over to our update test file and see if we can't make another kind of reasonable update to our test where we were previously asserting our post count was being incremented. So let's tackle that in the next section. In the last section, we learned more about virtual types, but in the process, we also broke one of our tests around updating records. So here's my update test file, and if I scroll down to the bottom, you'll see that we had X'd out one of our tests that had to do with using the increment operator with post count. So because our post count is now a virtual field, this test won't work the way we really expect. I still want to have a good working example of post count, however, so I'm going to suggest that maybe we add in another property to our user model and update our test to work with that new property. So I'm going to flip over to my user model. Here it is right here. And I'm going to add in a new property, and we're going to call this one likes. We're going to say it's supposed to be a number. The idea behind likes is maybe a user gets some number of likes from other users. So once a user gets liked, we'll add 1 to their number of likes. So we'll probably start off with a default of 0, and over time, as the user gets more popular, they'll just get more likes. So now that we have the idea of likes, let's update our test to work with likes. I'm going to start off by removing the X from before it on here. So now this test will actually run. I will then update my post count to likes. So it's going to start off, or the purpose of update right here is going to increment my number of likes by 10. And then we're going to assert that user.likes is equal to 10. Now we need to make sure that we actually default our likes to 0, and we did so up at the very top inside of our before each statement. So I'm going to find my before each, here it is, and I'll update post count to likes, like so. Okay, so let's check out our tests, and it looks like everything's passing. I am going to go through my well-practiced practice, so to speak, of making the test break. So I'm going to say that I expect user likes to be 0, and yep, looks like we got a good failure in there. And so I'll change it back to 10. Okay, so this looks good. Again, I just wanted to update this test to make sure that you have a standing good example of using the increment operator on a number field. So let's continue in the next section and talk about a couple more topics on virtual fields. We've now gotten some level of familiarity with the common operations using Mongoose. So we've gone through all of our CRUD resources. We've spoken about validation, subdocuments, and virtual fields. Definitely all core concepts in the world of Mongoose. In this section, we're going to move on a little bit and start talking a little bit about how we design large MongoDB databases. So at this point, we really just have a collection of users, and that's it, like basically nothing else. Yeah, users can have posts embedded inside of them, but in general, there's not really a lot of data or a lot of relationships floating around here. So in this section, we're going to start to think about some of the different ways that we could have designed this user schema. So what we have right here, it definitely works. It's 100% valid, but there are definitely some shortcomings that are going to arise by embedding posts inside of a user. So let's talk about what some of those shortcomings would be. I'm going to flip over to a mockup for an application that we might build by using the user schema that we just set up. So in this web application that we can kind of imagine, we're looking at a list of blog posts, or just like a list of posts, like the same type of posts that we are storing on a user model right now. Every single post has a title, which is reflected on the left-hand side, and then the author or owner of the post is reflected on the right-hand side. So we certainly have enough data right now to produce a screen that looks like this, right? We definitely have a list of users that we can fetch from our database, and we definitely have some number of blog posts that belong to each of our users. But I'm going to make the claim that maybe the schema that we've set up would not make this type of display right here the easiest thing in the world to put together. And here's why. I want you to think for a minute about the type of query that we would have to write to get some list of blog posts belonging to multiple users on the screen. So the key here, like the real wild card I'm throwing in the equation, is I'm saying that specifically I want to have posts from different users on this one screen. We might end up writing a query that looks something like this. Something where we say, okay, find a list of users, or just like get all my users out of my users collection. And then for each user, grab their list of posts and assemble them into a single list of posts. That's what this flat map is doing right here. You can kind of imagine that this middle line right here is just grabbing all of the posts from each of these users that we've just fetched. And so that would eventually produce an array or a list of a bunch of different posts that we could show to our user or whoever's actually using our web application. So here's the reason that this would be a little bit of a pain to take this approach right here. First off, when we build this list of blog posts to show to our user, we probably don't want to show an infinite list, right? We probably just want to show specifically like a list of just 10 posts or 20 or 30 or 40 or 50 or something like that. We want to show just a finite list of posts. And we probably want to make sure that it is a round, even number so that when a user comes to our site, they're always guaranteed to see exactly 10 posts appear on the screen. With this type of query that we have right here, fetching exactly 10 posts is surprisingly challenging. If we go and find every single user inside of our database, well then sure, we're probably guaranteed to, depending on the size of our application and how many users have signed up, maybe we're going to get like many blog posts, way more than we would ever want. Maybe we get like 1,000 posts out of this. And so we'd want to tame that query down a little bit, right? We would want to make sure that we don't get 1,000 posts. So maybe we find some way to limit the number of users that we find at a given point in time to just like 20. So just give me 20 users, let's take all their blog posts and then try to get a total of 10 out of those users. So even if we found a way to limit the number of users that we fetched, even if we just said, just give me like 20 users out of the database, we would still run into an issue where, well, what would happen if those 20 users that we fetched hadn't written any blog posts at all? Then our code right here would be producing a list of no posts. So essentially what I'm trying to get at here is that when we nest our blog posts inside of the user model, getting access to a bulk list of all of the posts that we have starts to get really challenging. It starts to get definitely harder than it has to be. The upside to the schema that we've put together, because I don't want to downplay any of the upsides, is that finding all of the posts associated with a very particular user is very straightforward. So if I had changed up this mock-up over here and said, I only want to ever see all the posts by a single user, like only show me posts by Alex, all of a sudden the schema that we put together works really well because we can just find our user of Alex and then render all the different posts that they have onto an HTML document. So certainly there's some upsides and some downsides to this approach when it comes to listing off nested documents. Let's continue the next section, and we're going to talk about one of the other differences or kind of challenges that we might have by using this nested blog post or this nested post approach inside an imaginary application. In the last section, we spoke about some of the challenges that we would run into if we used nested posts as our primary data structure inside of our database. I didn't really suggest any alternative to this, but we're going to continue on this next section and see maybe there's a better way to handle this. Or maybe not necessarily a better way, but a way that's going to make operations like this a little bit easier on ourselves. I want to look at another mock-up for a potential application that we might make. We're going to imagine that maybe our user looks at a list of posts and then they click on a particular one. So like they click on Life with JavaScript. When they click on that, maybe we'd take them to a screen like this, where we show the title of a post, some content in the post. Keep in mind that right now we're not actually recording any blog post content, but we certainly could. And then I've taken the liberty of saying that maybe we'd want to have the ability for users to comment on posts inside our application. So we have not introduced the ability for users to comment inside of our application at all just yet. But I want to, in this section, just think about how we would implement that with this type of nested data structure. The real challenge in this nested, if we started to nest comments somewhere, is figuring out exactly, well, how would we deal with recording who made a particular comment? Right now, it's really easy for us to keep track of who makes a blog post because every blog post is nested inside of a user. And so we just look at the user that the blog post is sitting in, and hey, that's who wrote it. But if we want to then nest comments inside of a blog post, but those are supposed to belong to a different user, wow, okay, this is definitely starting to get a little bit complicated. Let's start thinking about where we might pull each of these pieces of information out of our current schema. So here's one possible approach. Maybe for the author, we could say like user.name. Okay, that would definitely give me Joe. If we're looking at a particular blog post, maybe to get the title, we would be referencing user posts at 0.title, and some content would be like, mystery content property. But then when we get down to the comments down here, yeah, this is definitely more challenging. How exactly would we nest our comments in here? And the answer is that, well, this is really pushing the bounds of nesting data structures one in the other. Since we have all these, nested data structures with a lot of kind of built-in or implicit references, it would start to be really challenging to maintain all this stuff, and most importantly, write queries to efficiently find a lot of this data. For example, if we nested comments inside of posts, which were in turn nested inside of users, how would I ever write a query where I could get all of the comments that Amanda has ever made? Like, that starts to get just arbitrarily difficult, really, really hard. So I'm going to suggest maybe there's a better way to do this. So maybe instead of having a single collection of users where every user can have a nested collection of posts, of subdocuments, maybe we could instead, well, just to be 100%, sorry, got a little bit out of order here, but just to be 100% clear, this is kind of the, if we added in the idea of comments, maybe this is one way we could handle it. So maybe we could say that a user has posts, and a post has comments, and a comment had a content, something like that. But what I'm trying to get at, here we go. Here's what I'm looking for. So I'm going to suggest maybe a good way of solving this overall problem would be to break out 3 different types of collections inside of our application. Maybe we could have a collection of users, a collection of posts, and a collection of comments. A user, rather than having a nested subdocument collection of posts, could have an array of post IDs. So just the IDs of the posts that have been created. So then at any point in time, if we had a user and we wanted to find all the posts that belong to them, we could ask our post collection to give us the IDs that are contained within the post IDs property of a particular user. In addition, if we had a comment collection, we could then record all of the comments that belong to a particular post on a property comment IDs and record that on a post. So then if we wanted to know, okay, what are all the posts or what are all the comments that belong to this particular post, we could look at the comment IDs property and then pull off a list of all the different comments we have. And then finally, to figure out what comment was made by which users, each comment could record a user ID property, which points back at a user collection. This would definitely solve a tremendous number of our issues. It would make pulling an arbitrary number of posts, like just give me 10 arbitrary posts, the latest 10 posts or something like that, would start to get really straightforward. Finding a list of all the comments that a particular user has made would also get really straightforward. The downside to this approach, however, is that now that we have 3 separate collections, our queries are going to get a little bit more painful because we're going to have to first find, if I want to find all of the posts that a user has made, I would have to touch the database one time to pull out a particular user, like user Joe. I would then look at all the different post IDs they have, and then I would dive back into the database again to fetch all the posts out of there as well. So definitely things start to get, pros and cons. It's really a balancing act. One thing I want to mention in particular about a new NoSQL approach with this right here compared to a traditional relational database. If you have any previous experience with a relational database, you might look at this and say, aha, a table of users, a table of posts, and a table of comments. Well, yeah, it definitely is similar to that type of architecture, to that type of structure. But using MongoDB exclusively in this type of fashion or trying to emulate a relational database starts to get you in hot water really quick for that last reason that I just described. We don't have single operation joins inside of Mongo. So unlike a real-time database where we could very easily in a single query say, give me a user, and then look at the post collection and give me all the related posts to that user, you can achieve that with a single query inside of a MySQL or Postgres database, but we can't really do the same thing with NoSQL or MongoDB. Definitely gets a little bit more challenging. Okay, so lots of talking, lots of lecturing. What I'm trying to communicate here, or the end takeaway of all this, is that nesting records definitely has its places. And there are definitely some legitimate use cases for taking that kind of approach. However, there are also some problems or some challenges that are just really hard to approach or solve when we take that nested document approach. Most explicitly, stuff like this. Just, hey, give me a list of all my posts. Yeah, that's kind of hard. That's not the easiest thing in the world. On the flip side, if we flip out to always using separate collections, then we start to have to worry a little bit about performance concerns, because to do these equally trivial or simple operations, we have to start touching our database multiple times just to fetch out some relatively simple amount of data. So let's continue the next section, and we're going to start thinking about how we might do a little bit of a refactor to our test suite right now to satisfy this type of multi-collections setup. In the last section, we spoke about refactoring our single user collection or our user model into separate user, post, and comment collections. And this would make some very common operations that we might want to take in a normal web app a lot more easy to undertake. The one thing I want to say about our refactor is that we already have a post property on our user model. So if we open up our user model right now, we've got this post, and it points at the post schema. And we've already got a bunch of tests around this behaving like a subdocument. Now, just because I don't want to lose any of that subdocument stuff that we've been working on, so just for the purposes of this app or this kind of test suite that we're putting together and making sure that you have a good project or a good code base to look at and reference in the future, I don't want to remove the existing subdocument posts that we've got already on here. And so I'm going to say that rather than creating a post collection, we will make specifically a blog post collection. Okay, so we're going to have both posts embedded on the user, and then separately we're also going to have this like blog post concept. So in our app, we're going to have both post and blog post. I know it's a little bit confusing, but again, I want to make sure that you've still got a really good working example of document embedding going on. So we're going to do this as a completely separate and different entity rather than posts. Okay, anyways, a little bit off topic there. Let's get started with a refactor to bring in the idea of both posts, comments, and users, blog posts, and comments into our application. So the first thing we'll do is we will make a new file inside of our source directory called blog post. We'll create a blog post model in here, and then we'll also make a new file called comment.js. And then we'll put a comment model inside of here as well. Remember, as soon as we create a model, models correspond to collections inside of our database. So we're going to create actual models here as opposed to our post file that we were working on earlier where we only created a schema. All right, so let's get started inside of our blog post file. We're going to start by first doing some imports at the top. We'll then define a schema, and then we'll assign that schema to our Mongoose object. So we will import Mongoose, or require it. We'll then grab the schema property off of it, like so. And then we'll define our blog post schema. And it's going to be a new schema. So we've seen this a couple times before. So now we need to think about the different properties that this thing might have. I think that a blog post will probably have a title of type string and maybe some content of type string. So let's do a title of string and some content of string as well. Now the last thing that we need to think about is how we are going to somehow connect this blog post to a user. In the diagram that we were just looking at, I said that a blog post would have a reference to look off to a comment, and a user would have a reference to look off to a blog post. Let's take a quick break and then come back and talk a little bit more about exactly how these references work. In the last section, we started working on our blog post model, And then we took a quick pause and we got to the point in time at which I said that we need to figure out how to reference one type of model from another model. So we've already seen how to tie together documents with a sub-document collection. And we did so inside of our user model. So inside of here, we had created a post schema, and we just said, hey, a user is going to have an array of posts. Each of those posts needs to follow the post schema. That was only applicable to when we set up a sub-document type of reference. Inside of our blog post, however, we want to have an actual reference to another collection. So the case of sub-documents versus referencing collections is a little bit different. I don't really have a great lead-in for this, so I think the best way to go is probably going to be to just add in the code, and then we'll talk about exactly what it's doing. So I'm going to add in a new key here. It's going to be comments. And then inside of it, we're going to, or for its value, we're going to place an array that's going to contain an object. And then this object will have a type of schema.types.object ID, and then also a ref property. And here I'm going to give myself just a little bit more space so you can read everything that's going on. For the ref property, we're going to assign it comment, like so. All right. So this vaguely looks similar to the post schema that we were just looking at inside of our user model. So here's the post schema right here. A blog post will have many comments associated with it. So we pass an array to indicate that we expect to have many different comments inside of this relation. Then inside of a configuration object, we specify the type of this reference, or the type that's going to sit inside of here. This type is going to point off to a record that is sitting in a different collection. So we are not nesting documents here. We are passing a reference off to another model or another document sitting in a comment collection. To indicate that we are going to pass a reference to a document in another collection, we say that we are going to have a type of object ID. We then also specify a ref of comment. Now the ref right here is a little bit interesting, and this is working very closely with Mongoose. Internally, when MongoDB stores this record, there will be an array of IDs here. That ID will eventually need to be kind of buttoned up and turn it into an actual Mongoose model, right? That's like eventually what we want to work with. To make sure that Mongoose understands what type or what collection it needs to look at to figure out where this ID belongs to, does this thing belong to a comment or a user or a post, or what is it? We assign this ref right here. The ref will be matched up against the model definition. So I'm going to flip back over to the user file and then scroll down a little bit. And if you recall, when we created our user, we told Mongoose that it was going to be receiving a new model that would be called user. So this user string right here is of the same kind of in the same vein as this ref right here, this comment. So because I'm specifying comment, this means that once we go over to our comment.js file and add in some configuration in here and create the comment model, that will be what Mongoose uses to populate each of the different comments that are going to sit inside this array. Okay, so we got that. The last thing we have to do after finishing up our blog post schema is declare the actual model. So we'll say const blog post equals mongoose.model, and this is going to be a blog post, and it's going to use the blog post schema. And finally at the bottom, we'll do all our module.exports equals blog post. Okay, so this is looking pretty good so far for our actual blog post. Let's flip over to our comment file and start putting in the schema for that as well. At the top, we'll go through some more of the boilerplate. So const mongoose equals require mongoose. We'll grab off the schema object, so mongoose.schema. And then we can create our comment schema. So with this equals new schema. I think that each of our comments will probably just have some amount of content which will be a string. So it'll have a content property. It doesn't really need a title or anything like that, just some amount of content. Then we need to make sure that we also provide a reference to the user who made this comment. So that's the ID here. We're going to, or idea, that's how we're going to record which user made each comment. We're going to have a reference to the author of this comment. Now you'll notice that in our blog post, we assigned the list of comments that belong to a particular blog post to a value, or a key, called comments. The key that we assign there, it can be anything that we want to call it. So this is especially relevant inside of our comment, because in a comment, we can either say, well, here's the user that this comment belongs to. It might also make sense to say that this was the author of the comment. It's really totally up to you which way you want to go. Personally, I like sticking with user because since there's probably only going to be one user associated with the comment, it's kind of reasonably implied that the user associated with this thing is probably going to be the author. But if I started having like, a user who wrote the comment and then maybe like another user who reviewed it or something like that, then I might do something like an author and a reviewer, and both of these would refer to a user. So this is when I would start to apply different terminology to the property. But we're going to stick with user because we only have one user who's going to be referenced here. Now for the user property, unlike the blog post where we could have many comments, and so we pointed it to an array, which indicated there could be many comments associated with the blog post, we will only have a single user associated with an actual comment. So rather than assigning an array to this, we're only going to assign an object, which is going to be a configuration object. So on here, we're going to specify the type, which will also be what we just saw a moment ago, schema.types.objectID. And then we'll also specify the ref. So whenever we specify the ref, we definitely want to triple check, really make sure that we're getting the name of the model correct. So if I go over to my user file, I'm inside the user file right now, and I scroll down to the bottom, when we register the user model with Mongoose, we called it lowercase user. So I'm going to make sure that I use that appropriate ref over here. So I'll say user like so. Then finally down at the bottom, we will register this thing with Mongoose. So I'll say const comment equals mongoose.model. This will be a comment, and this will use the comment schema. And then finally, we'll do our module exports for comment. Now, I did just introduce a very subtle bug in here having to do with the ref system. You'll notice that inside of this comment file, I used a string of lowercase comment, but over in my blog post, when I set up the ref, I used uppercase comment. And so that's definitely a mistake on my part. I need to make sure that I do the right thing here. So I'm going to replace the comment ref over here, and I'm going to make sure that it's a lowercase as well. It doesn't really matter which way you go, whether you use uppercase or lowercase, really doesn't matter. The only thing I recommend is that you stay consistent among all your different model files. So inside of my user file, I have lowercase user. In my blog post, I have lowercase blog post. And comment, lowercase comment. I think you get the idea. Okay, so we've now wired up both our blog post and our comment, and we've set up an association between the blog post and the comment and the user. The last thing we have to do is make sure that we somehow associate the user with the blog post. And once we do that, we will be in a great spot to start writing some tests and figure out how these different models are going to work together. In the last section, we set up our association between blog posts and comments and users, but we never actually associated a user with a collection or a list of different blog posts. So we need to make sure that we flip back to our user model and we tell the user model that it's going to have a list of blog posts that exist inside the blog post collection. So let's open up our user model. I'll find my schema. Here's the user schema right here. And I'm going to add on another property to this thing of blog posts. So I want to say it just one more time because I know it's a little bit confusing what we did here. We have both a post collection, or a post property. Let's get the terminology right. And a blog post property. We left the post property in here just so we can continue to have the idea of sub-documents inside our application, just to kind of leave that code example in here for future use. So now that we've got the blog post property, we're going to set up a association just like we did inside the blog post and the comment file. So we're going to say that every user will have a collection or a list of different blog posts associated with them. And inside of this, we'll set up a type of schema.types.objectID and also a ref. Don't forget the ref. This will be of type blog post. And again, I'm using the string blog post because that is how I associated my blog post inside of the blog post file, lowercase blog post. All right, so that's pretty much it for all the associations that we have to do. So now I think that we're ready to start writing some tests and kind of figure out how these different associations work together. So I'm going to open up my file browser here on the left-hand side, and I think I'm going to create a new file in my test directory, and I'm going to call this one association test. And we're going to test out how associations work with Mongoose. So let's put in some boilerplate at the top. We'll say const mongoose. Let's require mongoose. We'll pull in our user model. So we'll require src user. We're going to pull in our comment model from src comment. And then we'll pull in our blog post model from src blog post. So now we've got all three models inside of this test file. Remember that every one of these models corresponds to a collection that is going to sit inside of our MongoDB database. So let's add on a describe block of associations. And now we're ready to write some if statements inside of here and figure out how these things work. Now there's one little gotcha that we haven't quite taken care of just yet. If you recall, inside of our test helper, every single time before each test, we were reaching into our collection of users and dropping the entire collection of users. So don't forget that we have to do this same exact thing for all of our other collections as well, our collection of blog posts and our collection of comments. So we're going to just nest a couple of calls in here to drop all these different collections. And then after all the drop action is complete, we'll run our done callback. So as you might imagine, this is going to look a little bit ugly because we have to nest a couple callbacks inside of here. The one thing that we can do to kind of make this code look a little bit better is we can pull off references to our three different collections ahead of time, and that will kind of at least clean up this code a little bit. So we're going to use a little bit of ES6 code to do this. I'm going to say const users, comments, and blog posts equals mongoose.connection.collections. So again, just a little bit of ES6 code here. The ES6 code is going to look at this collections object, and it's going to try to pull off the users, comments, and blog post properties. Now that we've pulled off these properties, I can condense the existing drop statement to just users. Then inside of here, after we drop the entire collection of users, we can call comments.drop. And then once that's done, we can call blog posts.drop. So just basically drop everything. And at the end, we'll call done. Now, once you look at this, you might get the feeling, we're dropping three collections sequentially. That's probably going to take a little bit of time, isn't it? And the answer is, yeah, it definitely is. We are waiting for the entire users collection to drop, then the comments collection drop, and then the blog post collection to drop. So clearly this is something that is not super ideal. Let's continue the next section and maybe take another look at this and then flip on over to our association test and start writing our first test. So I'll see you in just a moment. In the last section, we started working on dropping each of the collections that we've created between every single test. And we ended the section by saying, gee, this doesn't really look like a great approach right here with this kind of callback of doom that we've got. Well, here's the downside, or here's the bad thing about this. Unfortunately, you cannot drop multiple collections inside of Mongo at the same time. And so it kind of leads us towards taking this like sequential approach where we drop each collection one at a time. Now, if you don't like this kind of callback of doom that we've got right here, we could definitely refactor this to loop over all the different collections we have. I'll leave it up to you to do that refactor if it's something that you really want to see. Now, really important, I did make one big typo in the last section. Well, actually two, and we're going to fix both of them up right now. First, when Mongoose loads up these collections to MongoDB and they get reflected over in MongoDB, Mongoose actually normalizes each collection name by lowercasing the entire collection name. So blog post with a capital P is not correct. It should actually be blog posts with a lowercase p like so. So I'm going to also make sure that I update this inside of the drop statement right here as well. So that was a little bit of a typo. I did make one other typo. I know, just awful, 2 in a row. I put in the incorrect require statements in here. So I said require source user. This is not a correct path. In fact, we want to go up one directory in all 3 cases. Because right now we're inside of the test directory. We want to go up to users, into source, and then get the different model files. So again, two typos on my side. Totally my mistake. Okay, hopefully you can forgive me. Hopefully you can forgive me. So let's start working on some tests around associations. So our entire goal right now is to create some users, comments, and blog posts, associate them all together in some fashion, and just kind of see how they work, how they play together. I'm going to expect that we might write a couple of different tests around these associations. So I'm going to create one user, one comment, and one blog post in a before each, and then we'll see how these all work together. So we'll start off by defining our before each. Now this is definitely going to be an asynchronous before each, so I'm definitely going to include a done callback inside of here. We're also going to create 3 different variables inside of here that I want to use inside of all the different it blocks that I put inside this describe block. So I'm going to initialize these 3 variables ahead of time. Remember that this initialization is all about how scope works inside of JavaScript. Since we're going to want to assign these variables inside the before each, we need to make sure that they're inside the outer scope as well. So I'm going to define Joe, a blog post, and a comment. Do make extra sure that you've got lowercase b blog post and lowercase c. Remember that up top, the capital versions of all these models indicate that this is the model class, whereas lowercase indicates that this is an instance of that model. Okay, so Joe, blog post, and comment. Now we are going to create one of each of these user, blog post, and comments. So I'll say Joe is a new user with the name of Joe. And notice that I'm not going to set up any associations just yet. I will then say blog post is new blog post. It's going to have a title of JS is great. And how about some content of, yep, it really is, or something like that. Then for the comment, we'll make a new comment with some amount of content. Congrats on great post. Okay, so that's pretty much it for our 3 setup resources. So I'm going to zoom out for just 1 second so you can see the entire line on each one. And let's go back in. So again, you'll notice that I did not do anything that really makes it appear like these records are associated in any such fashion. So I've not done anything to make it seem like Joe owns this blog post, or that this comment belongs to this blog post, or that Joe made the comment itself. So like nothing is tied between here just yet. To form up these associations, we have to do so in a very direct fashion. So this is like just very direct. We are setting up these associations in a very direct manner. We'll first start off by associating Joe with the blog post. So we're going to assume that Joe authored this blog post, or that this blog post belongs to him. I want to flip over to our user file really quick and remind you that blog posts right here, a user can have a collection of blog posts. So this is an array right here. They can have a collection of blog posts. So to associate a blog post with a user, we can write joe.blogposts.push blog post. And that's it. You're going to look at this and immediately think to yourself, wow, this looks a lot like document nesting. Well, yeah, it's very similar, very similar. So we say Joe has a collection of blog posts. I want him to have a new association to this blog post that we just created right here. And so I'm going to push that entire blog post in there. You'll notice, very importantly, this is a little bit of magic on the Mongoose side. Over on blog posts, we had said that this was going to be of type object ID, but we just pushed in an entire model here. So this is a little bit of magic on Mongoose's side. Mongoose is going to recognize that we just pushed in an entire model, and it's going to automatically say, okay, they're probably trying to set up an association here. So I'm not going to mess with the entire model itself. I'm just going to set up this object ID type to refer to this other blog post. So Mongoose is going to just automatically do the right thing for us, even though we pushed in the entire model. So now we can set up an association between a blog post and the comment in a very similar fashion. So we'll say blog post.comments.push comment. So again, a blog post has many comments. So if we open up our blog post schema, here it is right here, comments is an array. Because it's an array, we're going to push in this comment model to it. Mongoose is going to work the exact same way here. It's going to say, okay, comments should be recording object IDs, and they just attempted to push in a whole model. Chances are they don't want to store the whole model. They just want a reference to the object ID. So again, Mongoose saving the day for us. Okay, last one. In this case, we want to associate Joe with this particular comment. So this time around, it's a has one relationship. So a comment has one user, and that is Joe. So this time around, we are not pushing into an array of users. We want to just say this comment has exactly one author, and it is Joe. So to set up this relationship, we say comment.user equals Joe. All right, now this one right here, absolutely magic as well. Total magic on Mongoose's side, because you can kind of accept that push is like gonna look at this thing and say, okay, it's a model. Yeah, there's some magic going on, whatever. It's taking the object ID. But in this case right here, we are like no two ways about it. We're saying this user property is equal to Joe. So Mongoose clearly has a setter going on behind the scenes, or some type of interception on this assignment right here. And it's gonna say they are trying to assign Joe to this property, but this is supposed to be a reference. So chances are they don't want to set like all of Joe equal to this thing. They just want to have a reference to Joe assigned. So again, big piece of magic on Mongoose's side. All right, so at the risk of this turning into a really long section, let's take a quick break, and then we're going to figure out how to save all these records because they've not been saved to our database yet. So let's take a quick break, figure out how we save them, and then work on an assertion. In the last section, we set up some relations between our user, our blog post, and our comment. One thing to be really clear about right now is that these associations that we just set up are only reflected in the Node.js side of things. So none of this has been persisted or saved off to our database just yet. To make sure that everything gets saved off, we're going to have to call save on Joe, the blog post, and the comment. So we can do so by saying joe.save, blogpost.save, and comment.save. Just as you might expect, right? Well, here's a little bit of an issue though. Inside our before each, we have our callback done, right? And we have been saying all along, just like almost every spec we work on, that only after all of our database work is complete can we call done to say, okay, Mocha, go ahead, continue on, run some spec. When we call save 3 times in a row like this, the question very quickly becomes, well, all right, 3 save attempts, but which one are we going to chain on a .then and then call done from? Essentially, we could pick any of these 3, right? But we have a 1 in 3 chance of being right. In other words, we have a 1 in 3 chance of guessing that Joe will be actually saved last, because we want to make sure that all 3 are successfully saved before we actually run any other specs. So to solve this issue, we're going to use a little bit of ES6 code. We're going to make use of a native function called promise.all. I'm going to put out a reference to it right now. Promise is provided by the ES6 spec, so it's the local or native implementation of promises. The all property right here is a function that will take an array of promises and combine them all into a single promise. So in other words, long story short, we can combine all 3 of these promises and get a single .then statement when all 3 have been resolved successfully. So I'm going to pass all three of these promises that get created by the save into an array that we're going to hand off to the all. So inside of here, we'll say joe.save, blogpost.save, and comment.save. Now we don't need the saves up here anymore. So I'll clean those up. And now on the promise.all, I can chain on a .then, add on a fat arrow function. And this function right here will be only called once all three of these save attempts have successfully been completed. Once they're all completed, we can call done, and we're off to the races. The thing to keep in mind here is that all three of these save requests are going to occur in parallel. So it will be, on average, just as long as the longest single save request between all three, which should be pretty darn quick. This promise.all that we're looking at right here is definitely very frequently used whenever we are setting up associations like this, because we'll want to create some number of records, set up the association, and then save all of them. And only after all these records have been saved, we want to actually take some action. All right, so with this amount of code that we have right here, we should be in a spot where we can start writing tests and just kind of see what happens. We'll see, I don't know, whatever happens. Let's get started. We're going to start off writing a test, and I think maybe we'll just assert that if we fetch Joe out of our database, we should be able to somehow get access to the blog post that is associated with him. So maybe we'll add in a description for this test of it saves a relation between a user and a blog post. I think that's probably reasonable. We'll add on our done and our function. So now inside of here, we'll say user.find1. Keep in mind that our user Joe should already be saved, so we should be able to just dive right in and attempt to find our user. So say name of Joe. And now since we kind of have no idea what to expect with Joe, I think maybe a good first step is going to be to just console log out the user that gets returned, and we'll see where to go from here. So I'm just going to console log our entire user, and we'll figure out what we're going to do with them. Don't forget to call done on here, even though we don't have any tests. If we don't call done at some point, Mocha will think that something bad happened, and it'll throw a big error. Now the last thing that I want to do, right now, we have about 19 or 20 specs inside of our project or so, but right now we really only care about running this single spec right here, the single it statement. So I don't really, just for purposes of development, I don't really want to run any of the other tests that I have in my test suite. If I want to just run a single test by itself, I can say it.only. And when I do so, Mocha will run only this test right here. And so no other test that I have will be saved at all. We're just going to run this one in isolation, and that'll make sure that we just get the quickest debugging experience possible. This is especially useful when you start working with large quantities of tests, I'm talking about hundreds at a time, where the entire test suite might take up to a minute or even much, much longer than that to run. Be a good use case for using the it.only. Okay, so let's save this. We'll flip over to the terminal and see how we are doing. So over here, all right, well, looks like everything is good for right now. So we're definitely getting a console log out. Our console log has an ID, a name of Joe, a blog post property, which is empty. Well, excuse me, not empty. It has an ID, but it does not appear to have an actual blog post object inside of here. And then it also has our old or kind of legacy post property. Remember, we were using this for working around with subdocuments. So it appears that we are correctly fetching Joe out of our database, but certainly we are not actually getting our blog post reflected inside this array. What I really want to have happen here is I want to see my blog post object sitting inside of here. I want to see that thing. So clearly not quite working as we expect. Let's take a quick break and then come back and figure out exactly what's going on here and how we can get access to our actual blog post object. In the last section, we were able to set up some number of relations between a user, a blog post, and a comment. We saved all three models. Then we fetched our user out of the user collection. When we then console logged it, we saw it inside the terminal, but it didn't quite look exactly like what we wanted. We want to have our blog posts inside of here actually kind of load up inside this thing, right? We want to like actually get a reference or get a handle on the actual blog post object so we know what the title or content or whatever else exists for each of these blog posts that we have. But unfortunately, we have just the ID. So to solve this issue, we're going to jump a little bit into the idea of queries inside of Mongo. We haven't quite touched queries just yet, but we will explore them a little bit inside this section and talk about how they're relevant to this kind of process of loading up data. So first, we need to understand what a query is. So this is a breakdown of the current statement that we have inside of our test file. We have user find one dot then inside there, right? That's what we have right now. So if we break this statement down piece by piece, we can turn it into just user find one and then. User in this case says look inside of my user collection. Find one is the type of query, where a query is an operation to look through all the records in our database. So we're specifically saying find the first record with this criteria. And then the real magic, the really important part here that we haven't quite seen in practice just yet is what .then is actually doing. If we just type into our code base right now, user.findOne, and just leave it at that, like nothing else, nothing will actually be issued off to our database. When we just say find one, when we just call find one, that returns what is called a query. A query does not actually go off to our database automatically. It's only when we say .then that the query actually gets executed. You'll also see a lot of existing documentation around Mongoose use a slightly different keyword for executing the query. You'll frequently see the word exec, short for execute. Exec is for use with the older legacy callback type syntax, but we are using promises throughout this entire course. And when you're using promises to start up the query, you use the .then. So you will see exec in some places. It is equivalent to .then, but .then is the more modern syntax. So anyways, again, 3 big parts right now for all the queries we've seen: the collection we're operating on, the type of operation, and then the actual execution of that operation. So our big problem that we have right now is that our query isn't quite finding all the data that we want it to find. Inside of Mongoose, we have the operation or the ability to add on some number of modifiers to our query. Modifier right here, by the way, it's italics. I know it's kind of light, but it's in italics because there's nothing actually called modifiers. I just mean to say that we can add in some functions right here that are modifiers. Modifiers work to enhance the query or make it more specific, or sometimes more broad or more generic, and tell the query to load up more data. Modifiers are used to customize the query that we're making. In our case, we are not currently loading up the blog post association. There is a modifier that we can use called the populate modifier to make sure that whenever we make this query, the query will also load up our collection or our associated blog posts that are associated with the user that gets fetched here. So let's see what that looks like in practice. So this is what it looks like. We still have the reference to the collection, the operation that we want to make, and then a modifier to the query. And then finally at the end, we still have the executor, or in our case, the .then statement. Populate works by passing it a list of strings. And let me be really specific. When I say list of strings, I mean not an array of strings, but we can pass in, like, as an argument 1, argument 2, argument 3, a couple of different strings, where each string represents a relation that we want to load up on the model that gets returned from the find one operation. So in total, we can read this entire statement as go into the user collection, find a user with the name of Joe, load up any associated blog post that Joe has, and then call the function that we passed to then. Or maybe a better last step there would be then execute the query. So this is what we're going to do to enhance our query that we have right now and make sure that our blog posts are actually getting loaded up. So I'm going to flip back over to my code editor, and after we do our find one operation, I'm going to insert another step in here to modify the query that we're making. I'm going to say populate, and I want to specifically populate my blog post association. Just to be 100% clear, I'm able to say blog post right here, specifically because in my user model, I have the property blog posts written out right here. This is really important to note because if we go back over to, say, our comment file, so here's my comment file, you'll recall that I had said that there's definitely some thought to go into whenever you are relating a like a user here. We said user, we could have just as easily said author or something like that, the author of this comment. If you start using some fancy terminology for all your different properties, you will need to make sure that when you call your populate statement, you add in the correct reference to the right property. So right now, if we were putting out a query for comments and we wanted to load up the associated user, we would say user. If we had gone with author over here, so if we had said author, we did not say author, but if we had, we would instead in the populate statement say author like so. So just to make sure that's really clear. Okay, so we are forming up the query. We then add on a modifier, and then we execute the query. So now when we see a console log, I will expect to see the blog post loaded up in total. So let's flip over, and hot dog. All right, so here's our user. We got the ID, we got the name. We have an array of blog posts, and inside of there, we've got our automatically loaded up ID, title, and content. Fantastic, exactly what we want. So this is exactly how we deal with associations in Mongoose. But, I love doing that. I'm going to say but. One little thing. You might notice that although we have our blog post, the comment did not get loaded up at the same time. Interesting. Well, it definitely seems like if we're going to go through all the trouble of loading up our blog posts, whenever we get a list of our blog posts, we probably want to see all the comments associated with them as well, right? Yeah, that definitely makes sense. But it appears that this is an array of object. And without going too far into it, I can tell you that this is not the actual comment object. This is still just an ID right here. We could modify, let's modify our console log just to make sure that's the case. So in my console log, I'm going to say blog posts at 0. Let's save. Okay, so there we go. So this is just the blog post by itself, and now we can very clearly see that comments is an array, and it has just the ID of the saved comment here. So now we're back in the same situation as we were before, where we had just the populate in here, or excuse me, when we did not have the populate, my mistake. So your question that might immediately come up might be, well, is there any way that we can just like recursively load up all these different associations? And the answer to that is no, absolutely not. Absolutely not. Mongoose does not make available to us the ability to recursively crawl through all these records and load up all the associations automatically. We can explicitly load up the associations. We can say explicitly, okay, load up the user with their blog posts, and then look at all the blog posts and load up their comments, but we cannot automatically say, load up the user and everything, every last record automatically associated with it. The reason for that is that if we have a highly interconnected database or a highly interconnected schema, we could have queries that for some reason, by just kind of errantly saying, oh yeah, recursively load up all my relations, those queries could take minutes, hours, days. They could easily crash. Incredibly easy to walk into that situation. So Mongoose will not let you automatically walk through an association and just recursively load up all the different associated records. Okay. I know this has been a long section, but I do want to do just one last thing because we're so close. Let's finish up our spec by adding in an assert statement. I think that we forgot to require assert at the top. So before we put in the actual assert, we'll say const assert. Too many S's there. I'm not even going to repeat that word. So we'll require an assert. And then down here, let's just assert that the user did in fact load up the blog post. We can do so by referencing the blog post, looking at the title, and making sure that the title is equal to JS is great up here. So we'll say user.blogposts at 0. Title, totally blanking out there. And then the title was JS is great. And do make sure that, let's double check to make sure we got the capitalization correct on there and the punctuation. Yep, okay, looks like we're correct. So I'll save this. Let's check it out. Okay, test is passing. We'll see it fail really quick. I'll make a change, I'll save. Yep, test is failing. Let's go back to JS is great. And we're back to passing again. Okay, so our test is definitely working here. The last thing I'm going to do is I'm going to take off that it.only statement. So we're going to go back to just it by itself, and we'll be able to verify that all of our tests are successfully running again. So I'm back to 21 passing tests. Okay, so this definitely works. We're definitely loading up the associated blog post. Let's continue the next section and figure out how we can possibly load up the user, blog post, and associated comments all at the same time. In the last section, we were able to make a query for our user and populate the list of blog posts. When we then inspected the user, we saw that all the blog posts had been successfully loaded up. But we very quickly ran into a little bit of an issue. How are we going to use this type of approach right here to load up the comments on each associated blog post as well? And for that matter, each comment has a respective user as well. So how are we also going to load up the user at the same time? And so it's clear that this just single level populate right here might fall a little bit short in some situations, especially when we want to find like a lot of associations all in one go. So I'm going to repeat the cautionary tale that I told you at the end of the last section, where I specifically mentioned that you want to be careful the number of associations that you load up, because if you start loading up too many associations, it's really going to bog down the duration of all your queries. So you definitely want to be very careful. So we are going to walk through the process of loading up a user, all their blog posts, all their comments, and all their users as well. But again, just be careful with this approach. Okay, so let's give it a shot. I want to load up a user, the blog posts, and the associated comment. So I'm going to write in another test, and I'm going to say this time saves a full relation tree. And I say tree here just a little bit lightly. It's, given that we can have a user related directly with a comment as well, and I think, matter of fact, we do right here. It wouldn't be quite accurate to say this is a tree. This is more of a graph. So let's just go with graph. What the heck? No big deal either way. Okay, so in here, we're going to start off by loading up our user. We'll get the blog posts, we'll get the comments, we'll get the owner of each comment, and then we'll make some assertions about it. Okay, so let's see how this goes. We'll first start off by doing our user find one with the name of Joe. So we've seen this much so far. This forms the initial query. Now we're going to tack on an additional modifier to this in the form of populate. Now previously we just passed a string to populate and said, hey, go find this particular key and toss some data in there. Just resolve everything. Populate, however, can also take an object with a bunch of configuration options. One configuration option that we are going to make use of is the path and populate options. The path option that we see right here is going to say inside of the user that we fetch, we want to recursively load this additional resource. So for us, the user Joe has a property blog post that we want to populate. So this path key right here works much in the same way as how we were using it up here. Path means look into the user object, find the blog post property, attempt to load any associations that are in there. Now the populate key right here starts to get a little bit more interesting. Populate means inside of the path that we just got right here, we want you to further go inside of there and attempt to load up this additional association. So inside this additional populate object, we're going to give it a path of comments. Okay, so I feel like things probably just got a little bit confusing. So just rewind for 1 second, make sure everything's really clear. User.findOne is going to find a user. This first path key right here says in that user, find the blog post property and load up all the associated blog posts. Then the populate option right here comes into play. Populate means inside of all those blog posts that you just fetched, find the comments property and attempt to load up all the associated comments. Okay, so first get the user, then load up the blog posts, then load up all the comments that belong to the blog posts. There's just one little issue. When we start loading up these nested associations, Mongoose requires us to tell it which model we want to be using. And when I say model, I mean specifically like out of all the models that we've registered with Mongoose, remember with the mongoose.model, which model do we want to use for this nested association? So we can pass in the string of comment right here to tell it that, okay, when we load up these comments, we want to use the comment model, like so. Okay, so this is very quickly getting out of hand, so I think maybe right now is a good time to pause, execute this query, and see how we're doing. So let's put on a .then to actually execute this. We'll take our user, and let's just console log the whole thing. And then I'm also going to remember to put on my done callback so that Mocha doesn't think that we're throwing an error. Okay, so let's save this. And okay, so it looks like we've got Joe, we've got our blog posts, and we've got an array of comments, and it's still kind of like how it looked last time when it still was an ID. So let's narrow down the console log and instead look at blog posts at 0. So now when this thing runs, okay, we're looking at the blog post now, and it appears that, yep, our comment has been successfully loaded up. Definitely what we want to have happen. So here's the content, and we still only have an ID for a user, so clearly we are not successfully loading up the user just yet. Well, here's where the real magic comes into play. If this looks confusing right here, we can go even deeper. This is like pretty much Inception. It's identical to Inception. What am I saying? It's totally identical. So we have loaded up the comments property by using the populate option on here. We can now say on each of these comments that get loaded up, I want to also populate the user property. So look at the user property and load up whatever's there. And then we are again going to tell it, we have to be very specific and say when you populate that property, make sure you use the user model. And so again, this model right here is saying go and find whatever model is referenced or registered with Mongoose as a user. So I'm inside my user file right now, and use that to populate this additional association. All right, so let's save this and see how we're doing. And looks like we got a little bit of a crash here. I think that I have a little bit of a typo. My mistake, I got ahead of myself. Yeah, I forgot a comma right after model. So do watch your commas. Make sure you've got all the appropriate ones in here. Totally my mistake. So let's save it, run this again. Okay, so now we've got the blog post, the array of comments, and a user that is an object apparently. So still, clearly this is not just an ID anymore, but let's add in a little bit more specific console log and make sure that we're getting the correct user here as well. So now again, back down in my console log statement, we're gonna say, take the user, find the first blog post, find the first comment, and console log that. All right, so here we go, full circle. We're now looking at the comment by itself. So here's the content of the comment, and here's the user who is Joe. And if we were just completely insane, we could nest in a bunch more preload options to then go through again and load up all of our blog posts recursively. So, man, this stuff definitely gets overboard pretty quickly as far as loading associations. You definitely have the option to go as deep as you want by nesting all these populate options. But you definitely have to be careful, again, to make sure that you're not going to find yourself in a case where you're accidentally loading up like tens of thousands of records, which is definitely possible depending on the type of app that you have. All right, so I think the very last thing that we're going to do in this section is probably going to be pretty good to maybe write a test around all these resources that we just loaded up. So I'm going to take out the console log statement. And I think that we'll just make one assertion about a single property on each object that should have gotten loaded up off the user. So we'll start off by saying assert that the user's name is Joe. I think that's a safe assertion. We'll assert that the first blog post has a title of, what do we use? JS is great. Not great, but JS is great. Let's assert that blog post 0. Now we have to look at the comments array. So here's comments. We'll get the first comment, and then the comment has a content property, and we'll make sure that that is equal to whatever we used for the set for the content. So I'm going to scroll up and find whatever we used, because I certainly forget by now. Okay, grats on great post, or congrats on great post. So congrats on great post without a period. I'm going to zoom out for a minute just so you can see everything. Okay, there we go. I think that's legible, right? Hopefully that's pretty good. And then just to do the full circle, everything that we can possibly do, we'll assert, and now here's the real long one, user.blogpost at 0.comments at 0.user.name is Joe. All right, this is definitely a mouthful right here. If you want some real good practice with destructuring, by the way, I challenge you to try destructuring some of these properties. I'm just going to throw that out there. All right, let's save this and see how we're doing with our assertions. So we'll run it, and darn it, it looks like we've got a little bit of an error somewhere. Chances are I might have, yeah, I'm sure you were all just yelling at me as I type this out. I use blog post. It should be blog posts plural. So I'm going to fix that up real quick. So blog post, posts, comments. All right, let's give this another shot. Okay, 22 tests passing. So clearly, this is working out pretty well. One thing that might be a little bit of fun is you'll notice that after every single test over here, we get a printout of the time that it takes. Let's get just like a very simple, stupid benchmark of the query that we just added in by looking at the time that this takes. So just to make sure, I'm going to do a save over here again to get my test to rerun. Okay, so last time was 429, it's 439, 470. Okay, like basically mid 400s. I'm going to now take this entire query out. Actually, let's just put an X. So we'll exit, so this will ignore the entire spec. So let's run this now and see how long the query takes. Oh, all right, well, 455, 383. Okay, well, that's definitely a difference. 438. So I think that it's definitely a significant, well, not 43. Okay, this is a very unscientific method of benchmarking. So we'll just say this has an unknown impact on query performance. We'll figure out a little bit more about benchmarking later. Maybe using Mocha for benchmarking isn't the best approach. Anyways, sorry to run this section really long, but we've definitely gone through a lot of content. Let's continue in the next section. We've now gotten a pretty good taste of associations with Mongoose, but there's one last topic that I want to talk about that is somewhat related to associations. You might say it's associated with associations. All right, I'll stop there. The topic that we're going to talk about is something that is not particular to Mongoose. This is something that is common to just about every type of database that exists out there, but we're going to be covering exactly how to solve it by using Mongoose. I want you to think about the situation for a second in which we have a user, a blog post, and a comment. Now we've said that the user is kind of like more or less the root record for blog posts and comments. Yes, comments must have a user, but at the end of the day, if the user doesn't exist, or if the user for some reason just like disappears off the face of the earth, it doesn't really make a lot of sense to still have around a blog post and a comment. Now, maybe for your application, right? Maybe if you are making some forum post or some forum of some sort or a blog post of some sort where even after a user deletes themselves, you still want all their blog posts and comments to stick around, then this discussion we're about to have is not super relevant. But I'm going to sit in a world right now where I'm going to assume that if a user's account ever gets deleted, we will also want to delete all of their blog posts and comments as well. Okay, so that is what I'm talking about here. That's the problem that we're going to look to solve. If we delete a record, like a user, I want to automatically clean up all of their blog posts as well. It'd be great to also clean up their comments, but just to keep our example a little bit more compact, we're just going to be looking at how to clean up blog posts. Okay, so that's pretty much the problem. Given a user who deletes himself, we got to clean up after them. That's pretty much the whole story. So how are we going to do this? Now, of course, we could probably say that whenever we delete a user, just write some additional amount of code to go and find all of their blog posts and delete them as well. But here's the thing, we might have users being like deleted all over the place in our application. Yeah, it's not super common to delete a user, but maybe if we were talking about comments, this would certainly be very relevant. Like comments might be getting deleted all day. So clearly we must have some reasonable idea of figuring out how to do cleanup. To do resource cleanup in this manner, we're going to use a system in Mongoose called middleware. Middleware are also referred to as pre and post save hooks. Actually, let me subtract one word there. I don't want to say save. I just want to say pre and post hooks. So let's get a better idea of how middleware works. Middleware, as I've depicted right here as middleware pieces 1, 2, 3, and 4, are functions that execute before and after some distinct event takes place with Mongoose. Okay? There's two types of middleware. There's pre and post. Pre and post is a reference to what side of some given event that the middleware runs. So that's kind of the textbook definition. Let me give you a much more practical one. One type of event that we might watch for is a save event. So anytime that we are about to save a record to our database, run this function, then after the record is successfully saved, run this one and this one. We can also put a hook around validate. So this would say, before we validate a record, run function 1 and 2, and then after, run 3 and 4. Perhaps most useful for us in the context of the example that we're looking at is an event called remove. So if we add middleware around the remove event, we can have some number of functions that are called right before a record gets removed and or right after a record gets removed. So I think that maybe a great approach to this whole resource cleanup thing is going to be to add a middleware right before the remove event on a user. So the instant that a user is about to be removed, we'll go and clean up all their blog posts and then continue on and delete the actual user. So let's get some experience with writing middleware inside of our user to clean up all their blog posts. Let's do that. Let's take a quick break because it might be a little bit long and then tackle this problem in the next section. In the last section, we spoke about cleaning up after ourselves by using the middleware system in Mongoose. We can attach some number of functions to run right before or after some given event. The 4 events that we can possibly watch for inside of Mongoose are init, which is called for initialization of a model, validate, which is called whenever a record is validated, save, which as you might guess is whenever a record is about to save, and remove, which is by far most useful one for us. So we can define middleware to run right before or after each one of those events. So let's add a middleware to run right before the remove event on a user. And inside of that middleware that we're going to define, we'll make sure that we clean up all the associated blog posts with that user. All right, so I'm going to open up my user.js file. Typically, we will locate all of our middleware that is associated with a single model inside of the related user file, model file. Do note that all the different models that we have can have their own sets of middleware. So the middleware that we're about to add is tied 100% just to a user. So we're going to look at our user schema and we're going to say pre-save. So that's pretty much it. That's like the magic for adding a middleware. Watch for the save event and pre, or before that occurs, run some function. So we'll define a function and it'll be passed in as a second argument. So this right here is what's going to be called right before any record gets saved. Or I should say before any user specifically gets saved. Now, of course, I made a little bit of a mistake already. I keep on saying pre-save because pre-save is one of the most common middleware that we write, but we don't want to watch for the save event. We want to watch for the remove event. So totally my mistake there. Do notice that we passed in, again, a keyword function as opposed to a fat arrow function. That, again, just like with our virtual fields up here, is because the model instance is available as this. So I'm going to put a little comment in here. I'm going to say basically this is basically equal to Joe. Okay, so just remember that. This is not, of course, always going to be exactly equal to Joe. This is just like a nice little comment between you and me to remember that, you know, this very colloquial user that we have of Joe is what this is going to be. You get the idea. So now inside of here, we can do some amount of cleanup on all of our different blog posts. But this definitely starts to open up a little bit of a can of worms. Like ideally, we would say just blog post dot remove and something, 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 right? That's what we want to do. But this really starts to open up a can of worms, and here's why. If I make a direct reference to blog post right here, that implies that I am going to go up to the top of my file and require in blog post at the top. Now I can definitely do that right now, but here's where the problem is. If I later go into my blog post file and decide to write some middleware inside of here that needs to require the user model, I would then need to say up here, const user equals require user. So now I would be in a type of situation where I have a cyclical load between my user file and my blog post file. The user file requires blog post, but blog post requires user. So which one actually gets loaded up first? It's best to just completely avoid this type of situation. I'm going to remove this require in blog post, by the way. That was just a for example. It's best to just completely avoid this situation by using Mongoose as a little bit of a helper. At the very bottom of my user file, remember how we registered our user model using mongoose.model? We can use this exact same function right here to pull another model out of Mongoose that has already been registered. So long story short, I'm going to say const blog post equals mongoose.model blog post, like so. So when I do this, you might be thinking, well, Stephen, don't we still have like a cyclical load here? Or, cyclical, I feel like is not the right term. They both require each other. That's what I'm trying to say here. When we write the code like this, however, the mongoose.model call will not be invoked until this function actually runs, which in theory is way down the line, way past our application first loading up. So if we ever want to have to not worry about this cyclical kind of loading situation, we can just use mongoose.model and we will always be a-okay, because this is going to return the entire blog post model. Okay, so now we're inside this file. We've got access to our blog post model. And now we can call remove on this and figure out how we're going to remove all the records in blog post that are associated with Joe. So let's take a quick break and figure out exactly how we're going to do that in the next section. In the last section, we started adding in some middleware for handling, cleaning up all of our different blog posts on a particular user when they're about to get deleted. But we very quickly ran into an issue around a possible cyclical loading issue. We then fixed that up by making a direct reference to blog post by using the mongoose.model helper. So now we're ready to actually write a query to remove all of our different blog posts that are associated with this user. Now here's the real tough thing about this. Okay, this is like a query unlike any other that we've ever written before. Keep in mind that we want to remove all the blog posts associated with the user. But blog post right here is an array of IDs, and that is exactly where the challenge lies. We've already seen, back when we were going over all the remove methodology, how to remove a single record. So we can do something like blog post.remove, and maybe we can say like remove this given ID, right? Like we definitely know how to do this. This will go over our blog post collection, find every single record with this particular ID and remove it. But now we're saying that we have an array of IDs and we want to remove every single one of those from the blog post collection. So I'm going to tell you right now, the solution is absolutely not to iterate over the list of IDs. So do something like this dot blog posts dot each, and then inside of for each ID I want to issue a delete request. This is definitely not the solution we want to take. If you ever find yourself in this type of situation where you feel like you want to make iterate over an array of records and then issue one database update for every record, I really urge you to pause for a second and try to figure out whether or not that's the best solution. In this case, given that we want to take an array of IDs and delete each single one, instead of iterating over the list, we are going to use another little Mongo operator. So you might remember our first operator inside of our update function, our update tests. So this is my update test file right here. And at the very bottom, if I scroll all the way down, you'll recall that we use that increment operator. So with the increment operator, we were using this to modify a collection of data. There's another class of operators that can be used for querying records as well. So increment was a update operator. We want to use a query operator called in. So I'm going to throw up some code and we're going to talk about exactly how it works. So I'm going to say, look at all the IDs inside this collection. I want to delete anything inside of this .blog posts. Okay, that's a pretty big change right there. So let's take just a second to digest it. Remember first that this is a reference to our instance of a user. So in this case, in the world of our tests, this is equal to Joe. So if we say this .blog posts, this is going to be an array of all the IDs of all the blog posts that we want to delete. The in operator says, go through all the records in the blog post collection, look at their IDs. If the ID is in this array, like go through this array and do a little match on each and every single one, then I want to remove that record. Okay, one more time, go through all of our blog posts, look at all their IDs. If the ID is in this list right here, go ahead and remove it. And that's it. Okay, so that's nearly it for our middleware. There's just one last little piece of bookkeeping that we have to be aware of. It is assumed by default that the middleware that we write might be kind of asynchronous in nature. Like, this right here, definitely asynchronous. This is going to take some amount of time to execute. But we want to make sure that the entire middleware is executed before our record actually gets removed, before the user actually gets removed. So to accommodate for this asynchronous nature, all of the middleware that we write starts to make use of this concept called next, or a function called next. Every middleware that we define, the function that we define right here is going to be called with a function called next. After we finish all the work that we want to accomplish inside this middleware, we call the next function, and that tells Mongoose, hey, everything we've done is all complete. You can move on and call the next middleware if one exists, or otherwise remove the record from the database. So we can relate this really easily back to the diagram we were looking at. When we attempt to remove a user, we will automatically call middleware number 1, and then Mongoose is just going to kind of sit around and twiddle its thumbs until our middleware number 1 calls next. Once next is called, middleware number 2 will be called. Once middleware 2 calls next, then we actually issue the remove event. Then we go to middleware number 3. We wait for next to be called. We go to 4, and so on. You get the idea. So after we remove the model, we'll chain on a .then, and then inside of here, we call next. And that's pretty much it. So remove all these records. When it's done, go on to the next middleware. If one doesn't exist, then just go ahead and remove this record. All right, so I'm going to save this file. We've added in the middleware, but we don't have any tests put together just yet. So let's take a quick break and then come back and add in a new test file to test out this middleware that we've just implemented. In the last section, we added in some middleware to make sure that whenever a user gets removed, we would we'd kill off all their existing blog posts as well. The real interesting thing inside of here is that we use the in modifier that's a part of Mongo. Okay, so I think that this middleware is looking pretty good. And we're now at a spot where it'd be pretty good to probably add in a test and make sure this thing is behaving as we would expect. So the test should be pretty straightforward. We will create a user, we'll create a blog post, we'll delete the user, and then make sure that the blog post is not there. So I'm going to start off by creating a new file inside of our test directory, and we'll call this one middleware test.js. Now inside of here, we'll grab Mongoose, not Moongoose. We'll grab assert. And yep, I misspelled require. My bad. Let's fix that up. Okay. And then I think that the only models that we're going to need inside of here are the user and the blog post as well. So we'll say const user equals require src user, and we're going to make sure that we go up 2 directories, or excuse me, go up 1 directory. We have 2 dots. And then we'll also grab our blog post model as well. So src blog post. Now we'll place our describe of middleware, nice and simple. Now we need to create inside of a before each our user, our blog post, associate them together, and then save them. So we basically already did all this just a second ago inside of our association test. So maybe it would save us a little bit of time by just doing a quick copy paste. I'm going to flip over to my association test file, and I'm going to take my entire before each, just the before each. I'm going to copy it all. I'm going to flip back over to my middleware test, and I'll save it inside of here. I'm going to immediately take out the code for the comment because we're not working with comments here. So I'll take out the comment. I will make sure that the comment is not trying to associate with Joe. And then also I don't really care that the comment get associated with the blog post either. So I'm going to take that out as well. So now I'm left with just Joe, the blog post, the association between the two, and then our promise.all. And I will also make sure to remove the comment.save as the third entry in the array. Okay, so I think this looks good right here. Let's not forget that we also need to initialize Joe and blog post right above the before each. Okay, so I think we're at a good spot now with our setup. We can now add in our it block and start making some assertions. So let's start by placing our it block. Let's give it a description. How about users clean up dangling blog posts on delete? Maybe instead of delete, we'll stick with the terminology that's used with Mongoose. Let's go with remove. And then we will not forget our done callback. So now we can take Joe, we'll remove him, and then there's a couple different ways that we could tackle this. We could load up all of our different blog posts and make sure that the first entry just does not exist. Maybe a better way, or a little bit more canonical way, would be to get a count of all the blog posts that are in our blog post collection and assert that that count is 0. Because at this point in time, we've only created 1 blog post. When we delete Joe, that only blog post should be deleted, and so our blog post count should be absolutely 0. To get a count of all the records of that are in a single collection in our Mongo database, we can make a reference to our model that represents the collection we want to get the count about, and then call the function count. Now remember, even though this seems like a fairly simple thing that we're doing right here, like literally just give me a count, this is still an operation that's going to touch our database because we are asking Mongo, hey, how many records do you have in the count collection? So just as though we were finding a record or filtering or doing anything like that, this is going to be an asynchronous operation. And so we're going to chain on another .then, which will be called with the result of this operation, or in other words, the number of blog posts that we have in our blog post collection. So we'll add in another .then that will be called with the count, or more specifically, the number of blog posts that we have. So then inside of our then inside of here, we can assert that count is equal to 0, and then we're called done to clean up or finish off the test. All right, moment of truth. Let's save this, flip over to our terminal, and hot dog, 23 tests passing. Not bad at all. So it looks like this is definitely working out the way we expected. Let's do a quick change to the assertion in here. So I'm going to say count equals 10 just to make sure that the thing's going to fail. Yep, looks good. We'll go back to a count of 0. All right, definitely exactly what we wanted. So this is looking pretty good. We're definitely cleaning up all of the blog posts associated with a given user when the user gets deleted. Let's go ahead and continue in the next section. We've covered a lot of different topics with Mongoose so far. There's one last big topic that I want to talk about, and then we're going to move on to our next project where we're going to make use of all these different types of operations that we've been looking at. So let's talk about this last topic and kind of wrap up this section and then continue on to the next one. I'm going to open up my read test file. So let's find that one. Where is it? Reading test. There we go. So here's my reading test file. And so this is one of the first tests that we looked at, or one of the first tests that we actually wrote. If you recall, we had a bunch of different tests in here with all the different ways to fetch users out of our user collection. In this case, just two. We were making use of find and find one. I want to focus a little bit more on find for a moment. I want you to think kind of carefully about find. Okay, let's look at a diagram of what our user collection might look like at some point in time. So I know that the text on here is really small. All I'm really trying to convey by this diagram right here is that as we start to use our application or we deploy it out to the wild and users start signing up for our app or whatever it is that they do, we might end up with a whole bunch of resources in a single collection. Now there's definitely nothing inherently wrong by that, right? Like Mongo data collections can get somewhat arbitrarily large without us really having to do anything special. But I want to ask you a question. Okay, I want to ask you a question. What would happen if we wanted to put together a web page where we just displayed about 6 different users on the page at a time? So maybe this would be like search results for friend requests or something like that on Facebook, right? We don't want to show a big list of like 1,000 different users all at once. We probably only want to show a small handful of records at once. And then to make sure that the user can navigate around and look back on the list and look at like the next 6 results, we might show them a previous and a next button on here as well. So this is something that we don't really have the tools yet for handling. We don't really have the ability to limit the number of records that come back in a query. And we don't really have any idea on how to implement some type of pagination like this, where we can look back at like the last 6 records or look forward at the next 6 records. So in this section, we're going to kind of try to figure out how this would exactly work with Mongoose. Implementing pagination in this fashion utilizes 2 query modifiers that we're going to be talking about. The first is skip and the next is limit. So skip and limit are 2 query modifiers that we can use to implement pagination. Let's take a look at how these would work. There we go. So skip and limit. In this diagram, we still have a big old list of different users in here. The purpose of skip is to say, all right, I acknowledge that my collection will have some giant number of records inside of it. By default, whenever we make our queries, we start off with a skip value of 0. As soon as we start to increment a skip value, that means that in our query result, we will skip the first 15 records. On the other hand, we have access to limit. Limit does exactly what you might think. It limits the number of results that we'll get back from a query. So if we apply this skip and limit system to the diagram that we just saw, this one right here, we might be using a skip of, well, I don't know. You can't quite tell by just looking at a list like this. A skip is kind of arbitrarily long. If we were on the first result or first page of results, then maybe this button down here, instead of saying previous, it would say, like cannot go back anymore. So if we had something like that, which implies that we're on the first page of results, then that would mean that we have a skip value of 0. So we did not skip any records. We're at the very start of the collection. However, we could definitely tell that this would have been generated by using a limit value of 6, because we only see 6 records on the screen at this point in time. So by using skip and limit, we can essentially set up a window of results that would come back from our user's collection. Let's take a quick break and then come back in the next section and write a test or two to figure out exactly how skip and limit works. In the last section, we spoke about how we can implement pagination over our collections by using the skip and limit modifiers on top of a query. Let's flip over to our test file and we're going to add in a new test to figure out exactly how skip and limit work. So I'm going to go over to my code editor. And I think maybe a good place to put this test is inside of our existing reading test. So if I open this up, this is where we've been writing in some tests around reading users out of our database. And that's definitely what we want to do right now. We're testing the ability to read users out of our database. So I think this would be a great place to add the test. I'm going to flip down to the bottom of this file. and add on a new it block. So I'll add on a new it, and I think a good description for this would be it can skip and limit the result set. So when we're using skip and limit, that's what we're really doing. We are filtering out or filtering the result set. Skip and limit are applied traditionally after some amount of filtering criteria. So in practice, we can still say like, hey, give me all the users with the name of Joe. Maybe I've got many users with the name of Joe. And after we've applied that sort of filter, we can then skip and limit that result set. Okay, let's go back up to the top of this file. I'm going to find our before each statement. So here it is. I think that a good way to approach this test, or a good way to write it, is going to be to create a number of users, like maybe we'll say 4 different users, and then we will add in a query to fetch just some little window inside of there. Okay, so some just small portion of the users that we create. Right now, our before each is only creating a single user of Joe, so we'll need to add in a couple more new users and then save all of them. Keep in mind that since we're going to have 4 users total here, and we only want to call our done callback once all 4 are saved, that definitely tells me right now, like I'm definitely thinking in my head, that we're going to have to use that promise.all helper again. So we'll save all 4 users simultaneously, and then when they're all done saving, we'll call our done callback. So that'll be our plan. So first, we've got Joe. We need to add in 3 new users here as well. Let's say that we're going to have Maria, Alex, and how about Zach? We'll keep this nice and alphabetical, which will make our lives a little bit easier. So let's start off with Alex. Alex is going to be a new user with the name of Alex. Let's do capitalization correctly. Then we'll add in Maria, who's going to be a new user with the name of Maria. And then finally, Zach, who's a new user with a name of Zach. Okay, so this, again, just creates these records on our server side or in our Node.js program. It does not persist it to our database. To do so, we have to actually call save on each record. Again, like I just mentioned, we have to save all 4 of these in parallel, and only when they are all saved do we call that done callback. And so again, we'll use our promise.all helper to make that happen. So I'm going to pass an array to promise.all, and inside of here, we're going to save each record. So I'll say alex.save, joe.save, maria.save, and zach.save. I'm going to clean up all the existing code that we have underneath here, the joe.save stuff. Let's take it out. So now, I'm going to zoom out for 1 second just so you can see the whole line right here. We'll chain on, we'll chain on a .then statement, which will only be called once all 4 records are saved. And inside of here, we can call done. Okay, let's save this file. Now, all of our tests inside this file should still be running A-OK. So let's flip over to our terminal and, okay, so this is, it looks like the tests are all passing. The test that we just added in is not calling the done callback, and so for right now, for me, that's failing. If we want to just make all of our tests pass, we can go down to the current it spec, the spec that we just added, and remove the reference to done over here. And if we do so, okay, so now all tests are passing. So even though we're adding a couple of other records inside of this before each test, or this before each callback right here, it's not having any impact on the other tests that we have in this file. And actually that's like pretty good. It means that the find operations that we have in here are definitely working the way we expect. All right, so now that we have our test setup all put together, we can add in a little bit of a query in here to pull out just this very small window of users. So inside of our new it statement, we are going to make a query to find our users. Then we're going to limit and limit and skip the number that we get back. So we'll start off by writing out a query to find all of the users in our user collection. So I'll say user.find, and I'm going to pass in an empty object. Remember that by passing in an empty object right here, it means I have no filter criteria whatsoever. Just give me every record that is sitting in my database. If we wanted to apply some filter, like say only find the users with the name of Joe. We can certainly still do that here. After we find a list of users, be it like all the users or just a subset, just a filtered subset, we can then skip some number of records. Okay, so remember, this is a query modifier. So after creating the query, we are going to modify it in some fashion. We're going to say skip over this first number of records inside of here. So for us, for our test, we were saying that we want to skip over the first user and then limit to a result set of 2. So we should only get users 2 and 3 that are sitting in our collection. So I'm going to skip the first user in our collection, and then I'm going to limit the number of results so we get back to 2. So right now, if we imagine that we have Alex, Joe, Maria, Zach, we just skipped Alex, so I can kind of like, strike out Alex like so, and I said limit 2, so I'm really going to expect to only see Joe and Maria in my result set. All right, I'm going to take out this comment here. Let's take a quick break because I don't want this to turn into too long a section. We'll take a quick break and then come back and write the actual assertion here. There is maybe going to be a little bit of a rough edge to this, something that we'll need to discuss as well. So I want to make sure we have plenty of time to do that. So let's tackle this in the next section. In the last section, we started writing out our query to skip and limit some number of records out of our user's collection. We've got the basis of our query all put together. All we have to do now is actually write an assertion around it. So this this query right here will return, in theory, just 2 of my users. So I'll add on a .then, and this will be called with the list of users that gets returned from the query. So inside of here, I think that we can probably go ahead and just make an assertion on the first and second element in this array. And we can just check to make sure that they have the correct names. So let's do that now. We will assert that users at 0 has a name equal to the second user in our collection, which in theory is going to be Joe. And then the third one in theory should be Maria. Now there's a very important reason that I say in theory here. Okay, here's why. When we look at the way in which we're saving all these records, we are kicking off 4 save operations in parallel. We have absolutely no guarantee that Alex will be the first one saved, and then Joe, and then Maria, and then Zach. We have no guarantee that that is going to be the case. In fact, if our Mongo database is like somewhat disconnected or there's some significant latency between our test suite and our actual Mongo database, it's entirely possible that there will be some amount of time or some lag between each of these operations succeeding. And so we could end up in a situation where first Zach is saved, and then Joe, and then Maria, and then Alex. But I am about to make an assertion inside my test that Joe will always be second and Maria will always be third. So let's write in this assertion and just see if it works. Okay, let's just see if it works for right now. So the first user that comes out of my kind of little window right here should be Joe. And then my next one is going to be Maria. And then we'll add on our done callback. And remember, I just deleted done up here inside my it block, so I'm going to add that back in. Okay, so we are finding all the users in our collection, skipping the first record, saying we only want 2 results back, and then asserting the name on each of those records. Maybe one other really good assertion to add in here would be to assert that we only got 2 records back. That would just make sure that, in fact, right now the test that we have is really only kind of asserting that skip worked properly. We should also make sure that we only got 2 results back. So maybe a good idea would be to add on another assert of users.length is equal to 2. So that's going to make sure that we only got 2 users. Okay, so let's save this, run our tests, and see how we're doing. Okay, so we're definitely passing here. Out of curiosity, what would happen if we change the order in which these are saved? So I'm going to take Joe, and I'm going to move Joe to be first. So let's save this. And okay, yep, we're definitely failing now. So our test is very much vulnerable to issues with sorting. Now, I'm not saying that this is like the biggest deal in the world for the purpose of our test suite. Our test suite is like sitting right next to our MongoDB database, and so I don't really expect this to be the biggest issue in the world. Maybe one test in every like 100 is going to fail. That is definitely not ideal. I definitely don't want to have that happen. But is it really the biggest thing in the world? Well, I'm going to say yeah. I'm going to say that we want to make sure that our tests are 100% of the time always going to have the same output. So I'm not really comfortable saying that our current test setup is a really good solution. I don't think that relying upon Alex first saving and then Joe and then Maria and then Zach is the safest thing in the world. So I think that we need to add in some type of protection or some guarantee here to make sure that our records are always ordered in the same fashion. To do so, we're going to use one last little query modifier. So in our queries it stands right now, we have two separate modifiers. We first skip a number of records and we limit a number of records. I want to add on one more modifier called sort. Sort does exactly what you might think it's going to do. It's going to sort our collection of users, and then we will skip some number of records, and then we will limit the results. So I think that we should add on a sort to sort by all the users' names. Then we can skip and limit the result set. And the result will be no matter what order in which we call save, or no matter what order in which these actually get saved to our database, I will always expect the test to work appropriately. Okay, so let's go on back down to our test statement here. It's definitely traditional, or it is convention, I should say, once we start stacking on a bunch of query modifiers to new line each of them like so. This just makes it a little bit more legible, so I can say, okay, we're going to find all of our users, skip one, limit two, and then blah, 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 do something with the result. So to sort our collection before we do our skip and limit operations, I'm going to add on another modifier called, you guessed it, just sort. Now to sort by a given criteria, we can pass in an object. The key of this object will be the property that is sorted for all of our users, and then the value will be the sort order. So if I pass in a key of name and a value of 1, that means sort all of my users by the name property and sort them in an ascending fashion. So A will be first, then B, then C, then D. I can also specify a -1 here, and that means sort in a descending fashion. So I would expect to see Zach first, and then Maria, and then Joe, and then Alex. With the way that we've written up our test suite, I definitely expect it to be ascending. So I'm going to go with name of 1. That means sort all my users by their name in an ascending fashion. Okay, so let's test this out. I'm going to save now. And okay, looks good. Still got 24 passing. Let's go up to the top of this file and change out the order of these save statements. So let's just take Joe. I'm going to cut Joe. I'm going to put him right before Alex, like so. So I'll save this, and hot dog. Our saves or our sort is definitely working the way we expect. Okay, so this has definitely been a good little experience on sort and skip. Let's continue on to the next section and see how we can start applying all these different Mongoose rules that we have learned. We've now got a lot of practice working with Mongoose in a testing environment, but we don't really want to be in a testing environment forever, right? In this section, we're going to start working on a much more realistic application where you will be writing queries and seeing data pop up inside of a written application. Essentially what we're going to do is take a pre-built application and fill in all of the Mongoose and MongoDB logic required to make the thing work. So this is going to be a lot of fun. You're going to get a lot of very live practice writing queries by yourself, and then you and I will come back and do a little bit of review and make sure that all the queries are being written correctly. So in this section, we're going to start doing a little bit of setup on this application that we're going to be working on. And then once we're done with the setup, we'll take a look at what is already put together in this app and exactly how this is all going to work. So in this section, let's get started with a little bit of setup. First off, I'm inside of my project directory right now. I'm going to go up one directory. And so now I'm just in my general workspace directory. So I'm not working inside of my users project anymore. I'm inside of a very kind of empty project workspace sort directory right now. Next, I'm going to open up Google Chrome. Now, I've already taken liberty, again, of putting together kind of like a skeleton of a project for us to work on. It's going to be a lot of fun, trust me. Can't say it enough. So we're going to go over to GitHub and download this project and get it set up to run locally. So inside of Chrome, or whatever browser you want to be using, I'm going to manually navigate to github.com/Stephen Greider. That's my name. And then we're going to go to a very specific repository, which is called Upstar Music. So Upstar, well, you'll see the name in just a second. There we go, Upstar Music, like so. So this is a starter project. It's already got a whole bunch of code inside of it. What we're going to do is install this and then figure out exactly what code we have to add in to take it all the way to completion. So the first thing we'll do is download the project. On the right-hand side, you'll find the green clone or download button. Now, if you're familiar with Git, you can go ahead and just clone using this link right here. If you don't have Git installed on your machine or you're not familiar with it, you can just as easily download a zip file and then extract all the files that are inside of here. So since I'm going to go the Git route. I'm just going to say I'm going to go the Git route. So I'm going to grab this link right here. I'm going to flip over to my terminal. And then inside of my just kind of general workspace directory, I'll say git clone. Oops, didn't grab the link. Well, I did a poor job of that. There we go. Okay. So I'll clone my project. After I've cloned it, I will change into that directory. And then once inside of here, I'm going to install a bunch of dependencies that are already bundled up inside this project by running npm install. So this npm install is going to take a little bit of time. So let's take a quick pause and then come back when all of our dependencies are installed. So I'll see you in just a second. In the last section, we started doing a little bit of setup around a new project we're going to be working on called Upstar Music. We ran the npm install command to install a bunch of dependencies. Once that command was complete, if you saw any warning messages in here, totally fine, don't sweat it. The only thing we need to be worried about are error messages. So if you see something that says error, okay, that's when we need to start to do a little bit of troubleshooting. Now that I've installed all my dependencies, I'm going to start up this project by running the command npm run start. Now once we run this command, it's going to automatically pop up a little window for us that this application is going to run inside of. You'll notice that the screen first appears as white. I'm going to wait in my terminal until I see a line in here that says something like bundle is now valid, and then I should see the screen automatically refresh. If you don't see it refresh, you can come up to view and then hit reload up here at the top. Alternatively, you can just hit the hotkey Command R or Control R. Either one is fine. So you can see the project that we have to work with right here. I'm going to drag it out a little bit and notice that when I expand the width, I get the two buttons on the top right-hand screen appear, which is definitely what I want to have happen. Okay, so here we go. Here's our project as it stands right now. So I have taken the liberty of putting together a little bit of UI for us. Okay, so clearly like there is some amount of UI here already at work. However, if we start clicking around a little bit, like, I'm just going to come down here and click on submit. If I click on submit, it definitely appears that nothing happens. If I click on like random artist, well, nothing happens, but I do see a message here that says something like find artist query. So there is some amount of code in play here, but there's still a lot left to be done on this project. So let's open up our code editor and see exactly what we have to work with and what we have to do to get this project working as we expect. So I'm going to open up my code editor inside of our project directory. I'm also going to pull this diagram out of the way. There we go. Okay. So inside of my project directory, I can find a folder in here called database. So I'm going to open up this database folder, and inside of it, you'll find two more files, folders, one named models and the other one named queries. So this is where we're going to be adding a whole bunch of code inside of our project to get our application actually working, because clearly, as we see it right now, not everything is functioning as is expected. So let's look at a couple of different files inside of here and kind of get a better idea of exactly what's going on. Inside of my queries directory, I'm going to find the find artist file. So here's findartist.js. If I open up this file, you'll see that there's some very small amount of code in here already. At the top, we have a require statement for our artist. We have a comment above a function, and that's pretty much it. So here's exactly how this next section, or the entire working on this course, is going to work. Or not the whole course, but this entire app, sorry. What we're going to do is we are going to place a bunch of implementation inside of each of these files, one section at a time. So what I'm going to do is we're going to have one video where we kind of lay out the contents of a single file and like a function and what it kind of has to do. We'll then take a pause where you will work on the implementation yourself, and then we'll come back together and write the implementation together. So this is going to be a great opportunity for you to apply all the knowledge that we just picked up as we were working in the last section doing all this testing stuff. And you're going to be able to see our application come to life as you complete each separate query. So the first query that we're going to work on inside of here is this find artist query. Now we just opened up the find artist file. So if we implement this query and make sure that it follows these requirements that are listed out inside this requirement right here, or in this comment right here, we should magically see this page right here come to life, the random artist page. So whenever I click on a random artist, chances are I'm going to expect to see a list or a single artist appear on the screen. Just to give you a better idea of what this application is going to look like when we're all done, I've got some diagrams of exactly what it should look like. So right now we have seen the search or filter page, and the page that we're on right now where it just says implement this query to see something, this implement find artist query, is what we refer to as the show an artist page. So the application we're working on is all themed around a music browsing or an artist browsing application. So we're imagining that we're working with a big list of musicians here. And as we fill in all these different queries, we're going to start to see a bunch of information for each of our artists appear on the screen. We will also put together a search and filtering page. We will have a page to add new artists, and then a page to edit existing artists. So we're definitely going to get the kind of full spectrum of all different possible operations. You'll also be able to delete existing artists or remove them from the show an artist page. So don't worry, we're going to get all 4 operations in there. So we definitely have a lot of work cut out for ourselves. Let's get started in the next section. There's one last thing that I want to show you before we start actually working on our application. First, I'm going to open up RoboMongo again. If you don't have RoboMongo running again, don't sweat it. I just want to show you something really quick. On the left-hand panel, I'm going to find the local item on here. This means that we're connected to a local server. I'm going to right-click it and then click on Disconnect. Once I've disconnected, I'm going to click on Connect again, and I'm going to connect to my local machine one more time. So essentially I just did that because I wanted to refresh our local connection. Once I do this, you can see that we've got a new database in our local MongoDB installation called upstar_music. If I expand this and then look at the collections, you'll see that I have a collection of artists automatically added inside of here. If I expand one of these records, you'll see that, oh wow, there's already a whole bunch of information about a single artist already loaded up inside this database. So the instant that you started up this application inside right here, so here's our application right here, the instant you started this thing up, it automatically reached out to your local MongoDB database and seeded a bunch of information in here. So you should see a whole bunch of stuff already inside of here. So these are going to be the artists that you're going to be working with. Take a look at a couple of the properties on here. We've got stuff like name, age, image, and notice that image is not an actual image, it's a link to an image. Retired, which is true or false. And then we have a subdocument collection of albums. And every album in here has a title, a date, which is the release date, copies sold, numbered tracks, an image property again, which again is not an actual image, it is a link to an image, and revenue, which is supposed to be like the number or the dollars made by the albums being sold by the artist. So clearly there's a bunch of data already here. So this kind of leads us into step 1 of our project, the first thing that we're going to address inside of here. We've already looked at our queries folder, and we've seen some stuff in here where it's telling us about how we're going to, like find a single artist in the artist collection. But step one, before we can make any type of queries, is to actually put together our artist and album models. Okay, so inside of my models directory, I have the artist file and the album file. So this is going to be the first thing that we're going to tackle inside of this project. Your job is to create a new Mongoose model that satisfies the schema that we just saw in RoboMongo over here. So I'm going to pull up a diagram to kind of give us a good idea of exactly what each the artist and the album should look like. Now I want to tell you right now that the view layer of this application, like all that kind of, all the nice pretty looking graphics, all this kind of stuff, makes a lot of very specific assertions about certain properties being available. So it's extremely important to make sure that everything shows up correctly, that you define all of these properties with exactly the same name and capitalization. Okay, so I want to just make sure that's really clear right now. When you define something like years active, it has to be specifically years and then capital A active. Okay, so just make sure you're following that same terminology. Okay, so what you're going to do right now is we're going to end this video in just a second. You're going to go into your artist.js file and your album.js file, and you're going to put together one model and one schema file for the artist and the album. And then the thing to remember is that the artist has a subdocument of albums. Okay, so you'll make sure that you'll want to make sure that you wire up that association as well. For the type of each of these records, I encourage you to just kind of use your best guess. Okay, use your best guess. So I want you to go ahead and give this a shot. You can go back to our users project and refer to that as a fantastic resource for figuring out how to set all this stuff up. I want you to give it your best shot. We'll take a quick break and then we'll come back and we'll work on this thing together. Okay, so hopefully you had some success putting together the artist model and the album and then wiring the two up. And remember, both these things should have been created inside of our album and artist files in our project directory. So in this section, we're going to go through the implementation of both of these files and make sure that we're both on the same page about where we should be going. So we need to create the artist and the album and then link the two together. The first important thing to recognize is that because the album is a subdocument of artist, album will not be a full model. It is just going to be a schema. So remember, we do not create a model when it's an embedded document. We only create a schema. So let's start off by creating our album. We'll make just the schema, and then we'll work on our artist. Okay, so let's give this a shot. I'm going to flip over to my album file first. I'm going to take out the comment at the top because, hey, we're doing this thing, right? We're starting it right now. So we're going to follow the exact same approach that we used inside of our post schema in the last project we were working with. So I will first start by importing or requiring in Mongoose. So I'll require Mongoose. Then I'll pull off the schema object from Mongoose. Next, we'll create our album schema. So I'll say const album schema equals new schema. Now, I definitely kind of wrung you a little bit with difficulty by saying that you should just have all these properties and just assign the appropriate type to them. And I kind of left you to figure out what they should all be. Hopefully, we'll go through all the different types. I really encourage you, if you used a different type for any of these variables or these properties in here, I encourage you to follow the same types that I'm using. If you have any questions about why I'm using a particular type, I encourage you to leave a comment or discussion on this video, and we'll follow up on exactly why I picked any of these given types. But as we're entering them in, I'll definitely offer up some discussion about each one as well. So first, we'll write our title in. So every album is going to have a title property, title. So our title is probably going to be a string, right? Like we want to have a word for the title of the album. Next is our date, or the date that the album was released. Now, in our users application, we only really ever spoke directly about a string type and a number type. there's another type to be aware of, and that is a date type. So if you didn't get this one, hey, no problem whatsoever. Throughout this entire section, as we're going through all these different queries, I'm definitely going to throw you kind of like out on a cliff a little bit, so to speak. All right, I'm going to kind of push you a little bit to have to do just a little bit of research on your own. If you get tired or frustrated at any point, don't sweat it. You can always go to the next video and go through the walkthrough as well. So I really encourage you not to get frustrated as we go through this. I am going to kind of push you a little bit by requiring you to figure out some stuff that I haven't explicitly stated earlier on in the course just yet. So a little bit more about this date type. Date right here is a reference to the global date object that is available inside of JavaScript. So by specifying date, this tells Mongoose and Mongo we're going to store a date field right here. So our next field, or our next property, will be copies sold. So this is going to be the number of albums that have sold. And of course, hey, reasonable thing here, probably a number, right? Then the number of tracks that the album has. So this is like the number of songs that each album contains. I think, again, a number would be an appropriate designation here. So I'll assign a number type. Next, our image. So let's make sure we're on track here. We got copies sold, numbered tracks, and image. Now, image is a little bit more challenging. When we were looking at RoboMongo, we saw that it was a link to an image. So we're not actually storing an image file here. It is not like a raw JPEG or anything like that. It is a link to an image. That link is going to be a string or a web address, a URL. So I think a type of string here would definitely be appropriate. Finally, our revenue. Now this one is a little bit tricky. Okay, this one definitely requires a little bit of thought. The revenue here is supposed to be the number of dollars, or kind of like the amount of money that the album made. Now you might be thinking, well, revenue we might want to show eventually to a user like $90,000 or something like that. And because we have the $sign in here and the comma, that would definitely indicate that it probably needs to be a string, because this would not be a valid number inside of JavaScript. However, whenever we store any type of currency in Mongo or any type of database, I really encourage you to stick with a just raw number designation, like something like this. And the reason that we go with this route is that if we ever need to convert this to any other type of currency or anything like that, we won't have to first remove the $sign out of the string and take out any commas or anything like that. We can just understand here's the raw numbers in US dollars or whatever currency it's meant to represent. We can multiply it by whatever currency factor, or we can format it, with a $sign and a comma, or maybe just a $sign, or maybe 90K, whatever formatting you might want to do. That is not really relevant for the database. So what I'm kind of getting at here is that I think we should just be storing the raw revenue in dollars, like number style. So I'm going to say that our revenue should be a number. Okay, the last step inside of here, make sure you do not forget to do this. We defined our album schema, and we want to share the code that we just created with other files in our project. So I'm going to make sure that I add in a module.exports album schema. Okay, so there we go. So here's our album schema in total, our entire whole project right here, our entire file. I want to take a quick pause here for just a second before we start on our artist. And I want to mention to you that at any point during these exercises, if you get stuck absolutely anywhere, the best way to get help from me, or to figure out what's going on, is if you can post your project up on GitHub or email it to me directly, like your entire project folder. If you send me both files, I can really easily go through all your code and figure out exactly what's going wrong. Also, once the code is posted, I will make sure that I post some solutions on the official Upstart Music repository as well. So I'm at Upstart Music on my GitHub profile right here. By the time this course is published, you'll see a link to some of the solutions down here as well. So again, if you get stuck anywhere, a lot of different ways to get unstuck. Just let me know, let me help you out. Okay, so album file looks good. Let's take a quick break, come back, and start working on our artist model as well. In the last section, we wrapped up our album schema, and so now we're going to go over some solutions for the artist model. The tricky thing about the artist is to keep in mind that it needs to have a subdocument collection of albums inside of it. So let's get started on the artist. Again, I want to remind you that it's really, really important to make sure that you have identical property names to everything that I have. So in the case of something like years active or net worth or label name, make sure that the second word in there is capitalized. If you don't follow the same property names, the client-side application isn't going to work correctly. Okay, so let's open up our code editor. I've got my album schema, and I'm going to flip over to the artist.js model file. So I'm going to take out the to-do inside of here. And at the top, we will start by importing or requiring in a couple libraries. First, we'll grab Mongoose, of course. So here's Mongoose. And then because I need to get a reference to the album schema so that I can set up my sub-document collection of albums, I'm going to pull in the album schema that we just created. So I'll say const album schema require album, like so. Finally, I need to make a schema inside this file. So I'll say const schema mongoose.schema. Now this is another file that's going to end up looking very similar to the user model that we just created in the last project. So inside of here, we'll start off by defining a artist schema, and then we'll give it some number of properties. So again, we're going to go through all the different properties. I'm going to give you kind of my take on what the type should be. If you have any questions about what the type should be, always feel free to ask me a question. I definitely, again, kind of threw you out on a limb on one of these properties as well, where you might have had a little bit trouble deciding what to name it. So we're going to go over the tricky one inside of here as well. Okay, so we'll start off with the name. The name, I bet you could guess, it's going to be a string, right? Like we've been working with the name for Joe all the time. Joe is definitely a string. Next is the age. So notice that this is not like a born at date. This is just the raw age. Meant to be intended as like years of age. So for this, we're going to say number. If it was something like date of birth, which probably would have been a little bit more realistic, we could have gone with a date value here. But because it's just supposed to be their age, we're sticking with just a number. One thing I do want to say about the age is that recording the age is probably a poor choice on my part. And the reason for that is that, let's say like 1 year goes by, we would have to somehow come through all the different artists that we have and like increment them at some point in time. And because everyone has a different birthday, it'd be kind of challenging to figure out when we should increment their age. But I think you get the idea. Next are years active. So this is supposed to be how many years this artist has been producing music. Given that's a number of years, well, yeah, probably number is going to be a good solution here as well. Now, years active definitely suffers from the same kind of issue as age, where the artist is probably active starting on like, November 1st of 2010 or something like that. And so we would really, in reality, have to know their exact start date. So like active since would have been a better property here. But again, I want to keep it just a little bit simple in this regard. So we're just going with a years active of a number. All right, let's check out how we're doing down our list. Okay, next one's image, genre, website, and so on. So the image, this one's gonna be very similar to the image that we were just working with inside the album as well. So again, this is not an actual image file like a JPEG or something like that. It is a URL to an image. So again, we're gonna go with a string. Then the genre, this would be like rock, classic, hip hop, pop, whatever it is people listen to, I don't know. So probably gonna be a string. Next, the artist website. Now we've kind of already spoken a little bit about like URLs in the case of images. So just the same way, our website should probably be a string as well. Our net worth, which is how much this artist is worth. Well, again, we spoke about this with albums. Dollars or currency is best represented by just a strict number. So we'll go with just like, the number of dollars that they have. Now, the situation with net worth and revenue on albums, you've been hearing me say like, oh yeah, it's been currency like dollars, right? In a a global type world where you have an international application, where you might be working with many different types of currency, it would really be worth requiring or annotating the type of currency this is. possibly as like a separate property. Alternatively, you can have like a global understanding that all the currency values in your application might be like US dollars or whatever appropriate currency. I'm definitely making the assumption throughout my entire schema that this is going to be US dollars for all currency that you see. All right, back on track, the label name. So this is like the company who is producing or managing this actual artist. We could definitely have a case for a separate collection of labels here or a subdocument of the label who manages this artist. But because I'm specifically saying the name of the label as opposed to like the name of the label, their managers, the years that the label has been in existence, all that kind of stuff, because we're not recording that, we're just recording the name, I think that it's 100% reasonable to just say the string of that label's name. Okay, so let's check out our schema again. We're down to two of the more challenging ones. So first, retired. So retired is meant to indicate whether or not this artist is currently like, not retired, like still developing music of some sort. So this is kind of like a yes or no question. Is the artist retired or are they not? So it's kind of like a Boolean of sorts. And so this is another type where I really threw you out on a limb, and we've not spoken about this type in particular just yet. So to express a Boolean here, like true, they are retired, or false, they are not retired, we get the Boolean type. So the Boolean type is going to say, yep, retired, or no, they're not. Again, I apologize for throwing you out on a limb without giving a lot of discussion about this. On future sections, when we're gonna go through some of these other things that include some topics I haven't spoken about, I'll be sure to link you to some documentation ahead of time. But for this first one, I kind of wanted to just really have you go through a little bit of a struggle. Sorry. Okay, last property, albums. This is going to be a subdocument collection. We've gone through that previously with users and posts. So a artist will probably have many albums. So I'd expect this to be an array. And it's going to be using the album schema. Whew. Okay, so hopefully that's a little bit enlightening on all the different types that we have inside of here. I definitely mentioned a lot of these, like say net worth, label name, age, and years active, definitely debatable approaches here, right? Like we could have definitely gone different direction here, but that's absolutely part of what learning about Mongo and databases in general comes down to. It's all about having some insight or design or plan ahead of time on how you think this data is going to behave and change over time. So that's definitely part of, it's up for interpretation. I think that's what I'm trying to say. So last thing that we're going to do inside this file is take this artist schema and create a model out of it. So remember, when we have a schema that represents a collection, which we do in this case, we need to actually turn it into a model. So underneath the schema, we'll say const artist is mongoose.model. It's going to be an artist, and we're going to pass in the artist schema. And then finally at the bottom, do not forget this extremely important line of code. We're going to be sure to export the model that we just created. Okay, so I think that's it for our first two models inside of here. Let's continue in the next section, and we're going to start working on all of the different queries inside of our application. In the last section, we finished up our artist model. So we've now got our artist model, our album schema, and the two of them are wired together successfully. Now, we've only put together the models, so I don't really expect any part of my application to be quite working just yet. We actually have to put together all of our queries before any of that stuff's going to start working. Nonetheless, I really encourage you to flip over to the application as it's running. Remember that you can stop it and start it at any time from the console. I can stop it by hitting Control-C, like so, and that'll stop it. And I can start it back up by running npm run start. So when I run npm run start, we're going to get a little bit of a boot up process. This window will come up. It'll be a white screen for a second. And in the background, I'll wait for a webpack is valid message. Yep, there it is. And now over in the window again, I can go up to view, hit reload. And in just a second, Or maybe, okay, there we go. I see everything pop up. Very good. Now, the one thing that I want you to do really quick is to, in the terminal, make sure that you don't have any errors inside of here. If you make any typo at any point in time, you'll see it appear as a big red error message inside of here. So scroll up to the error message, see if you can't find it, and figure out what's going on and do a little bit of troubleshooting. It's most likely that you might have a typo as you're going through all these, these exercises. If you can't troubleshoot the issue, if it's just kind of not quite, you can't quite make sense of it, feel free to reach out to me and I'll help you troubleshoot the issue. Of course, you can always pull down the project files and compare your code line by line. Okay, so we're done with our first two and only models, which means that it's now time to start working on our first query. So inside of my queries directory, I'm going to find my find artist file. Now the purpose of each of these so-called query files is to take in some arguments, manipulate our database in some way, and then return a promise that resolves with some amount of data. So that is going to be a common thread through every single one of these queries that we write. We'll take in some arguments, do some database operation, and then return the result. Okay, so that's the very common thread through each of these. So the first one we're going to be working on is find artist. The purpose of find artist, or this function that we're going to be working on inside of here, is to find a single artist in the artist collection. So in our last application, we had a collection of users. We were always working with users. This time around, we're working with a collection of so-called artists. Now, when we find a single artist, we want to find a very particular artist, the one that is indicated by this ID argument. So in the life cycle of this application we're working on, at some point in time, this function will be called with the ID of a very particular artist. It is up to you to write some code inside of here that is going to reach into the user collection, find the artist with this particular ID, and then return it out of here, okay? So for this first time around, I just want to give you a little bit of a hint just to put you on the right path here, just to show you the kind of general structure. Inside of every test that we wrote, we were saying something like artist.find or remove or update, whatever it was. And then for the purposes of our test, we would always chain on a .then, right? Like in every case, we always added on the .then. The purpose of the .then was so that we could immediately make an assertion about what this query right here was returning. In this application, however, some other part of the code base is going to chain on the .then for us. So what I'm trying to say here is that in the vast majority of these exercises that we're going to go through, you probably do not have to chain on the .then. And that's why the comment on here specifically says a promise that resolves with the artist. So you're not going to try to return the actual artist itself. You just want to make the query and then return it, and some other part of the application will receive that query and resolve it in some fashion. Okay, so just to make sure we're clear. The second thing that I want to point out to you is that almost every function that we write, and actually let me take that back, every single function we write, every last one, you need to make sure that you at some point in time return a query. Okay, so make sure that you always get that return keyword in here. You are always going to be using the return keyword because we are including the curly braces on every one of these functions. Unlike the tests that we were writing where sometimes we would omit the curly braces, and when we were doing that, we got the implicit return, which is part of the fat arrow function. Okay, so in summary, remember, always toss on that return keyword. Okay, so I'm going to clear this thing out. And for this first exercise, I know we did a lot of lead up here. In the future, we won't have to do quite so much. I just want to make sure we're on the same page for this first exercise. So give this your best shot. Again, your job is to find a single artist in the artist collection using this very particular ID. So give it a shot. We'll come back in the next section and go over a solution. All right, hopefully this first query that we were working on was not the worst thing in the world. I'll tell you right now that the first couple of queries we go through are going to be a little bit on the simple side, just to make sure you got a grasp on these core concepts. But as we start working on some of the other ones, trust me, they're going to start to get really, really tough. Okay, so for the first three or so, nice and easy, then we're going to really ramp up in difficulty. So for this first one, let me tell you, don't overcomplicate things. It's going to be just like the code that we were just writing inside of our tests. So we want to find a record, just one, with a very particular ID. So there's two ways we can tackle this. I'm going to show you both ways. Inside of here, I'm going to put return, because again, we want to return every single query or promise that we come up with. Artist, and I want to find just one entry, just one. Okay, so I'm going to use find one as opposed to find. And inside of here, I want to look at the ID property of every record and find one with this very particular ID. So this is my searching criteria right here. I would have most closely related this one. We had an example very similar to this when we were writing our tests around the user model. We certainly had a test in there that it was something like user.find with a name of Joe, right? We definitely had that in there, or excuse me, find one. And so this is very similar syntax right here. Find me one artist with this particular ID, okay? All right, so I'm going to save this file with just this query inside of here. We'll go through over the alternate solution in just a second. And I'm going to open up my application again. I'm going to make sure that I expand the window enough to see the random artist button on the right-hand side, and then I'll refresh the page. And sometimes it just takes a second to go. If it ever feels like it's really not refreshing, you can check the terminal to see if you have any errors over here. Alternatively, you can go up to View and then toggle Developer Tools. And then inside of here, go to the Console tab. Here we go, Console tab right here, and see if you have any errors over here as well. Sometimes you'll see them over here. And just for the purposes of going through all this stuff, I'm going to leave this console open on the right-hand side, just so I can see if I have any errors. Okay, so here we go. Once I'm here, I have now implemented that find artist query. So I'm going to go to the random artist tab, and all right, hot dog. When I click this, I can see a random artist appear up on the screen. The random artist has the artist name, which, okay, I'm going to tell you right now, this is all randomly generated data. So sometimes it's going to be a little bit weird. So Hazel Nolan, who's a master of blog rap, all right, 12 years active, 35 years old, and some label. Let's look again. I got my artist, here we go. Mrs. Janie Rippin, master of, all right. And here's some artists that they have, or excuse me, some albums. So 5 tracks, and all right, well, hey, looks like it's working, not bad. So this is definitely working out so far for this first query. So let's look at an alternative approach here to this find one. I'm going to pull up the Mongoose documentation. So I want to show you the documentation a little bit. Inside of Google, I'm going to look for Mongoose JS, and we're going to go to the Mongoose homepage. So here's Mongoose ODM. Right in the middle of the screen, I'll click on Read the Docs. And then on the left-hand side, I'm going to scroll down until I see API docs right here at the very bottom left. So I got to tell you, I don't normally toot my own horn too much, but these API docs are pretty much exactly why I made this course. These API docs are, I really don't like these API docs at all. I'm just going to say it right now. Here's why. If you want to find some documentation about the find one function on a model, okay, let's figure out how we find the find one function inside of here. Okay, so we'll scroll on the left-hand side. Okay, find one. I don't really see anything about find one in particular. I see a bunch of JS files. I don't know. Okay, well, here's model. Let's look at model. Okay, model where, increment, model, remove, save. Boy, we have to do a lot of scrolling. And even as I'm doing all this scrolling, I don't really see the find where, or excuse me, find one. So let's try searching for find one. How about that? I'll search for find one. Okay, fantastic. I have 66 results that I have to scroll through until I finally see, query find one. But we're not really working with the query here, we're working with the model. Okay, you definitely get the idea where I'm coming from, right? These API docs are not fun at all. They're really hard to digest. But anyways, back on topic. I told you that I would show you a different way to find an artist with a particular ID. So there's one other function that we could use here. It's called find by ID. And even then, when I search for it, I have to, go, okay, hey, finally, all right, here it is. My goodness. All right. So we can call find by ID with our model and pass in an ID as the first argument. And that's pretty much it. Okay, so it's going to behave identically the same as find one. And even the documentation here says is almost equivalent to find one. So nearly equivalent. That's good enough for us. Let's try changing this out. I'm going to say instead of find one, I'll say find by ID. And then as the first and only argument, I'm going to pass in the ID. So I'll save this. Let's flip back over. I'll refresh. Let it do its little thing. And okay, so now I can, yep, definitely still works. Fantastic. Okay, so that's our find one or our find artist query. Let's continue on into the next section and figure out which query we're going to work on next. We've now wrapped up our first query, the find artist query. And so now we're going to move on to our next one. Inside of my code editor, I'm going to find my queries directory and then open up the create artist file. So this file is intended to have an operation inside this function right here that will take some properties that represent a new artist and insert them into our collection of artists in MongoDB. So let's check out where this thing is going to be called from within our application. I'm going to open up our app. I'll scroll up to the top, and on the very top right-hand side, you'll find a button that says Create Artist. So if we click this, we'll see a form where we can input a name, age, years active, and genre. That's it. Now you'll notice that we don't really have a lot of fields in here, like all the fields for handling images and revenue and stuff like that, or even albums. I wanted to very purposefully keep this form a little bit simpler. So once we insert artists ourselves, they're going to have only kind of like a subset of the required properties or properties that kind of look nice inside of our artist detail screen right here. But nonetheless, again, I just want to keep this form just a little bit more straightforward. Okay, so let's see exactly what type of data this function that we need to write is going to be called with. I'm going to go in here and add in a console log for this artist props argument. Then I'm going to flip over to our app again. I'll hit Command R or Control R if you're on Windows to refresh the screen. And then once the form actually loads up, there we go. I'm going to enter in a name of, how about Swinda Songster. I'm awful. I have no idea. They'll have an age of 20. Maybe they've been active for 5 years, and their genre is going to be rock. So let's submit this. And when we do, okay, there's our console log right there. So you'll see that our function gets called with an age, a genre, name, and years active. That's pretty much, all the data we need to make at least some start of an artist or insert this into our collection of artists. So it's going to be up to you to take a little bit of time, figure out how we're going to take this object with all these different properties, insert it into our artist collection. And remember, the whole goal here at the end, the thing that you want to return is a promise that will resolve with the artist that was created. So we've really accomplished this type of operation before. We did this back with our user app. If you need any help, feel free to flip back to that application and take reference to how we were inserting records back there. Okay, so go ahead and give us a shot. I'll see you in just a second and we'll go over some solutions. All right, hopefully you got through creating the artist A-OK. If you succeeded, if you go to this form and enter in some attributes and then click submit, you should be automatically redirected to a screen where you will see some details about the artist that you just created. Okay, so let's go through the actual solution now, and then we'll test it out inside of our application. Back inside of my create artist file, I'm going to take out the console log because I don't really need it anymore. Then inside of here, we need to take these artist props or this kind of like data for new artists that we want to create. We'll create an instance of an artist and then we'll call save on it. And that will have the effect of inserting a new artist into our artist collection. So I'm going to say const artist equals new artist, and we're going to pass in the artist props. So the real key here to recognize, or the real tough part to understand, is that in all past situations where we've created a new instance of a record at any point in time, we were always saying something like new user and then directly passing in something like name with Joe. So the challenge this time around was to recognize that this artist props thing right here has all the data about the new artist that we want to create. And so we're passing in a variable that contains an object instead of an actual object literal inside of here. So now that we've created our instance of an artist, we can call artist.save like so. That's going to insert our artist into our collection of artists. Then the very last thing to remember is that the way in which all these functions are written, they all assume that you are going to be returning a promise that will resolve with the whatever operation. So we need to make sure that when we call artist.save, we just have to return it. This last thing on here, the return statement, again, common thread for every single operation that we're going to write. At the very last line, you're always going to want to be returning some value. Okay, let's flip back over to our application and see how we're doing. So I'm going to refresh over here. We'll wait for the really long reload time. There it is. So now we'll do Swinda Songster, age of 25 this time, 5 years active, and her genre, let's go with rock. So we'll submit. And awesome, we get redirected over to a screen with some details about Swinda Songster. Again, we're not filling out all the data inside of here. I just very purposely wanted to keep these forms that we were putting together very small so that if you had to go back and test a whole bunch, you didn't have to type in a bunch of album data every single time. We could very easily expand the forms out if we wanted to. It's really not tied to Mongo at all. I just wanted to make sure you can very rapidly test inserting a lot of artists. Okay, this looks fantastic. We're definitely inserting new artist into our artist collection. Let's continue in the next section and start working on our next query. We've now added in our two first queries, both find artist and create artist. There's two more basic operations that I want to go through, both deleting an artist and editing or updating an artist. And then we're going to start to get into some of the really tough queries. Okay, so again, we're going to go through a little bit of the easier ones first, and then we're going to get into the really tough ones towards the end. So the next query that we're going to work on, or the next operation, will revolve around deleting an artist. So I just opened up my delete artist file inside of my queries directory. So if we look at the comments on this one, it deletes a single artist from the artist collection. So this function right here will be called with the ID of the record or the ID of the artist that we want to delete. So it's up to us to find this record in the artist collection and delete it. This is another operation that we went through a couple different ways over on our users application. So I encourage you to go back and check out how we did things over there, and feel free to kind of copy or take, I don't want to say copy, I want to say take inspiration from that implementation when implementing this delete one. Once you write out the delete artist query right here, you can refresh your application, then go to the detail screen for a single artist by clicking on the random artist button up here. And then you should be able to click on delete right here, and that should delete the artist for you. Once the artist is deleted, you shouldn't be able to find them again in the random artist selection up here. Now do note that this delete operation is a little bit tougher to test right now because we don't really have any good way of listing out all the different artists that we have, right? So it's total luck of the draw if you're clicking on random artists a whole bunch to be able to verify that an artist was successfully deleted. So if you want to make sure that your artist actually did get deleted, you can always open up RoboMongo and look through all of your different artists inside of here and just verify that one was actually deleted. Of course, you can also just look at the number of records you have, and after clicking delete, yeah, you should probably have one less. Okay, I think you get a pretty good idea of how this one's going to work. So I'm going to let you get to it, and then we'll come back in the next section and go over some solutions for deleting a very particular artist. Okay, hopefully you had some solution in putting together the operation that will delete a singular artist. So without beating around the bush too much, I'm going to throw a query in here. I'm going to throw in one solution, and then we'll come back and look at another possible solution, and we'll discuss why the other possible one would not be a very good choice. So inside of here, I'm going to take my artist collection. I'm going to say remove any record that matches this given criteria in an object that I'm going to pass in. So go through the artist collection. If any artist has an ID of ID, then go ahead and remove them. So notice that the underscore ID right here, this is what the function is being called with. So this is going to be an actual ID of a record to remove. And so we're passing in as the value to this object. Now we can use a little bit of ES6 to clean up this statement right here. Because the key and the value of this object are identical, we can condense this whole statement down to just ID like so. So I've got curly brace, ID, curly brace to close. This is 100% equal to :_ID, like what we had before. Okay, so now at the right before the operation, we'll make sure that we return this thing. That's a requirement of every one of these functions that we're going to make. So let's get this to test out inside of our application, and then we'll talk about the alternative solution really quick. So I'm going to open up our app. I'm going to make sure that I refresh the page to get the new code that we just loaded or added in. Once the page is actually loaded up, I'm going to click random artist a couple times and just pick out a random artist to delete. Okay, Shirley, I'm sorry, but I think you're going to have to go. So just to make sure that our record actually gets updated, I'm going to first flip over to RoboMongo. I'm going to refresh the collection over here by hitting Command R. And I can take note that, let's see, I have records going from 1 to 13 right now. So now I'm going to go back to my application. I'm going to click delete. This sends me back to the unfinished screen that we have here right now. And then if I go back to RoboMongo and refresh again, I'm down to 12 records. So it looks like we are definitely deleting a record right now. Perfect. Okay, let's talk a little bit about a possible alternative solution. Now this is a solution that I just really want to steer you away from. In general, whenever you're using Mongoose with Mongo, there tends to be a one-step solution for many different problems, like probably the vast majority of problems that you're ever going to run into with working with Mongo. And what I mean by that is doing stuff like creating, editing, deleting records. Usually there's going to be a one-step approach for doing what you want to do. That is in juxtaposition to doing something a little bit more like artist.findById, finding this record, chaining on a .then, taking the artist, and then calling artist.remove, okay? So this is an alternative solution that I'm going to tell you you're probably not going to want to use. And the reason for this is that we are touching our database twice. We first touch our database to pull a record out, and then we touch it again to actually remove it. So this is a two-step operation right here. It's going to take, in theory, I'm just going to throw a random number out there. I'm just going to say, in theory, twice as long. So whenever you get the feeling that, hey, maybe you can probably condense this down to a single operation, I definitely encourage you to do so. So I'm going to definitely stick with a solution of artist.remove, and we want to remove this record with that particular ID. One step, everything's done. All right, one more simple, I don't want to say simple, but I will say a little bit more straightforward query that we're going to take care of inside the next section. And then we're going to start diving into some of the really tough ones inside of this app. So let's get through one more kind of beginner or ice-breaking query in the next section, and then we'll start on these much more difficult ones after that. All right, on to the last of our basic operations as far as creating, deleting, finding, and editing an artist goes. So inside my queries directory, I'm going to open up my edit artist file. So this is going to be the last of the kind of a little bit more straightforward queries we're going to work on. This function has two arguments, unlike all the other ones that we've been working on. The first argument is the ID of the record that we want to update, and then the second argument is an object that contains the name, age, years active, blah, 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 of all the different properties that we want to update on this given artist. So let's find where in the UI this thing is actually called from. Inside the UI, I'm going to click on Random Artist, and then on the left-hand side, I'll click on Edit. So when I click on Edit, I am taken to a form, and inside of here, I get all the properties of that artist pre-populated inside of here. So now I could freely make changes to this, like let's say they've been years active only 3, whatever. And then we can click on submit to actually submit this record and get the update reflected inside of our database. So that's where our logic is going to start to come into play. I'm going to add in a console log really quick just to look at the 2 properties or arguments that this function gets called with. So now I'm going to refresh my app, wait for the long reload time. Now again, I'm going to clear out the 12 years that I have in here. I'm going to take it down to just 3. I'll click on submit, and then we can see the console log. So the first argument, again, it's our ID. We've definitely worked with IDs quite a good bit. And then the second argument is an object containing the age, genre, name, and years active, which is now the updated value of 3. One thing that you'll notice inside of here is that years active is being passed in as a string of 3. So this form right here is clearly not really able to distinguish between numbers and strings that we enter into it. It's just assuming that everything that we change inside of here is going to be a string. This is part of where our schema for our artist model comes into play. Because we defined our years active as an integer, or a number, Mongoose is going to automatically take this string right here, turn it into a number for us, and save it off to the database. Okay, so now that we've got a reasonable idea of the arguments that this thing is going to be called with, I'm going to let you take it away to update the artist with this very particular ID. Again, don't forget, you can always go back to the user application and reference that thing to get a better idea of how to pull this off. So I'll see you in just a second, and we'll go over some solutions. All right, hopefully you had some success with updating an artist. Once you have the correct query in here, you should be able to add in some new information in here, click submit, and then be taken to the artist detail page and see the new or updated information reflected in there. So let's fill in our query and make sure that's the case for us. I'm going to take out the console log that I have in here. We're definitely not going to need this anymore. So let's write in our query. I'm going to look at my entire collection of artists. So I want to reference my artist model, which is already required in at the top of this file, and I want to update a very particular record. So the first argument to this update function is some criteria that we are going to use to specify which records we want to update. So I will pass in an object of ID and ID. So this is going to say find an artist with this very particular ID in my artist collection. Now again, because I have an identical key and value to this object, I can use a little bit of ES6 to condense it down to just ID inside of curly braces like so. So this should be selecting the correct artist. Now it's up to us to specify a second argument and tell this artist how we want it to be updated. So as a second argument, we'll pass in the updated properties to the update function. So I'll specify artist props like so. And then again, let's not forget, we need to return this whole thing. So find a very particular artist, update them with this set of properties. Let's test this out over in our application. I'll flip back over. I'm going to refresh. We'll wait for that really long refresh to occur. There we go. And I think, again, I'll take the 12 down to a 3. So we'll go to 3 years active. So now I'm going to click submit, and instantly I see 3 years active reflected on the edit page. So now I should be able to edit again, put in 13 this time, submit, and now 13 years active. All right, this looks fantastic. I think we're making great progress here. One last thing that I want to say about the this artist update function that we're using right here, exact same thing as what I was mentioning about delete earlier. We would not want to take the approach of doing like artist.find1 or find by ID, finding the artist, taking the model, and then calling update on that, or calling like set and save on that, or taking that type of just general approach, that kind of two-step approach. Wherever possible, we always want to do everything inside of a single operation or a single touch of our Mongo database. So this is it for our 4 basic queries or 4 basic operations that we're going to write for our application. We've covered creating, deleting, editing, and reading a single artist at a time. So from here on out, we're going to go through some of the more challenging queries that we're going to have. So let's take a quick break and then talk about our next little bit more challenging query. I'll see you in just a second. All right, that's pretty much it for the kind of a little bit more straightforward queries. Everything from here on out, we're going to dial up the difficulty a little bit. So let's check out the next query that we're going to be working on. I'm going to close out all the files I have open just to clean things up a little bit. And I'm going to open up two files. First, get age range, and then get years active range. All right, so I got both these files open. Let's see where these queries are used first, and then we'll come back and talk a little bit about the queries themselves. So here we go. I'm going to open up I'm going to click the link on the very top left-hand side. And I'm going to look at the search panel on the left-hand side. On here, you'll notice that there's two age and years active sliders. And right now they range from 0 to 100. Now I can kind of like drag them in like so. In theory, what we'd be doing with these two sliders is filtering down the age range or the years active range of some search results that we get back from the search operation. Now we have not yet wired up any like searching stuff. Right now we are just wiring up something to give a minimum and maximum range to both these sliders. Okay, that's the goal. It doesn't make like a lot of sense to be able to allow users to select all the way up to like 100 years active if the greatest years active that we have for any artist is something like, 30. So what we want to do here is find the minimum years active for any artist that we have, and then find the maximum years active for any artist we have. Then we'll repeat the same thing for age as well. So both these queries are going to be nearly identical. Actually, I will say just flat out, yeah, they're going to be pretty much identical for both age range and years active. So the only difference is the property that we're looking at. So I want to give you just a little bit of a tip for writing this query out. Okay, so you're going to take care of both of these in one go. Just to be clear, you're going to take care of both these files, implement both of them. And that tip, well, let's take a look at a diagram really quick. So this is a diagram of my artist collection. On the left-hand side, I've only reflected the age of every record. Okay, so this is like, these are each distinct artists, but I'm only labeling their age on here. When our artists get saved to the artist collection, they are not put in there in any particular order. They are completely randomized. So we might have the first entry with an age of 30, then 22, 43, and 14. If I want to very easily find the minimum record, or the record with the minimum age, what I could possibly do is sort the entire collection by age, and then I would have something that looks like this on the right: 14, 22, 30, and 43. Now because they are all sorted by age, I can take just the first record, so I will limit the number of records I get back from my query, and look at the age on that record. So I can sort, limit, and that must be the minimum age. Likewise, if I sorted by going from maximum to minimum age, I would end up with 43 as the first record. And so I could just limit to just the first record that I get back from the query and end up with 43. Now the second thing to keep in mind here is that we can't really do these two sorting operations in one go, right? Like if we want to sort from lowest to greatest age, and then also sort from greatest to lowest, well, that's really two separate sorting operations. So you might end up having to actually write out two separate queries here and combine them together using the promise.all helper. Now the last thing I want to tell you here is that the expected return value here is still going to be a promise. So like the return thing that you're going to return here is still going to be a promise, but the promise needs to resolve with an object that looks like this, like minimum of 16 and maximum of 45. Okay, that is what you need to make sure the thing resolves with. So you might have a kind of intermediate calculation step in there where you take the two results that you pull back, like the minimum record and the maximum record, and then create an object that has a minimum and a maximum property to it. All right, one last thing. Just in case you get any really bad errors, like stuff starts really going wrong here as you start to test out the query, if you can't like get this window to refresh, you can't get the app to refresh or anything like that, you can always flip back over to the terminal, find the running process. So where's our process? Here it is. You can stop it by hitting Control-C, and then just start the entire process back up again with npm start. So you only have to do this if everything becomes like totally responsive or unresponsive. And that might be the case if your query is like really not running appropriately. So I just want to throw that little tip out there. Also keep in mind that when you restart this thing back up, you got to wait for that bundle is now valid message, and then you can do the reload and see the app actually appear on the screen. Okay, so that's quite a bit of prep. I'm going to leave you to it. I'm going to let you take a shot at both these queries. Remember, you're going to tackle both get age range and get years active. And the two of them are going to be essentially identical. So go ahead, give it a shot, and I'll catch you in the next section. Okay, hopefully this query was not too frustrating. I gotta tell you, we just amped up the difficulty by like a factor of 20 compared to the last 4 queries that we were working on. So this one really amped up the difficulty in a very big way. It really requires you to have a pretty good understanding of every last aspect of making a query, and especially promises as well. So let's write out the query. We're going to start off with the get age range one first, and then we will go over to get years active range. Again, both these queries are going to be nearly identical, so we're going to write out one and then probably just copy paste it all over to the other file and make a quick change or two. So let's check out a diagram just to make sure that we're still on the same page here. Our goal is going to take our list of artists. We're going to take all of the artists in that collection. We'll sort them into a very specific order, and we're going to take just the first entry out of there. So let's start off by finding our minimum age first. So we'll do that with a single query, and then we'll come back and rewrite a second query that's going to find the maximum age. And we're going to combine the two of them together with a promise.all call. Okay? So first we'll start off with our min query. So this is going to be the query that's going to find our minimum age. So we'll say artist. We're going to find every last artist we have. Okay, I want to consider every artist in our artist collection. We'll then sort by the age, and I want to sort from the lowest value to the highest value. So an ascending sort can be done by passing in 1 to the sort function. 1 here means sort in an ascending fashion, go from minimum to maximum. Now here's the key part. I only want to get back the very first artist, because that first artist is going to be the one with the minimum age. Okay, I only want to get back the first one here. So I'm going to say limit 1. Only give me the first one. One very important thing to note, and I didn't really discuss this while we were going through the while we were talking about the limit function in the first place, or this limit modifier right here. Here's an alternative solution, something you could have done, and I'm going to tell you right now, do not do this. Okay, you definitely do not want to take this approach. I could have said something like .then, take all of my artists, and then return the first artist, like so. This right here is a very poor approach. The reason that this is a poor approach is that it's going to return we're going to find every last artist that we have. The important thing to keep in mind about all these queries is that the first half of this thing, like all of this right here, is all a query that's going to take place in the MongoDB world. Okay, this is all operation. This is an entire operation that MongoDB is going to entirely sort out for us. Excuse me. As soon as we add on that .then, it means, okay, execute this query up here, and then load all of the results back to my Node.js environment, back to my server. So if I took this approach right here, this artist array right here could be an array of like tens or hundreds or thousands or tens of thousands of records that I'm trying to load up to my Node server, which I absolutely do not want to do. We always want to minimize the number of records that get returned from our MongoDB database. And so using a limit of 1 makes sure that happens. It makes sure that Mongo is only going to try to communicate back a single record as opposed to a giant number of records or a giant list of records. So that's why we would always prefer to use limit 1 as opposed to just taking all the artists and then just taking out the first one. Okay, so I think that this is a good place right here. We're finding all the records, we're sorting them by age, and then we're just returning the first article or the first artist. Now the last step that I'm going to do on this query is definitely where, this is where things get a little bit tough. Okay, I'm going to put on one more clause here. Because I only care about the age of this artist, as it comes back from this query right here. I only care about the age, right? We don't care about the artist's name or their revenue or their albums or anything like that. I'm going to add on a .then statement. I'm going to take the list of artists that get returned. I'm going to say take the first artist out of there and give me their age. Okay. So this line right here might be a big surprise. You might look at this and say, Stephen, where in the world is this coming from? So the first thing to keep in mind is the terminology that I used. I said I'm going to take my list of artists. So because I used limit.1, that does not mean that the query is going to resolve with a single object, like just a model by itself. Because I used the find helper right here, that means give me back a list of artists or an array of artists. So even though I limited that list to 1, it doesn't mean that we're only going to get this thing called with just a model by itself. It's still going to be an array of models, but there just is only going to be 1 in there. Okay, so that's challenge number 1, recognizing that this is still going to be an array because we used find, but there's only going to be a single artist inside of that array. So then the next challenging thing is to ask yourself, well, Stephen, why are we doing this line here at all? Why are we adding on this .then? The reason that we're doing this is just a little bit of kind of massaging our API response. That's probably what I would say. By adding on this line right here, it means that if we add on any subsequent .then on the future, anywhere else, by taking this min query and adding on a .then, it will be called with just the age, just the minimum age to be precise. So if we add on a .then to this query, lower down inside this function, it will be called with just the min age, which is the only property that we actually care about off this artist. So this line right here in total, this .then, is just to make sure, or just to kind of give ourselves a nice kind of termination to this query. Okay, so that's to find our minimum age. So now we're going to take the exact same process again. We're going to take all of our artists, we're going to sort, but this time by descending age, limit 1, and then just pull off the age itself. So let's do it. We're going to make a separate query because we cannot sort by both, one way and then the other way inside of a single query. We'll say artist, we'll find every artist we have. We'll sort by age again, but this time we want to be sorting by descending age. So to sort in a descending fashion, we pass in -1 instead. Now we will limit just the first artist, and finally we're going to add on that same .then. So take the list of artists, of which there's only going to be 1 because we limit it to 1, and then just pull off their age. So now we have 2 queries, a minimum and maximum query, that will both resolve with just an age value. Okay, it's not going to resolve with the entire artist, it's just going to be the age by itself. So getting this far was definitely challenging. Okay, so if you got this far, nice job. I gotta tell you, this has been the difficulty of these queries definitely took a huge jump between the last section and this one. So the next thing we need to do is recognize that we do not want to really have to do anything until both of these queries resolve. So we want them to both run simultaneously, and then when they both resolve, we want to make use of the ages that they are resolved with. So because we have 2 separate operations that are going to reach out to our Mongo database, we will combine them together with a promise.all. With promise.all, we pass in an array of promises. So we'll pass in min query and max query. So min query and max query, like so. Also note that I am returning the result of promise.all because that, again, is the expected return value of this whole function. It has to be a promise that resolves with blah, 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 blah. Okay, so the promise.all will be resolved when both the min and max are complete. The last thing to keep in mind here is the little bit of landmine right here at the end. The promise is expected to resolve not with a model this time around, like we did with the previous ones, but with an object containing the min and max ages, like this right here. Okay, so this is the form of the object that we want this promise to be resolved with. So we will add on a dot then. This dot then is going to be called with the result. I'm just going to term it, I'm just going to arbitrarily call it result here. We could have just as easily called it like ages or something like that. I'm just going to call it result. Because the first element in this array was the minimum query and the second element in the array was the max query, the first element in result will be the minimum age, and then the second element will be the maximum age. Okay, so we'll return a min of result at 0 and a max of result at 1. All right, so that last little bit, another little tough part to keep in mind. Remember, on both the minimum and query, inside of the dot then that we ended this thing with, we plucked off just the age. We said, look at that first artist, give me just the age back. That means that at any subsequent dot then that we chain on to max query, like this one right here, exactly this right here, we will receive just the age back from that query. So because we are combining together min query and max query, we receive in an array just the minimum age and the max age. So inside of result, we can take just the minimum and just the maximum and return it inside this overall object. So now, at the very end of the day, like as this all comes, as this is all complete, if we imagine that this entire function right here, this entire thing is called something like dot or get age range, and we call it, and then we chain on a dot then, this dot then would be applied onto this promise.all right here. And so if we put on, like argument or something like that, and we said console.log argument, we would end up with an object that looks like min of, 14 and max of 35. Okay, so that's what this thing would look like in usage. It's a very, we hit a lot of very complex logic inside of here, but the upside to that is that we end up with a very, kind of elegant looking query right here. It's very simple, very straightforward to use for anyone else who's kind of like looking at this thing. A lot of complicated code tucked inside of here, a lot of assumptions, but for anyone else using the query, they get to just say, hey, get the age range, and then here's an object containing the minimum and maximum. All right, again, this was a really tough one. If you didn't get this one, do not sweat it, don't sweat it, don't sweat it. This is why we're going through exercises, so you can get practice, right? And so you can make mistakes, and it's when you make mistakes that you really start to learn stuff. Now the very last thing we need to do is duplicate this query over to the getYearsActiveRange file. So I'm going to take the contents of this function, everything from the first const inside of here, all the way down to the end of the promise.all. I'm going to copy all of it. I'm going to flip over to getYearsActiveRange. I'm going to paste it in here. And then I'm going to make sure that I update age all the way throughout this file or this query to years active. So instead of looking at age, we're looking at years active. Years active, years active, and I think that's about it. So we made sure that we are now sorting by years active, and when we find the artist with the minimum years active, we pull off that years active property. So now I'll save this file as well. I'm gonna make sure that I save both these files. Okay, so definitely both files are saved right now. Okay, time to test this thing out. I'm gonna open up our application. I will refresh it. The application should automatically call both those queries for me, so I shouldn't have to actually do anything. And as you can see on the left-hand side, I now have a age range slider that has much more realistic results than before. So it appears that the minimum age of any artist I have is 20, and the maximum is 43. It's entirely possible, because this is all randomly generated data, that you're going to have a different range and different years active than I. I think that the randomly generated artists that I added in here will take anywhere from a minimum age of like 14 all the way up to like 44. So you might see numbers within that range, and then years active I think spans from like 0 to 15. So now in theory, once we wire together all this search stuff, if I want to see just artists under the age of 30, I could drag down my slider like so, and then we could, in theory, hit submit and see only artists with a range between 20 and 30. Okay, that's it. That's it for the really tough queries here. Let's continue in the next section and start working on our next query. We've now wrapped up the most challenging query so far, which was the get active years range and the get age range queries. The difficulty curve is not going to let up though. We're going to move on to what might be the most challenging query that we're going to write overall, which is the search artist query. So I'm going to open up this file. Let's take a look at it. So this is definitely a pretty hefty chunk of work. There's a lot of moving pieces around this query, and so we're going to tackle this in a series of steps. Okay, so we're not going to do the entire thing in one go. We're going to do it in a series of steps. The purpose of this query right here is to populate the result set that we see inside this application right here. So if I click on Upstart Music, we'll see the search criteria on the left, and in the center right now it says no records found. So it's our job to write in a query that's going to return an actual list of artists inside of here that match up with the search criteria on the left-hand side. So if we take a look at the search criteria again, you'll see that we can search for an artist's name, the age range, the years active, and a sort by as well. So whatever result set we get, we can then sort it in some fashion. So just keep that in mind as we start to look through some of the comments inside of here. Let's walk through the arguments list that's going to be passed to this query, and then we'll talk about exactly what the query is going to be expected to return back to the rest of the application. The first argument to this is the criteria object. Criteria is an object with a name, age, and years active property. So these are kind of like the filtering criteria that we need to use. So when we when we type in a string like a artist name, we're going to need to make sure that we only find our artist with this very particular name. The second argument is the sort property, which is going to be the property to sort the results by. And so that's what's being selected by the sort by dropdown right here. So users should be able to sort by artist name, age, and albums released. Now we're going to assume that this sort property right here is always going to go in ascending fashion. So you're always going to be sorting with a sort property of like 1, or like a sort value of 1. And when I'm talking about 1, if I open up my get age range query that we were just working on, I mean like this one right here. So we're going to call sort, and we're going to always pass in 1. We're just going to hard code it like that. You'll notice that the real challenge behind this sorting though is that we can specify different sort properties, but only one at any given time. So if we look back at the query we just wrote, we had been hard coding in to sort by age, right? Like that was hard coded. But this time around, we're saying that we want to be able to pass in a different sort property depending on what the user has selected. And so in practice, that means that we're going to have to make sure that this value right here, this key, like literally that key, will be whatever the sort property is, okay? So if sort property is equal to, if we say sort property is equal to age, like so, we need to make sure that we end up having a statement that says age like that, just to be clear. All right, next is the offset and the limit. So the offset and limit, again, come down to pagination. Inside the application, you don't see it right now, but once we have a list of artists on here, you should see a little selector at the bottom stating whether or not you want to go to like the next page of search results. And so if a user clicks on this next page that's going to eventually pop up, the offset and the limit values here are going to change, and so we're going to need to return a different kind of window of results from our collection. Now the thing to notice about offset and limit right here are that they are using a little bit of ES6 code to default their values. Okay, so by default, if this function is called without an offset or a limit, they will be defaulted to 0 and 20. You don't have to change these two values right here. These are to kind of like for interface with the rest of the application. We shouldn't need to change the two values there at all. So that's an overview of the arguments list. Now, part of the real challenge here is not only getting all these different filter criteria and all these different query modifiers put together, but it is also the what we are expected to return from this query. So we are expected to return from this query a promise that resolves with the artists, the count of artists, the total count in the entire collection, not just in the result set, the offset, and the limit. Okay, let's talk about each of these properties. And notice that I added in an extra little comment here of exactly what the returned object should look like. So it's going to be an object with an all property, make sure you get that all in there, that will be the array of artists that was found, a count property, that is the total list or the total number of results inside of the result set, the offset, and the limit. The offset and the limit are just going to be the offset and the limit that get passed into this function. So we're not going to do any further calculation on these. We're just going to return them from this function as well. We're specifically returning them just because that's how this application was written. It was assuming the app was written, assuming that you would call this thing with the offset and limit, and the function would return that back to you. So it's just kind of an implementation detail. Okay. So definitely a lot of challenge here, a lot of very intricate moving pieces. For this first step, I want to do I'm going to do this in multiple steps. So for this first step, what I would like you to do is write a query that will follow sort, offset, limit, options only. So do not worry about criteria yet. Okay. Handling this criteria object up here is going to be pretty darn complex, and there's another topic or two that we need to discuss before we actually handle the criteria. So for this first part of the exercise, don't worry about the criteria object. Just write a query that's going to sort our entire list of artists and then find an offset and limit from them. And then you'll need to also make sure that your promise or the thing that you return from this actual function follows this type of function signature right here. Okay, so that's where we're going to start for right now. Go ahead and give it a shot. Again, this is a really challenging problem right here, and I probably haven't even given you a super in-depth explanation of all the little different steps in here. So I encourage you to give it a good shot. Give it your best try. After you give it a shot, we'll come back, go over some solutions, and figure out how to approach this. Okay, so I'll see you in just a second. All right, if you had challenge with this one, don't sweat it. This is intended to be a very challenging exercise to get through. I want to kind of stretch your understanding. I want to really put you to the test with this one. So if you didn't make a lot of progress, do not sweat it. In particular, if you had difficulty around the return object right here, that is something that I would really expect to be quite challenging. So let's get started and walk through a solution. Again, we're only going to be taking care of sorting, the offset or skip, and limit options. We're not worrying about criteria. We're going to take care of that in the next section. So the first thing we need to do is start off with our base query to the artist collection. So we'll start off by referencing the artist model, and we're going to find every single record in there. So when we take care of this criteria object right here, we'll pass in something different instead of the empty object. But for right now, we're saying just give me every single artist you have, and then we're just going to sort them and skip some number of values in there. Okay, so right now we're just saying give everything inside of here. Our next step will be to sort the list of records that we get. Now in the past, whenever we've been doing sort, we passed in a discrete property to sort by. Let me zoom in for just a second as well. We've been passing in a discrete value to sort by. So age of 1, or maybe years active of 1, or something like that. This time around, however, we are given a sort property, which might be a string. Remember, if we look at the docs right here or the comments, it says that it's specifically going to be a string. And sort property will be a string of like name, age, or years active. So rather than hard coding this key in here, we need to dynamically figure out what it should be. So there's two possible approaches to this. I'm going to lay out the kind of more ES5 or old school way of doing it, and then we'll refactor it to be ES6 instead. Okay. So first, the ES5 solution. Again, remember the whole goal here is to get an object that ends up looking like this. So whatever the sort property is, stuff it in as the key, and then set the value to 1, which is going to be our sort order. Okay, so I'm going to define an object called sort. How about sort option? That's good. Actually, let's go with sort order. Yes, that's best. Okay, sort order. We're going to make it an empty object. Then we're going to look at the sort order object, and we're going to add on sort property equals 1, like so. And then we can pass this to sort order. Okay, so this is the ES5 approach right here. And I very purposefully just threw up the code very quickly because I want to, kind of focus more on the ES6 solution, which is a lot more nice looking than this. So the whole problem with creating an object and simultaneously adding a property to it is that that's not really very well supported in ES5. We have to first declare an object, and then we can add a property to it and set that property equal to 1. Let's take this code right here. I'm going to copy all of it right now. I'm going to flip over to my browser and run this inside the console inside the browser just so we can see what happens with this type of approach. So I'm going to open up Google Chrome. I've already got the console open right here. I'm going to define a sort property equal to name, like so. Oops, let me refresh really quick. Okay, sort property equal to the string of name. So this is exactly like what our function will be called with. Sort property equal to a string of name. Now if I paste the code that we just added in, and then look at this newly declared sort order object, you'll notice that the square brackets on here means look at the sort property, it is a string, or look at the sort property variable, excuse me. It is a string, so we're trying to add on a sort order property of name to this object. And then we're going to set it equal to 1. So the end result is name : 1, which is exactly what our sorting function expects. So this definitely works, but it's a nasty little bit of code. So instead, we're going to do a little bit of a refactor to take it to the equivalent ES6. So I'm going to take this out. We're going to replace sort with an object. I'm going to place square brackets as though I was declaring an array. I'll say sort property : 1. So notice that the colon right here is outside of the square bracket. This is not an array right here. Let me say that again. Not an array, not an array. This is ES6 interpolated properties or interpolated keys. So what's happening is we are saying at compile or at runtime, look at this sort property variable. Whatever it's equal to, whatever string it's equal to, add that property to this object and then give it a value of 1. So if I take this statement right here, this object, and I bring it over to Chrome and I run it, you'll see that I also get name : 1 as well. So these two approaches, 100% equivalent. Okay, sorry about the brief aside there if you're familiar with that ES6 syntax, but it's definitely worth a little bit of discussion. So now we can add on our two remaining modifiers to this query, something to handle with offsetting the number of records we get. And you'll notice that I use the term offset here. Offset is really referring to how many records to skip in the result set. So this is going back to like the skip and limit modifiers. So we want to skip by offset many records. So by default that'll be 0, but over time it might change to other values. And then we want to limit our number of results to whatever limit is. Okay, so skip by offset number and then limit to this many records. Whew. All right, so this is definitely a mouthful. We're going to take this query and assign it to the variable query. The reason I'm doing this is because of the last little kind of hidden challenge in here, which is the count. So the promise that we're going to return from this function expects to have an object with a key of all that contains all the artists were found, and a key of count that contains the total number of records inside the collection. Okay, the total number of records inside the collection. We've looked at the count of collections once before. If you recall, getting the count or the number of records inside a collection is an asynchronous operation. It's not like finding the length of an array where we can just say like array.length. We have to actually issue a order or an operation to the database. The database is going to figure out the number of records that exist, and then it's going to return it inside of a promise. Okay, so we have one promise for our query. We're going to have a second promise to find our count. Because we have two separate operations, two separate promises that are going out here, we again need to combine them together by using the promise.all helper. So from this function, we'll return promise.all. The first element inside the array we're going to pass to this will be query. And then the second element will be the promise that will be used to find the number of records, which will be artist.count. So now we can add on a .then. This will be called with some number of results. Remember, results is going to be an array. The first element will be whatever came back from query. The second element will be whatever came back from count. So inside of here, we'll return our big result object. So this object that I have right here is going to fulfill this type of contract right here. So I will say all, which is going to be our list of artists, is going to come from results at 0. Okay, so that's query right here. Query is the search for all the different artists we have. It's going to show up as the first element in the results array. Next will be our count. This will be results at 1. So because artist.count was handed in as the second element in this array, it's going to be, the result of it is going to be the second element in the results array. Then finally, we need to pass through the offset and the limit. Again, the offset and the limit right here are just coming from the parameters right here, the arguments. They are exactly identical. We're not changing them in any such fashion. We're just passing them through to let this other part of the application that's actually making this query, let it be aware of how many records we were offsetting by and how many we were limiting. All right, so again, this is a tough one. Really, really, really tough. And I very purposefully wanted to give you something very challenging, and I have to make you kind of work around the expected results, or this expected return type right here. Having to deal with strange return objects like this is all a part of web development. You know, you're not always in charge of the entire stack, and sometimes another engineer or another library or whatever it might be is going to say, yeah, I want the data that comes back to have this really special format, and you might not really know why that's the case, but you have to do it anyways. And so that's a little bit of the kind of taste I wanted to give you here. All right, I think that we can probably test this out inside of our application and see how it's working. We haven't added in any of the actual filter criteria yet, so like searching for a particular artist name, but we should at least be able to see a list of artists appear on the screen. So let's flip back over to our application. Yeah, everything looks good. I just wanted to make sure I had the return on there. Do make sure you are returning that promise.all. So let's refresh. Okay, so here we go. Our list of artists is definitely appearing up on the screen. You'll notice that by default, it appears that they are all sorted by name. So we start off with Barney, D, H, J, K, M, 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 S, S, Z, X. So it definitely looks like we're pretty good on the sort order. If we go to sort by age, and then we click submit again, all right, it looks like we start off with 20, 25, 29, 30. Yep, looks great. And then if we go to years active, okay, 3 years active, 5, 7, 9, 11, 11, 12, 13. Awesome. All right, so it looks like we are definitely able to find a list of records, and we are able to sort them. You'll notice that at the very bottom of this list now, we've got a paginator down here, which says, okay, you are on page 1 of all the results currently, and there were 12 records found. So this is where that count is coming from, or it's why we found the count. This results set, or this results page, is showing up to 20 records at a time. And so right now we can't click to go to the right hand side or anything like that because there's no other records to go to. So this button is kind of grayed out. I know it's kind of hard to see, but it's grayed out and it's not giving me like a clickable link like this is right here to indicate that, hey, you can't go to the next page. You'll notice just really quick on each artist, some of them are gray and some of them are white. And then you'll also see the checkbox on the left and a play button over here. So let's click on this link to the right. So this will take us to the detail page for a single artist. That's definitely helpful. If we click on back at the top left, it's up here. If we click on back, it'll take us back to our result set. The gray artists are meant to indicate artists who are retired, while white are artists who are not retired. So gray is retired, white is not retired. If you recall, we had another function that we were going to eventually write called set not retired and set retired. That is talking about whether or not these people are retired or not. And as a matter of fact, if you click on these checkboxes, you'll get the two buttons up here that say retire and unretire at the top. So that's if we want to forcibly kind of like do a bulk update on a bunch of records. So I'm going to unselect all these people and we go back to what we had before. Okay, so sorting definitely working. We can't quite test the pagination just yet, but we'll definitely come back to that. So the next thing we need to work on is the name search and the actual age range and years active range. So let's work on these kind of filtering criteria in the next section. All right, part 1 of our query is all complete. Now we're going to move on to part 2, which is to deal with the criteria object that is being passed as the first argument to our query. Without saying another word about it, I'm going to add in a console log statement, and we're going to log out the criteria object. We're just going to look at it and see what data it contains. So I'm going to save this file. I'm going to flip over to our app, and I'm going to refresh it. So you'll notice that the instant that our application loads up, we automatically get a single console log in here. So by default, when the application first starts, it is going to call that search criteria or that search artist function for us automatically. By default, the criteria has a single name property that is an empty string. If we update the name property to, let's say, like Don, to match Don right here, and then submit it, Don will be updated as well, or the name will be updated as well. We can also update the age slider and then submit the form. And you'll notice that now the criteria contains not only name, but also age as well. This age property points at an object that has both a min and a max value assigned to it. If we then update our years active, and really quick, I'm going to clear my console just to make sure it's a little bit more legible. So I just updated my years active, and now I'm going to submit again. Now our object contains an age that has a min and a max, a name, and years active as well. So clearly, 3 different properties that we have to worry about: age, name, and years active. Okay. Now for this exercise, for implementing this criteria right here, I'm going to tell you that this is extremely challenging, and I have not at all given you all the tools you need to pull this one off. Okay. I will say very clearly, very directly right now that the answer is not to pass in an object of criteria like so. Like, we're not just passing this thing through and expecting find to just do the right thing. Okay, there's more work to it than that, a lot more work to it than that. So I'm going to present you with an option. You can either take a pause in between this video and the next and give this thing a shot if you are really daring and you want to do a little bit of research on your own. Alternatively, you can just skip to the next video and we'll walk through the solution together. Okay, so this next one, very, very tough. I have not told you everything you need to know to make this work at all. Okay, I'm like totally just throwing it out there. If you want to give this one a shot, it's like going to take a little bit of research on your end. If you want to give it a shot yourself, the one hint that I will give you is a certain page of documentation. So I'm going to open up my browser and I'm going to do a search for Mongo operator. Now we've looked at some of these operators before. I'm going to find query and projection operators. The operator we were using previously was the in operator, if you recall, to look at all the elements in an array. So I'm going to scroll down a little bit. So here's my query selectors. So 2 of the query selectors that might be very useful for you given that we have to find kind of like a range or values within a very specific range, might be this greater than operator, which matches values that are greater than a specified value. You could also use greater than or equal to, and then also the LT and LTE operators as well. So matches values that are less than the specified, or matches values that are less or equal to a specified value. You might also, do a little bit more research. This is clearly probably only going to help you with like age and years active, those two queries, because you're trying to find values that are between 10 and 13, okay? All right, so again, I'm going to leave it up to you. You can either give this a shot or just continue the next section with me. If you're on the fence at all, I would recommend you kind of walk through this next one with me. But if you're feeling really confident, then go ahead and give it a shot. Even if you use those two query operators, there's still one other big error message that you're going to get that's going to require a little bit of research. So I'm going to leave you to, whatever you want to do, go for it. I'll see you in the next section and we'll walk through this solution. Hopefully you had some success on working with the criteria object inside of here. If you didn't, or if you just want to see solutions, fantastic. Let's figure out how this thing is going to work. Now this criteria object, or this thing that I'm going to pass as some filtering criteria to the find function, I'm going to expect that it's going to take a little bit of logic to form this thing up. So rather than sticking all that logic directly into this function right here, I'm going to make a helper function that I'm going to call build query to build up the actual filter object. So I'm going to call filter query. I'm going to pass in criteria, which is the criteria that we're going to do the search with. Now at the bottom of this file, I will define the build query function. So it will be called with the criteria object, and inside of here, it's going to be up to us to form up an object that will represent the query that we want to, the way in which we want to search our artist collection. Now, the criteria object that's coming inside of here is some like very generic or not very well formed object for searching over our collection, right? And what I mean by that is it has like some random properties on it. Like it has age, which has min and max, which Mongo does not know how to deal with by default, right? It doesn't know what min and max actually means. So we'll be reading from this criteria object, but we're going to make a separate object to return from this function that's going to represent the actual query that we want to send off to Mongo. So that's kind of challenge number one, right? We're not modifying this object in any way. We're just kind of reading some of the desired search results or what the user wants to see from the UI from this object. So instead, I'm going to make an object called query, and we're going to be modifying this object over time to kind of narrow down the query that we're going to be making to our artist collection. So right now, we're going to go through the solution for adding on the idea of querying about the age of artists inside our collection. One thing that I want to remind you really quick is that when we just saw the criteria object console logged out, right? Like when we started actually console logging stuff, and why not? Let's just do that right now really quick. I'm going to add in another console log for criteria. Like so. Now I'm going to expect my code to throw an error, but we should at least see the criteria object get console logged. Okay, so here's our criteria object. Right now it only has a name property on it. So it has no property whatsoever like years active or age, okay, by default when it first starts. When we finally start moving these sliders around, then it gets the age property appended onto it. Or when we move around years active, then it starts getting years active appended onto it. So what the important thing to keep in mind there is that by default, criteria has only a name available on it. So if we want to figure out whether or not we should be updating our query to be considering the different age of an artist, we should put on an if statement that will look at criteria.age. So now we're only going to update our query if the user has modified the age. Then inside of here, we can take our query object and we'll modify it in some fashion to include in this like specific age range that we want to find. So this is where the Mongoose, or the Mongo query operators are going to come to play. And if you recall, I showed you this documentation just a moment ago. So the two operators that we want to be concerned with are likely the greater than or equal to and the less than or equal to operators. So let's see how these are actually going to be used in practice. As a quick reminder, we did already use the in operator, so we kind of saw a little bit about how these things are used, but we didn't specifically use greater than or less than. So let's see how they actually work. To specify that we only want to see artists of an age between some specific values, I'm going to say query.age equals an empty object. This thing is going to have the greater than or equal to operator. I want to see all of the artists with a age greater than or equal to criteria.age.min. Then I also only want to see the artists with an age less than or equal to criteria.age.max. Okay? So remember, the query object that we're forming up right here, we will eventually return it from this function, this build query function. That query object is going to be passed off to the find operation right here. So we are essentially saying, if we took the code that we just wrote and just stuck it in here, I'm going to modify my code really quick. I encourage you to not change your code, but just watch what I'm going to do for a second. We would have the equivalent of age greater than or equal to min age, and I'm going to just abbreviate this thing as min age, and less than or equal to max age. Okay, so that's essentially what we are using this build query function for down here. We're forming up this specific object right here just in a kind of nicely sanctioned off area. All right. So I'm going to go back to just the build query with criteria. Looks good. So my query is looking pretty good so far. At the very bottom, I'm going to return the query that I formed up and then save this file. Now I think that I've got enough stuff for this query that I could actually run it inside of our app. Let's do that right now and see if the age slider works at all. So I'm going to flip over to the app. I'll refresh the page. So by default, my age slider consists of the entire range of all artists inside my database. If I move the slider around, however, like let's say I want to see just artists from 20 to 26, and I submit that, fantastic. Now I only see artists who have an age between 20 and 26. I can move it around a little bit more, and okay, now I see a couple more artists appear on the screen. Notice that I can also sort at the same time that I do my filter. So I'm going from 20 years old all the way up to 30 years old, sorted by age. Awesome, definitely working the way we expect. I like it so far. We're going to take a quick break right now. I'm going to encourage you to give a shot at putting together the years active criteria as well. Okay, so we just put together the filtering for age. I'm going to encourage you to give a shot at years active. In practice, it's going to look very similar, so give it your best shot, and we'll come back in a second and figure it out. In the last section, we put together the criteria.age filter. Hopefully you had some success with putting together the filtering around the years active as well. So in this section, we're going to go over some solutions for years active. In practice, it's going to be nearly identical to what we just did for the age. Below this if block, I'm going to add in another one. So I'll say criteria.years active. And inside of here, we'll say if a years active was provided by that filter UI, right? Like if a user actually changed this slider right here, I'm going to expect my criteria object to have a years active property defined on it. So we'll say query.years active. We're going to add on a search for years active on all the different artists. Now I'm only going to want to see any artist with a years active greater than criteria age, years active .min, or less than criteria years active .max. And that's pretty much it. So again, we're just modifying our query object here. We return the query object at the bottom. That query object is going to be sent on to our artist.find. So the overwhelming kind of idea here, the reason that we broke this all out to this build query thing, was that we only conditionally wanted to add some properties onto the query object that we're passing to artist.find. And whether or not we added on these additional properties depended 100% on this criteria object. So here's criteria. We look at criteria, we do some introspection on it. If a specific age was selected by the user, then we'll modify the query. Otherwise, just let it go on through. So now we can test out both age and years active at the same time. I'm going to flip over to our app. We will refresh it. Wait for the refresh. All right, and now we should be able to say, give me only years active from, let's say, 8 to 13. Okay, I definitely saw some number go away, about 8 to 10. Ah, there we go. So now we're down to just 9 years active. How about let's go out to 6. Okay, looks good. And now I should be able to combine these two. So you'll notice that I have users anywhere from 36 to 43. So maybe I only want the user who's 43. So I'll go down to 41 to 43. And there we go. So now I'm seeing only artists with an age from 41 to 43 and a years active from 6 to 10. Just what I expect. So this is looking pretty good. I think that we're making some great progress. The last thing that we have to tackle is searching with some text criteria up here, or like a specified name. So this is where some very intense topics are going to come into play. If you already gave an attempt at this, fantastic. I definitely applaud you for your attempt. If you saw any error message around it, no problem. We're going to go over these solutions in the next section. It definitely requires a little bit of extra knowledge that I have not shared with you so far. So if you gave it a shot and it didn't quite work out, again, don't sweat it. I wanted to just push you a little bit and see if you can stumble across the solution. So let's take care of searching by name in the next section. Time to move on to the very last and probably most challenging part of the query that we're writing out here to find a big list of different artists. So this is where we're going to start adding in some implementation for searching for a very particular artist based on their name. To add in this additional query, we're going to add in another if statement inside of our build query function. So inside of here, we'll look at our criteria object, and if a name has been specified by the user, we will update the query object to accommodate for that. We're going to do so by adding on some additional properties to the query object, just like we were doing previously. But the question is, this time, how do we do a text search? We are searching by a name here, right? Now in the past, we've done things like user.find name of Joe, right? But this was a full text, or this was a exact text string search right here. So we were specifically looking for a user with the name exactly equal to Joe. But that's probably not the experience that we want to have here. We probably want to make sure that users have the ability to search for like just the word Don, right? Not Don Copeland, or just Hazel, not Hazel Nolan, and not Nolan, but you get the idea. We want to give users a little bit of flexibility in how they search for content out of all of our big list of users. So rather than using this very generic fashion right here, we're going to do a little bit more complicated search. To start off, I'm going to pull up my documentation for Mongo query operators that we've been looking at. So remember, we got here by doing a search at Google for Mongo operator or Mongo query operator, either one. And then we went to this page and we were looking at some of the documentation around greater than or equal to or less than or equal to. Remember, we've also previously used the in operator from here as well. So these are all about operators to do some kind of advanced comparison or querying inside of our MongoDB collection. Now there's one very particular operator that we can find by scrolling down a little bit. So I'm going to go down past the logical, past element, and all the way to evaluation. So you'll notice that inside of evaluation, there's one operator in here called text. Description is performs text search. Well, hot dog, that sure sounds like it's relevant to what we're trying to do, right? Let's check out the documentation for search and see exactly how it works. Now, rather than reading maybe all this documentation, let's just throw some code into our project and let's just see what happens, right? Let's just see what happens. I want to very specifically just ignore all the documentation. I want to go straight to the examples. Okay, search for a single word. Yep, looks great. Okay, we'll take our collection, text, search, and then the string we're looking for. Hot dog, let's give it a shot. Okay. So I'm going to very purposefully ignore all the documentation. We're going to say criteria.text equals search, and then the text that we are searching for, which will be criteria.name. So if I look back over just to verify, yep, text, and then search, and then the string we're looking for. So we add on a text property to, excuse me, not criteria right here, this should be query, my mistake. So we add on a text property to query, and then that's going to be an object with search and criteria.name. Okay, yeah, whatever, looks good, let's give this a shot. So I'll flip over to our app, let's refresh it. Wait for that long refresh. Okay, so let's add in a name here. Now I want to add in a name that is like nearly identical to one of my artists. So I'm going to use specifically capital D Don. So I encourage you to use like a very particular artist name with the correct capitalization. So let's do a search. We'll hit submit and oh, well that's definitely not good. I got a nice big error message over here. It says text index required for text query. Text indexed. Well, who knows what that is? Let's take a quick break, come back to the next section, and figure out exactly what indexes or indices inside of Mongo are. So we'll see you in just a second, and we'll get this bug figured out. In the last section, we attempted to make use of the text operator inside of our Mongo query to find a user with a very particular name. When we executed that query, we saw a big error message pop up that said text index required for text query. So clearly there's something wrong here, and frankly, I think we deserve an error message because we just copy-pasted a bunch of code without reading any of the documentation. So we'll say this one's on us, or I guess me. I'll take the blame for it, don't worry. So let's figure out a little bit about what this error message is talking about regarding this text index. An index is a system that Mongo uses to make very efficient queries whenever you're looking for data. That's what an index is. Let's look at an example or two. Inside this diagram, I have reflected a collection that we're going to call the users collection. The users collection has a big old list of users. Whenever we create a new collection of data, like the instant that is created in Mongo, an index is automatically created on the ID field of every record. So separate from the collection of all of the different records inside of the collection, separate from the big old list of users, is a bucket of indexes. And personally, I like to say indices, which I think is more accurate, but Mongo internally calls it, or their documentation refers to it as indexes specifically. This collection of indexes that sits inside of our users collection enables us to make very fast lookups to the ID field of every record. So in theory, whenever you call a function like, say, find by ID, and we try to find a record with a very particular ID, because the ID property of every record is indexed, we get a very fast lookup. The ID property of every record is indexed by default. So every collection we make automatically get an index on ID. If we want to add in very fast lookups for other properties on any of our objects or any of our records, we have the option of creating our own index. And we can do so by using the Mongo command line tool. A very common use case of creating your own index is whenever you have a certain property that you find yourself making many queries for over time. A very good common example of this might be an email field of a user. So we can imagine that every user maybe has an email. Maybe we want to very frequently make queries over our collection of users that involves the email field. So if we want to make sure that query is very quick, we can add an index for the email field, which would look something like if I want to just specify it or recognize it via diagram, looks something like this. So we would add in a index on the email property of all of our different users. And that means we can make very fast lookups on anything that's involving the query. Involving the email. So when we look back at the message that we saw right here, it says text index required for text query. This means any single time that we want to use this text operator inside of our collection, like as we just did, we must specify a field that will be indexed as a text field. And so if we even look back at the query that we made inside of our search artist file, this starts to make a little bit of sense. You'll notice that in this line of code right here, we never actually specified that we wanted to look at the name of each property, did we? And we never actually said, okay, out of every artist, look at their names and try to find a name of criteria.name. Criteria.name right here is the value that we're looking for, and it's not actually specifying the field that we're looking at when we're trying to find the appropriate name. So in order for us to use this text search operators, we must first create an index on the name property of our artist collection. Once we add in this index property, once we add in this index on the name property, we can then make text searches on that property. The one really big thing that I want to mention to you about text indexes specifically being used for search is that Mongo currently only supports an index on a single field. So in other words, it starts to get a little bit more challenging if you want to say have an index that is made for searching on both an email field and a name field. That's when things start to get a little bit more hairy. So inside this section, we're going to go ahead and add an index on our artist collection over the name field. And once we do that, we should then be able to pull off our actual query. So let's add on our index. To do so, I'm going to open up my terminal. So here's my terminal. I'm inside of my project directory right now, and I'm going to start up my Mongo shell. I can do so by running the command mongo, like so. You'll notice that when I run the command mongo, it automatically connects to my test database. Now, I have a test database. If I look at my RoboMongo UI, I have my test database, but I don't really want to be in the test database. I want to be working on my upstar_music database. To change the database that we are currently operating on, we can run the command use upstar_music. That switches us to use the currently active database of Upstar Music. Whenever you're inside the Mongo shell, you're always operating on a single database at a time. So you always want to make sure that you use the correct database. If you want to get a list of all of your active databases on your current machine or the Mongo instance that you're connected to, you can run the command show DBs. This will show us a list of all the different databases that we have running on our current machine. So now that I'm connected to upstar_music, I can create a text index on our artist collection on the name property specifically by running the command db.artist.createIndex, and then we'll pass in an object with a key of the field that we want to add the index to, which for us is going to be name, and then a value of the type of index that we want to create. So for us, we want to create a text index. So then I will close off the object, close off the function, and then we can run it. After this command runs, we'll get a little bit of output that specifies a little bit more about the results of the operation that was just taken. So we have a variable in here that says number of indexes before this command was run. There was only one. Now that we've ran this command, we have 2 indexes on this collection, and then we get a status code of, okay, like everything went along A-OK. So now that we've added in our collection to the name property, we can now flip back over to our application and give a test to searching for a very particular artist. I'm going to first refresh our application by hitting Command R. just to make sure that I refresh the connection to our Mongo database. Once the application then loads up, any second now, there we go. I'm going to again do a search for a very particular user. So I'm going to find the name of one of my artists. And sorry, I said user, I meant to say artist. So I'm going to search for Don. I'll submit, and all right, looks good. I found specifically Don. So now if I clear everything out, submit again, and I'm back to my full result set. One thing that you're going to notice very quickly is that if I do a search for like only a portion of a name, like let's say, let's just put in the letter E. How about that? Let's search for E. You'll find no results found. And so this behaves a little bit not like what you might expect as far as full text search goes inside of Mongo by default. So by default, whenever you're doing a search, it is looking to match an entire word like Don. So for example, on, just AWN, is not going to be matched. We can try out DAW, and yep, not going to match as well. But if we put in Don, all right, there we go. A little bit more like what we expect. So now that we've got text search in here, we can mix and match these different search operators together. And let's look for Don now. And she's outside of our criteria, and so she doesn't pop up. After we finish up with the last query inside of this sample project, we're going to seed our database and add in a couple thousand different records. And so searching and filtering is going to start to have a lot more sense than when we just have this limited list of 12 or so records. Okay, so this is looking good. We've got our text search wired up. We still have a little bit of work left to do as far as queries go inside our application, specifically around setting the set not retired and set retired flag for each of our artists. So let's continue the next section and implement these last two queries. I'll see you in just a second. In the last section, we just about finished up our search artist query. I say just about because I do want to mention that we still have one little issue inside of our query. You'll notice that up here at the top where we make our query, we are finding a subset of all of our artists with this build query thing right here. So in theory, we can get a result set far less than the full 7 or 17 or 17,000 artists that we have in our database. And that might be what we're actually returning from here, right? However, our promise is currently returning the entire list or the entire count of the entire artist collection. And you may or may not have noticed that that's going to be a little bit of an issue when we look down at this paginator. For example, if I filter down my search criteria to just Don, I see page 1 and 12 records found, even though there's clearly only one record on here. So I think that the way in which our artist.count function right here is working isn't quite perfect just yet. I want to move on to the set retired and set not retired queries, and then we're going to come back to this and fix it later on after we start to add in many more artists, like several thousand more. Once we get a several thousand more, the behavior of this paginator at the bottom has become a little bit more apparent, and so it makes sense to wait to fix it until that point in time. Okay, so let's pivot, and we're going to start working on the two retired functions. I'm going to close all the files I have open, and then I'm going to open up set retired and set not retired. So as you might guess, these work in just about the opposite of each other. Okay, just about the opposite. If I open our application back up, and then I get my big old list of users on the screen, the users who have a background, or the artists who have a background of gray, are the ones who are considered to be retired inside our application. And by retired, I mean they're not making music anymore. The users, or the artists in white, however, are not retired. If we look at RoboMongo, we'll see that every single user has a retired flag that is either true or false. So either you're retired or you're not. It's a Boolean, that's it. If we open our application back up and then start selecting some of these different users, you'll see that we get retire or unretire pop up. So in essence, we need to somehow take a list of users and update the retired property on every single one of them to either retire them or unretire them. Note that it's perfectly valid inside this application to try to retire an already retired artist. Like we're allowing that, we're saying that's totally fine to do. So let's take a look at the function and see what we have to work with. I'm inside of the setRetired function right now, so we'll start off with setRetired, and then we'll implement setNotRetired. Again, the two of them are going to be nearly identical. So inside of here, we've got some documentation, sets a group of artists as retired. The argument to this is going to be an array of IDs. So it's going to be an array of every artist that we need to update. Then the expected return value is a promise that resolves after the update. So basically just something that says, hey, we're all done, like go for it, whatever you want to do now. So it's going to be up to you inside of this function to write out a query that's going to look at all these different IDs and update the appropriate users. Now a couple quick notes that I want to throw out there. First, I want to steer your direction away. Like if you're considering to do something like IDs dot for each, and then you're going to take every ID and then fetch, find by ID, update it, and then save it. Not the direction we want to go. Okay, so we're not going to find every record in a loop and then update it and save it. We want to do all of our updates in one big go. Okay, so that's big note number one. Big note number two is going to be a lot more tricky. So we have an example of something exactly like this inside of the user's application we had been working on before. But we left off one extraordinarily important detail. Okay, we left off one extraordinarily important detail. So if you implement this query and then you attempt to test it and you notice that it's only seeming to update like a single artist, maybe that isn't quite what we expect, okay? So I'm going to encourage you to do your best shot at implementing this query. If it doesn't work exactly the way you expect, that's totally fine. We'll solve it in the next section, but I'm also going to encourage you to take a quick glance at some of the Mongoose documentation, which you can find at mongoosejs.com/docs, and maybe see, look at some of the different API methods in here, see if you can't figure out why update is only updating one record at a time. So let's take a quick break. You'll go ahead and give us a shot, and we'll come back and solve this problem. Hopefully you had some success putting together the setRetired function. If you ran into any issues, don't sweat it. Again, I really threw you into the deep end on this one. In particular, if you got the query kind of working, but it felt like it was only returning or only updating one artist at a time, no problem. We're going to fix that problem up inside this section. So we're going to start off inside of the setRetired file. So I'm inside of setRetired right now. We definitely want to update a couple of different artists all in one go. We've seen an example of this back in our user's application, and so without a lot of explanation ahead of time, let's put together what the query is probably going to be. It's probably going to be something like artist.update. I'm going to expect to have a couple arguments here, so I'm going to new line the function. The first argument to artist.update is the criteria with which we want to find the list of artists to update, and then the second argument is the way in which we want to update that artist. So first, we're going to say, look at the ID of every artist. If their ID is in this list of IDs that we're going to pass in as an argument, so IDs, this is coming from the argument right here, then we want to update them in some fashion. So we're going to put a comma at the end, and for the second argument, we'll say retired true. So I'm specifically saying true because we're inside the setRetired function. So presumably, if we're calling this thing, we want to set some of these people as being retired. Okay, so looking at this, it definitely matches up to some of the code we had previously written around our list of users. Let's test this out and see how we're doing. I'm going to flip over to our app, wait for the very long refresh to occur. Okay, there we go. So now I'm going to multi-select two of the artists with white backgrounds. Remember, if they have a white background, that means that they are currently not retired. So if I click the retire button right now, I'm going to expect both of their backgrounds to suddenly turn gray. All right, so here we go. So I'm going to click it, and that's quite interesting. only the first record was actually updated. It appears that Don wasn't updated at all. If I click submit to update the list right here, when I click on it, it is updating the list, but clearly nothing is actually happening. Like, let's confirm. I can sort by age. Okay, yep, there's age. If we go back to name with Dawn, yep, Dawn, sure enough, she is not getting updated to being retired. So what's going on? Well, let's check out some of the documentation and see one of the biggest gotchas around Mongoose and Mongo that you could ever possibly imagine. So I'm at mongoosejs.com, where we've been looking at a lot of the official documentation around Mongoose. I'm going to click on Read the Docs, and this takes us into some of the documentation. Now, I know that the text is a little bit small, but don't worry, I'll read it out to you. I'm going to scroll down on the left-hand side and go to the API Docs section again. So like I said earlier, yeah, I really don't care for these docs that much. Let's find our model.update function and see if we can't figure out exactly what's happening here. So I'm going to search for model.update, and then I'm just going to go ahead and there we go. Thank goodness, we found it without too much difficulty. All right, so if we look at the description, okay, updates documents in the database without removing them. Yep, sounds good. The first argument is the conditions, or kind of like the search criteria. The second argument is the document, or how we want to update the records we find. And then the third option, the third argument is options. Let's look at the list of options we have available. I'm going to scroll down a little bit. So here's valid options. If you look at these options, you're going to find one little option just buried away in this list, and oh my goodness, can you believe that it's so hidden? If we pass in a object that contains the key multi with a value of true, that is how we actually get a multiple documents updated at once. By default, multi is passed in as false, which means multiple documents will not be updated by a single update call, which really behaves a little bit inconsistently with how you might imagine update to work. Because hey, find, right? Find returns a list of records, remove returns a list of records, but all of a sudden we're saying multi does not. Well, that's a little unexpected. So in order to get our update function to update a list of records, like all the ones we have selected, we have to pass in a third argument here. So I'm going to put in another comma. We'll pass in an options object, and we'll give it the property multi-true, which means, yep, we want to update multiple records at once. So now let's flip back over to our application again. We'll refresh the page. Wait for the long update. I'm going to select 2 of our artists who are currently not retired. I'll click on retire, and ta-da, they both get updated at the same time. So again, multi, wow, extremely important setting to know about, but it's pretty gosh darn hidden away inside of the documentation. So I think that we're just about done with set retired. We still have to implement set not retired, but as you might imagine, it's going to be just about opposite in function. So I'm just going to copy the contents here, everything inside the function. I'm going to take it over to the set not retired function. I'm going to paste, but instead of saying all these records are retired true, I'm going to say, nope, you're not retired anymore. You're coming out of retirement. So we'll say retired false. So now let's flip over again. We'll go through one last very long refresh. And now I'll do some multi-select. Let's take a bunch of the retired people and say, hey, you're doing one more album. Here we go. And boom, all in one fell swoop, we update a bunch of records all at once. And of course, we can toggle them back and forth all we want. Cool. All right, this definitely looks good. I think that we've finished up all of the different queries we have, notwithstanding one tiny bug that we left inside of the search artist query. Inside the next section, let's figure out how we can add several thousand pre-generated artists to this collection. Then we'll test a couple of different query options that we have. We'll fix up this count thing that we've got going on. And I think we'll be just about complete with this application. So I'll see you in just a moment. Now that we've got all of our queries working, more or less, let's start to scale up our application by inserting a ton of data into it and then running some queries over it just for fun. Inside my project directory, I'm going to find the src folder. Here it is right here. And then when it's open, I'm going to open up the seeds.js file. Here we go. This file right here contains a bunch of code to add a ton of different artists to our artist collection. If I scroll down a little bit, you'll find a function called createArtist. And inside of here, it generates a bunch of data, everything that a fake artist contains. You'll see a lot of references to something called faker. So here's faker.name, faker.image, faker.internet, blah, blah, blah. If I scroll back up to the top of the file, you'll see that I imported the faker library. I specifically want to mention faker because it's something that is just fantastic whenever you are putting together personal projects of your own. The faker library is made for generating a ton of randomized fake data, and it's what powers just about everything having to do with fake data inside of this project. So it generates the name, image, URL, company name, Boolean, date, copy sold, album image, all these great things, all generated by the faker library. So I just wanted to point it out to you. You can find some documentation on it by going to npmjs.org and then doing a search for faker. So if we go here, here's npm, and then we can search for faker. And then the first result, actually the second one, there's capital F faker and lowercase faker. So I'm going to go to the lowercase faker, and you can find some documentation here about how this library works. So again, I just want to point out to you because I found that it's incredibly helpful whenever you are testing data or testing applications to have a bunch of fake data sitting in your database so you can test stuff like speed and whatnot, like how long do these queries really take. So with that in mind, let's go back up to the top of this seeds file, and we're going to add in a couple, many thousand more artists to our application. So at the very top of this file are two different variables. There's minimum artists and then artists to add. Minimum artists is the number of artists that the application should have at any given time. And then artists to add is how many should be added if the number of artists is less than whatever this minimum artist is. So I want to say that in my application, I want to add in let's say, 15,000 users. I'm going to generate 15,000 artists and add them all to our artist collection. Then I'm going to also make sure that I increase my minimum artists from 2 right now. If I go back to my app, you can see that I have only 12 total at this point. So I just need to make sure that I enter a value that's greater than the 12 that's shown right there. So I'm going to say minimum artists, I need to at least have 200. So that will make sure, the minimum artists right here will make sure that we go through the process of adding new artists, and then artists to add of 15,000. That'll make sure that we add the correct number to our database. Okay, so to get this thing to run, all we have to do is refresh our application. So I'm going to flip back over to our app. I'll hit refresh. And this may or may not take longer or shorter than you'll expect. Let's see how long it takes. Remember, we are adding 15,000 records to our database right now. Yours might take significantly longer or shorter than my own. Completely random. Who knows how long it's going to take. Okay, we'll let all right, fantastic. I was going to say let's take a break, but all right, not bad. So 15,000 artists, all randomly generated and then inserted into our database. Above all, I want to take this kind of experience right here, and I want to point out to you that for the vast majority of applications that you are ever going to work on, if it is a personal project, take that right there as evidence that you don't always need to worry about performance as a number one characteristic. We just randomly generated and inserted 15,000 records in probably 5 or 10 seconds. I know it took a while, but remember that it always takes a while for our app to refresh. And so the process of adding those 15,000 records, that was pretty quick, right? So do not try to prematurely optimize your application when it comes to the database. A lot of the things that we end up doing for the average application, which is probably not going to have, thousands or millions of records sitting in Mongo, you're probably going to be okay on the performance side. Anyways, Just want to throw it out there. So now, if we do a search for name, and I'm going to pick a random name out of here, like how about Aaron? Okay, now we start to have a lot of records inside of here. Also, if we submit again, empty out the list, and we filter down to like just ages 15 to 19, all right, now we're starting to get a ton of data sitting inside of our database. And you'll notice that these queries are very, very fast, right? They're very, very quick. If I do Aaron again, yeah, that's instantaneous right there. That's about as fast as it gets. Cool, so this definitely looks like it's working out pretty well. I'm going to go back to the full list of records. I'm going to scroll down to the bottom, and you'll notice that we got the page down here. So it looks like we can definitely increment through all of our different pages, and again, it's very quick, which is very nice. However, if I go back to just searching for Aaron, like so, I still, it says here 15,000 records found, and it makes me think that I can go to the next page. And as a matter of fact, if I click it, definitely not expected. So clearly there is still something funny in our application over how the total number of records are handled. So let's take a quick break and then come back and fix up our search artist function to make sure that we're handling this count thing in here correctly. In the last section, we added several thousand records to our database, but then we noticed a little bit of an oddity. If we got down to a compacted result set, like I can only see 5 records right now, our UI still reflected 15,000 records found and really made our user think that there was many more than just the 5 that are being shown right here. This error is being caused by our search artist query. So right now I'm inside of my search artist file inside the queries directory. So here's search artist right here. If you recall, inside of this function, we had an artist.count call right here. So this artist.count is what is powering that pagination feature at the bottom of the page. We're recording the count, or returning the count from that query, and that is exactly what is being shown right here. So clearly we don't want to show like always 15,000 records because that's really confusing to the user. The number of records returned, or the count right here, should match the number of records that match the search criteria. So there's one very particular thing I want to mention there. If I go down to, let's say we're going to search for only artists who are between 15 and 16. Okay, so here we go. So in theory, maybe this is like several hundred right here, right? Like who knows, but in theory, several hundred. The thing that I want to be really clear about is that however many artists come back from that query is how many we should see right here. Okay, that's how many we want to see right here. We want to see like the several hundred. In other words, we want to get a count of the total number of artists who match this query right here. The reason I'm spending a little bit of time to kind of drive that point home is that we want to get this total count before we run the skip and limit function, right? Before we run skip and limit. Because skip and limit is always going to return at best 20 records. And we don't want to tell the user that, oh yeah, there's only 20 records found from your search result. No, 20 is how many they can currently see. But in total, the number that match their search criteria is a little bit different. So in other words, we need to really do some work on artist.count right here. So to fix this up, what we essentially need to do is pull off this query right here and then get a count of the returned or of the number of records that match this query, this find with the build query right here. So you might be hoping right now, okay, Stephen, well, can we like save a reference to this right here, then get a count from this, and then also do like the sort and the skip and the limit? And the answer is unfortunately no. If you ever want to get a count of the total number of results that are returned from a possible query before you do the limit and the offset or the skip, you have to do 2 separate queries. There's no way to do both these things in one step. So in other words, to fix this problem right here that we're having with the counts, I'm going to take this entire query that we're building up here, I'm going to copy it, and then I'm going to just stick it right in before the dot count. So now I'm left with artist.find. We build up the query with the criteria, and then we call dot count on it. So yes, unfortunately, this is going to issue 2 separate operations to our Mongo database. It's not ideal. It'd be great if there was a better way to do this, but unfortunately in Mongo, there's not. So we've got one query going out that's going to fetch all of our compacted result set, like just enough to show one page of data. And then we're going to issue another query whose purpose is going to be just to find the number of records that match this given search criteria. Okay, so let's give this a shot out inside of our app. I'm going to go up to the top. I'll refresh the page. And now if I do a search again for Aaron, keep in mind that you might see a different number of Aarons because all this data is randomly generated. I correctly see, all right, 5 records found. There's one page and I cannot go to the next page. Likewise, if I say only show me artists between the ages, that slider's a little bit temperamental, but let's say 43 and 44. And I scroll down to the bottom. I see that, all right, I've got 974 records that match that criteria, and I can correctly page through all the different records. Cool. All right, this is definitely working out. I think that we've conquered the entire application, everything we have to do. I hope you enjoyed working on this application. It definitely ended up being a pretty nice looking thing, if I do say so myself. All right, I'll catch you in the next section. We've now gotten a tremendous amount of experience with Mongo and Mongoose, saving data, editing data, querying for data, all that kind of good stuff. But we're still missing a little bit of a piece out of the bigger picture here. We never would use Mongo alone to build a web application. We're always going to end up having a server of sorts in front of it. So in this section, we're going to figure out how Mongo fits into the larger backend stack of a typical API that we might build. So in this section, we're going to build an API of sorts that might serve up data to any arbitrary front-end framework or technology you might want to use. So we're going to build a server that you could use with React or Angular or an iOS application or an Android application. Any type of front-end app you might want to put in front of this thing, it's going to work with perfect compatibility. So let's talk a little bit about exactly what we're going to be building. We're going to make an API that would serve up a sort of application that we might use for Uber. If you've ever used Uber or heard of Uber before, or its very similar equivalent Lyft, Uber is a ride-hailing application, and we'll talk exactly how it behaves in just a moment. For right now, let's focus a little bit more on exactly what we're building, or the pieces of the puzzle that are going to form this API. For the application we're going to build, we're going to be making the entire back-end stack. So we are going to imagine that some front-end framework like React or Angular or an iOS application is going to make an API request to the back-end that we're going to put together. So we're going to put together a Node and Express server. That's going to be our web server, which is going to take some number of incoming requests. That Node and Express server is then going to interface directly with our MongoDB database. And it's going to work with a single collection of data that's going to sit inside of our database, which we're going to refer to as the drivers collection. So remember, in the context of Uber as an application, it's all about hooking up users or people who are looking to get a ride with people who are driving cars around, who we will refer to as drivers. So the API that we're going to be putting together and the different routes that we're going to be putting together are going to be all about working with this collection of drivers that are going to be stored inside of our MongoDB database. So let's take a quick break and then come back and talk a little bit about how this API is going to behave and what different operations we're going to need to work with a collection of drivers. In the last section, we spoke a little bit about the next application we're going to be working on. So we're going to make the entire backend for a type of Uber application or a type of ride-hailing application. We're going to put together the web server and the MongoDB database to serve it. So let's talk a little bit, just to make sure that's really clear, exactly how Uber works. So this is going to give us a little bit more insight into this drivers collection that I spoke about just a moment ago. Remember, the drivers collection is the collection of all the different people who are currently driving cars around in the world. So if you're not familiar with how Uber works, if you've never used Uber or Lyft or anything like that, it's relatively a pretty straightforward application. The user opens up the app on their device, their mobile device. They see a map of the world all around them, and then they can press a button that says, Find a Driver. When the user presses find a driver, that looks at all of the different drivers who are in the world immediately around them. It finds a nearby driver, and then it prompts that driver to ask them whether or not they are currently available to go over to this user who is sitting right here at the corner of this road right here, pick them up and drive them to wherever they need to go. So again, we're not going to be so much concerned about the end user. We're only going to be working with this collection of drivers. We could definitely expand the application quite easily to include the concept of end users, but trust me, we're going to learn a ton and really just about all we need by just working with this collection of drivers. So again, we're kind of only building half the application here, but really believe me, you are going to learn so much, and this is all knowledge that you can immediately apply to the rest of the application if you wanted to build the entire thing out. So I want to take a second and think a little bit about this collection of drivers. I want to think about exactly what are the different operations that we might want to take on this collection of drivers. So we can imagine that we've got a drivers collection, and it's got driver 1, 2, 3, 4, 5, all these different people who are signed up to drive inside of our app. So what are the different ways in which we might modify this collection? Well, I bet you can guess. This really comes down to another CRUD style application. And again, you would not believe the number of apps in the world that are extremely popular that really come down to just being CRUD style applications. Now, of course, there's really fancy ways that you can work with all this data and throw a lot of complexity on top of it. But at the end of the day, there are 4 core operations for an app like Uber, to some degree, as far as the drivers go. All right, yeah, I'm going to throw that disclaimer on there. Yes, Uber is a very complicated app, but we can kind of model it as this little bit more simple, this simple structure. So when considering the collection of drivers, we might need to create a driver. So that would be the instance of where someone signs up to the application to be a driver. We might need to delete a driver. Yep, hey, maybe they are a really bad driver and we want to just totally kick them off the platform, totally shut them out 100%. We might want to delete the driver. Or maybe they request to be deleted. They don't want to be driving for the application anymore. We might need to edit a driver. So this is where things start to get a little bit interesting. It makes sense that not all of our drivers are going to be wanting to drive 24/7. Right? They're real people just like you and me. They don't want to be driving 24 hours a day. There might be times where they want to go home, take a break, do something else. And so in the context of that, maybe we need to have the ability to specify which drivers are currently active. To be able to toggle these drivers from active to inactive, well, that sounds a whole lot like editing a driver. Definitely sounds like editing one. Now finally, by far the most interesting operation we're going to need to take on this collection is to find drivers near a very particular user. Let's go back to our map here for a second. And let's say that you are standing right here at the corner of this intersection right here. And we've got 1 million active drivers across the entire world. If you request a driver while you're standing on this intersection right here, we only want to find drivers who are within a certain radius of your current location. We don't want to, if you're standing on the corner of this street right here, and this is in San Francisco in the US, we don't want to find some driver who's over in Bulgaria or Russia or some country in South America, Brazil, Argentina, Chile. We only want to find drivers who are within a very specific radius of the user's current location. And so this read operation is actually going to be pretty darn interesting. We're going to have to really figure out a way in which we can make sure that we only specify drivers who are very close to a very particular physical location. Luckily, MongoDB has fantastic support for geo-based queries. And so towards the end of the section, when we implement this find drivers near me query, we're going to learn that that is something that's actually relatively straightforward when using MongoDB. Definitely a benefit of the platform. Okay, one last thing I want to talk about, and that's exactly, we just spoke about the drivers collection and how we have this big old pile of drivers, but now I want to think a little bit about how all these different operations are going to map up to API requests, okay? So let's take a quick break and then come back and talk about exactly how these operations are going to map up to particular types of requests inside of our application. In the last section, we spoke a little bit about our drivers collection and the different ways that we might need to modify that collection. So every one of these operations over here to the right, we're going to match up an API route to undertake or undergo this particular operation. So let's talk a little bit about what I mean by that. On the left-hand side of this diagram, I've got the 4 different operations that we might want to undergo or partake on our drivers collection. We're going to map up every one of these operations to a very specific route and request type that is going to be wired up to our Node application. So if somebody makes a post request to the /API/drivers route, that is going to have the effect of creating a driver in our drivers collection. If someone makes a delete request to API/driver/ID, where the ID is the ID of the driver that they are trying to delete, we will delete the respective driver in our drivers collection. And then the same thing for editing and finding drivers as well. So in other words, the takeaway here is every operation that we are going to undertake on our drivers collection is going to be mapped up to a very specific route or request type, So when I say request type, if that is like mysterious or you don't quite know what I'm talking about at all when I say request type, or if you don't know what I mean by post request or delete or put or get, no problem. We're going to spend a little bit of time now to do a little bit of fundamentals of Node and Express.js and exactly what these incoming request types are. So let's talk about fundamentals of Node and Express for a little bit. So again, I want to just do a quick refresher. We spoke about this just a moment ago, but I want to reiterate the design of our application. We are going to be building a Node Express server, and it's going to take some incoming API requests. So what I really want to focus on right now is this incoming API request. This is the same diagram we were just looking at, but now I've expanded out the API request or the HTTP request. So again, any type of front-end application, it might be React, Angular, iOS, Android. And I'm saying React and Angular, but I really mean just arbitrary JavaScript web application. It could be vanilla JavaScript. It can be absolutely anything we want. All of these different front-end applications that we might build are going to be able to interface with our Node Express server by making HTTP requests to it. So it does not matter what type of front-end app you want to build, it will be able to communicate with this Node and Express server that we're going to put together by making an HTTP request. So let's talk about exactly what forms up an HTTP request and some of the different rules that are around it. The text here is the text from a very real HTTP request. Well, it's not 100% real, but these are some of the properties you might see. So let's inspect a couple of the different parts of this request. On the very first line, we specify the type or the method of the request. In this case, I have post request. There are many different methods of requests, and we'll talk about all the different kinds there are in just one second. After specifying the method of the request, we then specify where the request is supposed to be sent to. So in this case, we're trying to send it to a route of API/drivers. So my expectation would be that we are going to wire up our Express server to watch for post requests coming in on a route of API/drivers. So whenever the Express server sees that type of request coming in, it will look at the request and then take some operation on our collection of drivers to suit whatever the request was. Some of the other interesting parts of our HTTP request are the header section. So that's everything from user agent down to connection down here. The headers of the connection are kind of like configuration options to describe some data about the request itself. The first line, user agent, specifies the type or the type of device that made the HTTP request. So user agent, I could talk about for a very long time. Let's just say it specifies the type of device that made the request. We've then got the host, which is the domain from which the request is bound to. And then a couple others on here that aren't particularly interesting, at least for the purposes of this course. What I really want to talk about is the very bottom part here, the request body. So if we want to send along any specific information with the request itself, that information will be tagged in the request body. So a post request has the implication of creating a new driver. If I want to create a driver, I might need to pass along some data like the email of the driver we're trying to create. So I would pass along that information in the request body. All right, so a little bit of a side on HTTP requests in general. Chances are I'm going to assume that you've probably made an AJAX request or an HTTP request in the past. If you have, you've probably used, say, Axios or jQuery or just raw JavaScript. When you've done that, you have been making HTTP requests that look exactly like this. The benefit of libraries like jQuery and Axios and all those, like Fetch itself, the Fetch API, the purpose of those is that they take care of formulating and producing this HTTP request themselves. So you don't actually have to manually finagle with creating all this different stuff. It's handled traditionally by the browser or by a mobile device for you. But again, I just want you to understand a little bit about what goes into an HTTP request, because it is quite important once we start working on our Express application. Okay, so before this section runs on too long, let's take a quick break, and then we'll come back and talk about exactly what this request method is and why it's so important for the API we're going to build. So let's talk about that in the next section. In the last section, we spoke a little bit about the anatomy of HTTP requests, and then we left it off with saying that we would cover a little bit about the request method that is tied to every type of request. So just a second ago, we were looking at a slide that said, hey, whenever we create a driver, I want to make a post type request. Or when I delete a driver, I want to make a delete type request. So this post, delete, put, and get, these are the request methods that I'm talking about. There are 4 primary request methods that we'll be working with on our application. And in practice, these are the most common ones that you'll see in applications in the wild. There are several other type of request methods, but you will not see them quite so frequently. The request method that is tied to an HTTP request describes the general purpose of the request. In general, whenever we want to create a type of record, like any type of record, we are talking about creating drivers, but this could be about creating users, blog posts, tweets, logging in, anything like that. Just the general idea of creating records is tied to post type requests. Deleting records is tied to a request method of delete. Editing existing records is tied to the request method of put, and reading information is tied to get. So these are the request methods that are tied to HTTP requests. Now I do want to tell you right now that these request methods are not necessarily like hard and fast rules. And there actually are some very famous stories about companies who make products where, they found that they were trying to make GET requests that had so much customized information about the type of records they wanted to read that they ended up saying, hey, you know what, GET requests have to follow this very specific rule set. They aren't really working for us. So instead, for fetching records, we're going to use a post type request. So these are not necessarily hard and fast rules, but they are the general idea or the general conventions by which we'll be following for our Express server. So let's think now about how we might apply these request methods to the different operations on our collection. I've taken the same diagram on the left-hand side that we just saw a moment ago, and we said that for creating a driver, we might make a post request to API/drivers. So this request might come into our Node or Express application, and it's going to be up to our Node server to look at both the type of request that's coming in. So it's going to recognize that it's a post type request. It's going to know, the Express server is going to notice that it's going to the route of API/drivers. And then we need to specify, or we need to add in some logic that is going to tell the Express server that it's going to modify the driver's collection in some fashion. So that's pretty much like the whole gamut here, the entire purpose of our Node server. We are going to wire up some code that's going to interpret these incoming requests, and then depending on the type of request that's coming in, we will modify the driver's collection in some fashion, be it by creating a driver, deleting one, editing one, or reading some drivers out of our driver's collection. All right, so that's pretty much it. All I really want to talk about for the fundamentals of Express, or not necessarily Express, but fundamentals of API servers and how we're going to take these incoming requests and then map them up to very specific operations to happen on our Mongo server. I think that we've done quite enough lecturing now, so let's get started with our application in the next section. We've done quite enough lecturing at this point, so let's get started with our actual application. The first thing we're going to do is make a new project directory and then initialize our project inside of it. We're going to do this entire project from absolute scratch. So no boilerplate, nothing like that. Every single line of code outside of the actual libraries is going to be written by us ourselves. So the first thing we're going to do is make our project directory. I'm kind of worried about copyright stuff, so we're not going to call this project Uber, even though it is a ride-sharing application of sorts. Instead, we're going to call it Moober, which is completely different and not trademarkable at all. At least, I'm not a very good lawyer, so who knows. Anyways, let's make a new directory called Moober, and then we will change into that directory. Then once inside of here, we'll generate a new npm project by running the command npm init. When we run npm init, we get a quick wizard for setting up our project. We don't need to modify any of the default information in here, so we're just going to hit the fantastic enter key to get through that wizard. And the end result is we get a package.json file. So the package.json file for us, only serving the purpose of recording our dependencies and also a couple of scripts that we might want to write as well. So now that we've got the package.json file in place, let's open up our project directory with our code editor. All right, so we got our package.json file inside of here. Right now, of course, no dependencies. So let's solve that a little bit. We're going to install a couple dependencies right now just to get us started. We'll start off by running npm install -- save, and there's a couple different dependencies we're going to want to grab. We'll get Mongoose, of course, because we're going to be using Mongoose. We'll put a space after that. Here, let me change my font size just to make it a little bit more clear. There we go. And then we'll also get Express. And of course, we are going to be doing some amount of testing here. It's not going to be necessarily test-driven development, but we are going to be writing tests to make sure that our code works the way we expect. So we'll also grab Mocha as well. And I think that'll be probably good for right now. Just Mongoose, Express, and Mocha. So this is going to take just a moment to finish installing. Let's just let it do its thing. One thing I want to point out to you in particular is exactly what the difference between Node and Express is. So in all the diagrams we've been looking at, I've been showing kind of like Node and Express as the same exact thing. And certainly whenever you hear about Express online, it's always Node and Express seem like they're nearly the same thing or very tightly coupled. So I would definitely say they are tightly coupled, but they're definitely not the same thing. Node is an environment, it's an engine, it's a JavaScript interpreter that allows us to run JavaScript code in a command line or just kind of like general running on your machine, on your computer, and most specifically outside the browser. That's really the key word here, outside of your browser environment. So Node has the ability to work with HTTP requests, like it can function as a server or a web server or any type of server, but it has many different applications outside of that as well. Express is a framework to just make working with these HTTP requests a little bit more easy, or just kind of simplify that process. So everything that Express does, we could do ourselves with just raw JavaScript code that's going to work directly with Node. The only purpose of Express is to save us a lot of time when dealing with these very common use cases. And when I say very common use cases, I mean like interpreting an incoming HTTP request and deciding what to do with it. That's really what Express's job is, as far as we're concerned. So let's jump back to our terminal. It looks like all the installation is done. Fantastic. Let's open back up our code editor. Okay, looks good. And it looks like we've got the node modules directory in here, which is where all of our dependencies were just installed. And yep, we got Express, Mocha, and Mongoose, just what we might want. All right, let's take a quick break and come back and figure out exactly how we're going to start working on our application. Now that we've got a couple dependencies installed, we can start writing some code for our actual Express server. Inside my project directory, I'm going to make a new file called app.js. And then inside of here, we're going to add a little bit of code to generate a new Express application. So at the top, we'll write Express equals require Express. And then immediately underneath it, I'm going to say const app equals Express. And then we're going to call Express, invoke it as a function. So already, hey, some crazy code. I know that you might have gone through an Express tutorial in the past, or you might have seen essentially the same exact thing right here. But of course, with me, I am just obsessed with making sure you understand every single line of code. So what exactly did we just do right here? Like what just happened? We required Express, and then we called Express. But what is app, really? What is it? Let's take a look at a diagram really quick. So this is a diagram that we're going to be coming back to very frequently. Let's imagine for a second that we want to create a driver. Like we want to take a driver object, save it to our database. To do so, we are going to end up making a post request to the /API/drivers route inside of our Express application. We're going to put in a couple different pieces of code called our router, controller, and model to facilitate that whole process. These different pieces of code that we're going to write are all going to be wrapped up inside of our Express application. So this Express thing that we just created, that app that we just created, this thing right here, it is an object that is going to take incoming requests, so incoming HTTP requests, and depending upon some information in that request, like the type of request it is, the method, and the route that it's trying to go to, like that API/drivers, it's going to run some different amount of code inside of our application. So that's what the purpose of that Express server is, or Express application, as we might want to call it. Now, aside from this app.js file, we are going to make one other file really quick. I'm going to make a new file inside of our root project directory, and this one I'm going to call index.js. Then inside of here, I'm going to import the app that we just created. So I'll say const app equals require app. Then we'll say app.listen on port 3050. And after it starts listening, I want to console log the message running on port 3050, like so. And then one last step, I'm going to flip back to my app file, and I'm going to make sure that I export the app that we just created. So now we got module.exports. We're going to export the app. That gets imported into the index.js file, and then we start listening on port 3050. So again, I just took a big leap in faith here. I promise you the rest of this application is going to be a little bit more clear with each line of code that we write. I'm not going to continue to just throw lines of code up onto the screen. Just for this very first part, it's a little bit easier to just kind of throw some stuff up and then talk about it afterwards. So inside of our app.js file, after we created the app object, we then exported it from this file by assigning it to module.exports. We then import that into this index.js file, and we tell the app, the Express application, to listen for incoming HTTP requests on port 3050 of our current running machine. So if I now started this application up, it would automatically start listening to requests coming in on port 3050. Right now, we don't have any route handlers, so even if we started the app up, we couldn't really very effectively communicate with the server because we have absolutely no code in here that specifies what to do when there's an incoming request. So let's take a quick break and then come back and make sure that we add in a little bit of code that we can use to listen for incoming requests. We've now got some boilerplate put together for our Express server. If we run our server right now, it's not going to quite do anything just yet, however. We haven't specified any routes for the server to actually listen to. So although we are listening on port 3050, our server will not respond to any incoming requests. For our server to respond to incoming requests, we must define something called a request handler. Request handlers listen for incoming HTTP requests on very specific routes, and whenever it sees one, it'll respond to it with some amount of information. So let's take a look at a diagram that's going to help us understand some of the terminology behind these request handlers. We start off on the very top left-hand side with our incoming HTTP request. So again, it doesn't matter where this request is coming from, be it a JavaScript application or a native mobile application. We refer to the incoming request by the abbreviation REQ, which is short for request. The incoming request is going to go into Express, and Express is going to decide what it needs to do with this request. Once it decides what code it should run, it formulates up a response, which we refer to as the res object, short for response, which will then be used to send some information back to whoever made the initial HTTP request. So the two important words to remember here are REQ and res, and we'll refer to these two objects, REQ and res, very frequently throughout the entire course. So let's add a route handler to our application that we'll use to listen to a very specific route, and whenever we see a request coming in, we'll respond to it with some amount of information. We're going to add a request handler inside of our app.js file, and we do so by writing out app.get. And then as the first argument to this function, we'll write in the route that we want to be listening to HTTP requests on. For us, I'm just going to arbitrarily say right now /API. Now this app.get function right here is one of several such functions. So get is not saying like, hey, whenever you get a request on the route /API, it is saying whenever you get an HTTP request with a method of get. So remember all the different methods we spoke about. Get, post, put, and delete are the big ones we're going to be using. So this app object has several functions just like get. We can also specify app.post, app.put, app.delete. And then each of these are functions, and we can specify the route that we want to be listening to, like so. So each of these say whenever a request with a very particular method is made to this very particular route, run the second argument to this function, which is going to be a callback. So I'm going to take off these extra ones on here. I just put them on as a, just to let you know that they exist. And we certainly will be making use of them later on. This callback function in here is called with two arguments, REQ and res, which, as we just learned, represent the incoming request and the outgoing response. They're both objects, and each object has a bunch of information that describes the incoming the incoming request and details about the outgoing response as well. We'll definitely get a lot of experience with both of these REQ and res objects, but for right now, we're just going to use the res object to formulate a response and then send it back to the user. So we'll say res.send, and then we'll pass in the information we want to send back to whoever made the HTTP request. For us, just to kind of get something in here, just to see a request just happen, I'm going to send back an object that contains a key of hi and a value of there, like so. So we can now read this request handler in total as whenever an incoming HTTP request of method get is made to the /API route, run this function right here. When the request is made, immediately send back an object with the key of hi and a value of there. The last thing I want to mention about this request handler is the route in particular. So I've been saying route nonstop. Whenever you hear me say the word route, I'm talking about the actual URL that the HTTP request is being made to. So let's put a comment on here just to sum up the entire request handler and also make it really clear what this /API really means. So we'll say watch for incoming requests of method get to the route http ://localhost port 3050/API. So this is where we would be making a GET request to. And again, that GET request can be originating from our front-end web framework or from a native application, whatever we want it to be coming from. The URL itself specifies the domain. For us, because we're running the server on our current machine, we can specify localhost. Then we have :3050. This is specifying make the request to port 3050, and it is specifically port 3050 because in our index.js file, we told our Express application to listen for traffic on port 3050. And then the very last part is the actual route that we're trying to access. So because we attached our route handler to /API, we are making a GET request to /API. Okay, so let's save this thing and run the application and just kind of see what happens. I just want to test this out manually. So I'm going to save the file. I'm going to flip back over to my terminal, and I'm going to start up the server by running node index.js. I immediately get a message that says running on port 3050. Okay, that looks good. And I'm going to flip over to my browser, and we will make a request to localhost :3050/API. So one very important thing to note here is that whenever you type a URL into your browser, you are making an HTTP request of method get. So if I had changed this handler right here, this get, to like a post, all of a sudden this wouldn't work out anymore for exactly what we're trying to do. Whenever you go to a URL inside your browser, it is making a GET type request. Okay, so let's visit this. If we go here, we immediately see the response sent back to us of hi there. And we got specifically that because we sent back an object with hi there from this request handler right here. Now notice if I go to API / whatever else, all of a sudden I start getting an error message because I don't have a route handler defined for localhost 3050 API / ALKSJ, blah, 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 all that stuff. So right now, one single request handler of /API. All right, so this is one more step in understanding what's going on with Express. Let's continue on in the next section and learn a little bit more about how we handle routing inside of our application. And we're also going to learn a little bit about how we set up our testing environment as well. We've now got a single request handler in here. Let's put together a very simple Mocha test around this request handler just so we get a better idea of how testing works inside of an Express application. In general, it definitely is pretty darn similar to the Mocha test that we've written already, but there's a couple of extra little considerations that are going to make life just a little bit interesting. So let's give it a shot. We've gone through default Mocha test setup before. As you know, the first thing we'll do is create a new test directory inside of our project folder. So I'll make a new folder that I'll call test. And then inside of that, we'll make a test file, which I'm going to call app_test.js. So we don't have any need just yet to make a test helper file because we are not working with Mongoose just yet. So no need for test helper or any type of initial setup just yet, but we will in just a little bit. Inside of here, we are going to first require in assert, as we've done many times before, and then we'll place our first describe block. So let's describe the Express app. Flipping back over to our app.js file, if we look at this thing, what are some of the different things we might want to test about it? Well, I probably want to test to make sure that this request handler listens for incoming requests of type or method get on the route of /API, And I would probably also want to make sure that I test to make sure that the response that comes back is an object that contains a key and a value of hi there. So in total, I want to make a request to /API with the method of get, and then assert that I get back a response of hi there. So that's what our goal is going to be. Now, making requests or fake requests to Express is part of a little bit of the difficulty that I spoke about a while or just a moment ago about working with Mocha and Express and Mongoose in the same application. So to help us test the app appropriately, we're going to install one more package that is called Supertest. The package Supertest is a little tool that helps us make fake HTTP requests to our app. So we need to first install this package at the command line. I'm going to flip over to my terminal. I'm going to stop my running server by hitting Control-C, and then I will install the Supertest package by running npm install -- save supertest, like so. And it's a pretty small package, so it just takes a moment to install. Let's flip back over to our test file. And inside of here, we will first import or require in that Supertest package. By convention, we don't actually call Supertest when we require it in. By convention, we usually call it request. But we are still going to require it from the Supertest library. So Supertest definitely breaks the convention of naming the imported variable the same thing as the library itself, as we do with like assert. The only other library that I can really think of off the top of my head that does the same thing is the Lodash library or underscore, which both use the underscore character to represent the variable name. So again, this variable name right here can be absolutely anything we want. By convention, the Supertest community usually calls it request because it helps you in simulating requests to our Express app. Now we also have to require in our Express application as well. So we'll say const app, which is going to come from one directory up and then the app.js file. So one directory up, app, like so. Now we will add in our it statement. So it handles a GET request to /API. And then because this is probably going to be an asynchronous test, I will add in my done callback. As you've seen, just about every single test we've worked on inside this course has been asynchronous in nature. Whenever you are making HTTP requests of any type or even faking them, as we kind of are with Supertest right here, it is always going to be asynchronous in nature. So I can probably guarantee you we're always going to need done for every test that we're going to write inside this app as well. So now we can make a fake request of sorts using the Supertest library. Here's how we use Supertest, and this is something that's kind of hard to lead into, so I'm just going to put down the syntax we're going to use, and then we'll discuss exactly how it works. So inside of the it block, we'll say request. So that's our Supertest library right there. We'll pass in the app. Then I'm going to chain on a .get to /API, and then I'll chain on a .end, which will take a callback function that will be called with two arguments of error and response, like so. So we call request, we pass in the app, we chain on a .get, and then we chain on a .end. So this is a very typical use of how we will see the Supertest library in practice. We call request, passing in our Express application, and then we'll chain on some number of customizing statements in here. So in this case, we're just making a GET request to /API, but we also can say maybe make a POST request to /API or a PUT request, or all these different types of requests that we might want to make. We can also chain on some additional statements on here, like .send, to send along some information with the request as well, but we'll get to that in due time. Now the callback function itself inside of here has the arguments of error and response. One common misconception is around this error object right here. Error does not talk about getting a errored status code back on the response itself. It means did anything like literally just physically go wrong with the request. So I don't usually look at this error object because we don't run into errors around it too often, but I would encourage you to consult the documentation around supertest to get a little bit of a better idea of when this error object comes into play. So the thing that we really care about is this response object right here. This is what we really care about. Let's console log that response and just see, what is it? What do we get back? So we've got that in there. Let's take a quick break and then come back and figure out exactly how we actually run this spec. So I don't want this, again, very easy in this section in particular, all this express stuff to have really long sections. I'm gonna do my best to try to keep them bite-sized. So anyways, let's take a quick break and come back and figure out exactly how to run this test. Now that we've got our test in place, we can run it by adding a script command to our package.json file. So this is definitely something we've gone through before. Let's open up our package.json file. Inside the script section, the test section is currently blank. So we're going to, well, I shouldn't say blank, but it's got the kind of dummy command in here right now. So we're going to add in our test command here. It's going to be very similar to the one we used previously. So we'll say nodemon --exec. That means whenever our project directory changes, run this command that we're going to pass in as the exec argument. So with single quotes, we'll say mocha --recursive, which means look through any nested folders that we might have inside of our test directory. We don't yet, but we will in a little bit. And then we'll also pass in the -r, which means clear out any of the previous test printout that there had been. And then also -r specifies the test reporter to use. And we're specifying to use the minimum reporter. So let's save this, and then we can run our actual test. Back at my terminal, we will run that test command with the npm run test. So there's our nodemon command, and then we get a nice gigantic console log here. So here's the console log that we just got back inside of our test file. Let's go check out that console log really quick, just so we can remember where it is. So after the request is completed, we take the response and we console log it out. So we can scroll through the big old thing. There's a couple interesting sections inside of here. Here's the headers. We can see, here's very interesting, body, which is probably what we care about. So the body has the object hi and there. We could also continue to scroll through this thing, and you'll see that it's got just a ton of data connected to it as well. In general, what we are most going to be concerned about on that response object is the body of the request that comes back. And we'll also sometimes be interested in the status of the request as well. The status in status code is an integer number that is used to tell us a little bit about the status of the request. A status of 200 literally means okay, or everything about this request occurred as expected and there were not any errors associated with it, which is definitely good. So now that we know that this response object has a body property that contains the information that got sent back from the request handler, we can write an assertion that asserts that we get back an object of hi there on response.body. So let's open our code editor back up. I'm going to take out the console log from the response. We definitely don't need this anymore. And we'll add in an assert statement to assert that response.body.hi is equal to there. So we are looking at the response.body property. That is an object that has a hi property. If we access hi, this entire thing right here will be there, equal to there. And so we add on the triple equals to say that should be equal to there. So let's save this and see how our test is doing. And okay, still getting a big or a timeout message here. Totally my mistake. I made the very classic error of not calling done after the test is complete. So we'll add in the call to done right there. And fantastic, now our test is passing. So just to make sure that it's passing appropriately, I'm going to change the equals there to some gibberish. And yep, looks like now it's an error, so that means that our test is definitely working as we expect. All right, so this is great. This is the very common way in which we're going to be testing all the different handlers that we're going to put together. So at this point, we've made some pretty good progress. We've put together all the boilerplate for our Express application, as small a boilerplate as it is, and we've learned how to define and test a single route handler. So let's continue in the next section where we're going to start getting a better sense of how to structure our application. Now that we've got a single route handler and a test in place, let's take a little bit of time to figure out some of the folder structure of our project and what some of the different other parts of it might be that we're going to need. As always, it really pays dividends to plan ahead just a little bit. So let's pull up a diagram really quick. We've looked at this one previously for just a moment. So remember, whenever an incoming request comes in to create a driver, we are going to expect that's going to be a post type request made to the route API/drivers. And then we had said, okay, Express is going to have a couple different parts of code to figure out what to do with that incoming request. So we're going to have 3 additional parts of code, or kind of centralized locations of logic inside of our Express application. The first is going to be something that we're going to call the router. The router's job is to look at incoming requests and look at specifically the URL and the method of the request, and then send that request off to the appropriate part of the application to serve as the route handler. So if we take the code that we've already written inside of our app.js file and think about which part is the router, well, that would really be this first part of the statement on line 7 right here. So our router is going to have a bunch of code that's going to specify a route and a type of or a method of request. And then depending on the method and the route, it will specify a different function to run. In the example that we already put together, we just threw the entire route handler and all of its logic directly in here. But you can imagine that if we had just a single file where we looked for all the different routes and also specified what to do when that type of request came in, we would end up with one file that was really, really big and really, really messy. So instead, we are going to separate out the routing logic from the actual logic of deciding how to respond to that request. We're going to take all the logic that's going to decide how to respond to the request, which is going to be this callback function right here, and we're going to place that logic inside of a file that we're going to call our controller. So the controller is going to contain all the logic having to do with how to respond to a very particular request. The controller will eventually end up working with our model, and we've definitely spoken about what models are previously. The model is going to be our Mongoose model. So our Mongoose model, like our drivers collection or a model driver of sorts. So these are the 3 big parts of code that we're going to have inside of our application: the router, controller, and the model. Let's start implementing these different parts of our app inside the next section. Now that we've got a better idea of the purpose of the router, controller, and model parts of our application, let's refactor the single request handler we have right now into both a new router and controller. Since we've already got a test around this request handler right here, after we do our refactor, we'll be able to look at that test and have a reasonable assurance that we did our refactor appropriately. So let's get started. We need to make a router and then a controller. To make the router, I'm going to make a new directory called routes inside of our root project directory. And then inside of that file, I'm going to make a file called routes.js. Now, I do agree with you that having a folder and file called routes is really not super ideal, a little bit repetitive, absolutely. The reason that I personally like to place this routes file inside of another folder is to just keep the root project directory a little bit more clean. So very personal for me, very personal choice. I don't like to have a ton of files inside of here, especially since some of the files are tied to application logic and then others are tied to like Git or our dependencies. It always seemed kind of funny to mix and match the files in the root project directory. So again, I like to just place everything inside of folders whenever possible. But you could just as easily, if you want, put this routes file inside of the root project directory. Totally up to you. Okay, so inside of here, We're going to do that fantastic thing where we put a little bit of code on the screen and then talk about what's going on. So we're going to define a function and immediately export it. Okay, that's what we're going to do. So we're going to say module.exports equals a arrow function like so. Now I'm going to flip back over to the app.js file. We're going to require in that routes file that we just created. So I'm going to say const routes equals require routes, because the first one is the project directory and the second is the actual file. So now this routes thing right here is a function, right? Like we just defined a function and exported it. So routes right here is a function. So to attach some routes to our app object, we will call routes with our app and then set up all of our different routes inside of that router file. So explaining how it works with words is a little bit confusing. Let's just do the implementation and I think it'll be really clear exactly what's going on. So I'm going to call our routes function with the app object. Okay, there we go. So now I'm going to take this big ol' snippet because we want to move all of this request logic to the router. So I'm going to cut all that logic out. I'm going to flip over to the routes file. So here's the routes file. I'm going to paste that bit that we just cut out. And then one last step, I'm going to take in the app as an argument like so. So all we did was we moved the configuration where this route handler is set. We just moved it. Nothing inherently changed. We just moved where we set the route handler. So let's walk through the flow of our application. When the app first starts up, we're going to create our new app object. We then call the routes function, passing in the app. Then inside of the routes function, we receive that app as the argument, and then we will associate some number of routes with it. So that's what we just did. As a quick intermediate step, let's save both these files and see if our test is still working. So I'm going to make sure both files are saved. And I'm going to open up my terminal and yep, looks like everything is still passing. Definitely good. Now the next thing I want to do is define our controller and move our request logic for the response into that controller. So remember, the router is all about just taking incoming requests and sending them off to the right location. The actual request handling logic is going to be defined inside of a controller file. So inside of my project directory, I'm going to make a folder called controllers. And then inside of there, I'm going to make a controller, which I'm going to call drivers_controller.js. So this file is going to contain all of the different very specific logic for manipulating and handling drivers inside of our application. By convention, we usually have one controller for each type of resource inside of our application. So for us, we are going to eventually have drivers. So I would expect to have a drivers controller. If we also had like a list of to-dos, then I would expect to have a to-do controller. If I had a list of books or a collection of books, I would have a books controller and so on. You get the idea. Our drivers controller will be an object that has some number of functions associated with it. So I'm going to define and immediately export an object. This object is going to have a bunch of key value pairs where each key value pair represents a request handler. So for the first request handler that we have, which is this dummy little thing inside of here, we're going to, let's make a request handler one called, we'll just call it greeting. Why not? And then we'll use a little bit of ES6 syntax to define this key value pair. So it's going to be called with a request and a response. So again, this is a little bit of ES6. 100% equivalent way of defining this would have been greeting and then define request and response like so. So this is the old school ES5 way of doing things. You can absolutely use ES6 if you would like. Totally up to you. But I'm going to go with the more up-to-date ES6 fashion. So then inside of here, we'll say res.send, hi, and there. So now all we have to do is make sure that whenever that request comes into our router, we run this greeting function right here. So the last step, very last thing we have to do, is to flip back over to our routes file. We will require in our drivers controller. So const drivers controller equals require up one directory over two controllers and then drivers underscore controller. And whenever a request comes in of type get to /API, we are going to run that function that we just defined on drivers controller. So drivers controller dot greeting. And then notice, very important, we are not invoking greeting here. We are just passing a reference to the function so it can be called at some future point in time. Okay, so I know everything we just did probably seemed like a pretty crazy, very fast refactor. The reason that we went through that kind of quickly is that nothing really changed about the logic inside our application. All we did was spread around some of the request handling logic. That's all we did. We just took the request handler that we had inside of app.js and we just took out some little parts of it and squeezed it around to different parts inside of our application. So now, when our app first boots up, let's walk through the whole process. When the app first boots up, we create our app, we pass it to the routes function. Inside the routes function, we say, hey app, whenever you get an incoming HTTP request to the /API route with the method of get, go and run this function right here. Just go and run that function. Then inside the drivers controller, we created an object with a single key of greeting that had a function where we take the incoming response object and send back, we take the incoming request and response and we send back an object of hi there to whoever made the request. So again, exact same code as what we just had. We just massaged where each part of it lives inside of our application. And we just did that to make sure that our application is a little bit more easily accessible in terms of project directory structure. So as our application grows, we're not going to have a single file with just tons of logic sitting inside a single file. So the last thing we have to do is make sure that our test is still passing. If we flip back over, yep, sure darn looks good to me. Let's run it one more time. Yep, definitely passing. So hopefully your test is still passing at this point. We've definitely got a more flexible project structure at this point in time, which is definitely good. Let's continue the next section where it's time to probably start introducing the Mongoose side of our application. So let's get to that part in the next section. Now that our project directory structure is a little bit more flexible, we can start thinking about the Mongoose side of our application. So in this section, we're going to start working on our drivers collection. I know it's been a little bit since we spoke about our drivers, so just as a reminder, a driver represents someone with a car who is driving around in the world and waiting to pick someone up to give them a ride to some other destination. So inside this section, we're going to create our driver model, and we'll think a bit about the schema that that driver should have. The first thing we need to do is make sure that we have a place to stash this model. So we need to have a location just to place the code to define the model schema and associate it with Mongoose. To do so, we're going to place all of our models inside of a folder that we'll call models. So inside my root project directory, I'll make my models folder. And then inside of there, we're going to make our driver model inside of a file called simply driver.js. So we've gone through the boilerplate for creating a new schema and associating it with Mongoose several times now. So let's throw that boilerplate up. We will require in Mongoose. Let's get the font size nice and large again. There we go. Then we'll pull off the schema object. So const schema mongoose.schema. And we'll make our driver schema, which is going to have all the properties associated with the driver. Okay, so that definitely looks good. Let's spend some time to think about what different properties a driver should probably have. So reminder, here's our app over here. We need to have the ability to find a driver, delete them, edit them, all that kind of good stuff. So what are some properties that we might want to associate with a driver? Well, chances are we want to say when you sign up as a driver, I want to know at least what your email is, right? Like a reasonable identifier so that you can then log out of the application in the future and log back in with your email. So we'll assume that we're going to take the email of every single driver. Next, we want to know whether or not a driver is currently looking for passengers. Don't forget, like drivers are people too. They don't work 24 hours a day. Maybe they only work 2 or 3. So we need some type of flag to decide whether or not a driver is currently looking for passengers. So how about we use a flag called driving, and it can be either true or false to decide whether or not this person is looking for passengers. Since it's going to be a true or false flag, we'll make it of type Boolean. Finally, because we need to know where all the drivers are in the world at any given time, so that we can always make sure that whenever a user is looking for a driver, they only get drivers who are very close to them, we're going to need to record the location of the driver as well in some fashion. And so that one, as far as the type goes, well, that's a challenging one. I'm thinking that as far as the location side of our application, like all this location or geolocation stuff that we're going to have to do, let's just put that off for a little bit. So we're going to defer on figuring out exactly how location is going to work for our application right now. For right now, let's just focus on manipulating the email and driving flag of our drivers. Now, of course, we would probably also want to record a driver's license plate and car make and model and year, payment information, all that kind of great stuff. But for our application right now, this is really the bare minimum to get us started. So we'll start with this simple information. And if you want to go back on your own and add in some additional schema for this driver, you will definitely know how to do it after we walk through these couple of properties. So let's start off by defining the email and driving schema. We'll associate that with our Mongoose model, and then we'll start thinking about how we're going to associate that with our Express application. So inside of our schema, we will specify that every driver should have an email. I really think that an email must be defined at all times. So we'll say that it's going to be of type string, and we're going to specify that the email is required. We can do so by passing in required true. So now if we ever try to save an email without save a driver without providing a valid email address, then we'll get a flag, an error message raised. We'll get an error message and it's going to say, hey, sorry, but you got to provide an email in here. And that's the purpose of this required true right here. Required true is definitely, without a doubt, the most common piece of validation that you're ever going to have for all the different properties that we'll make use of. And then for our second property, we'll have our Boolean driving. So we'll say driving. It will be a Boolean, so either true or false. And I think that it'll be important that when we first create a driver, we would probably want them to start off as not driving by default. Like the instant that you sign up for the application, we probably don't want you to sign up and then 2 seconds later immediately get a request to drive someone. So we will default the starting value of driving to be false. So this says if the driving flag is not provided whenever a driver is created, it will start off as false. And so for us, that's probably going to be very handy because, again, we don't want someone to sign up as a driver and then immediately be told hey, you just got your first passenger, congratulations. Okay, so the last thing we have to do is associate this driver schema with Mongoose. Let's do that. So we'll make our driver model, mongoose.model driver, and we'll pass in the driver schema. And then finally, we'll export the export the model with module.exports equals driver, like so. All right, this definitely looks like a solid start to our application on the Mongoose side of things. We've got the ability to at least understand what a driver is. Let's continue in the next section and start wiring up our first API route to manipulate our collection of drivers. Now that we've got our driver model put together, we can add in our first real integration between Express and Mongoose, which will be to give users of our API the ability to create new drivers. So that's the first route we're going to be working on, the ability for users to create drivers. And again, when I say users, I mean people who are consuming our API, which would in theory be people who are like signing up as drivers to our application. So every single operation that we're going to add in to our app is going to take place in two separate parts. First, we'll add in a route handler to our routers file, and then we'll define a corresponding function on our driver's controller to specify what to do when that incoming request comes in. So the first type of request that will come in will be to receive a request with the intent of creating a driver. As a reminder, whenever we want to take an incoming driver request, we said that it should be a type post request or a method of post to the URL /API/drivers. Do note that there's really nothing inherently special about this URL right here. We can use absolutely any route that we want, but by convention, whenever we are manipulating a type of resource, like a very distinct resource, in our case drivers, a creation or attempting to create that resource will usually take the form of a post request to / whatever the name of that collection is, which for us is drivers. So let's give this a shot. We'll first start off inside the router and then move on to the controller file. One other thing that I want to mention really quick is that we have not yet added in any logic to our application for actually connecting to Mongo. So we'll take care of that in just a moment when we start to write some tests around testing the code that we're about to add. So I'm going to add in my request app.post. This time it's post, not get. It is post because we're going to be expecting an HTTP request with a method of post to the route /API/drivers. So whenever this request comes in, go to the drivers controller and run some function. For us, we're going to call that function create. Okay, so that's the name of the function we're going to make. So drivers controller dot create. And again, remember, we are not placing the parentheses on here because we do not want to instantly run this function right here, the instant that our app boots up. We are passing a reference to the function so that this function be called many times in the future whenever someone makes a request to this route right here. So no parentheses after the create. Okay, so this looks good. Let's now flip over to our controller and we will create this create function. So here's my driver's controller. I'm going to add on another function called create that's going to take in request and response object. Traditionally, this is another thing that's by convention, the route, the function that gets called whenever someone makes a request to create a record, we will usually call create. There's similar terminology around updating, editing, destroying, editing, destroying, and reading values as well. And we'll talk about the conventional names of each of those when we get to them. All right, so this is looking pretty darn good. Let's take a quick break and then come back. There's one little bit of issue that we're going to have to address before we start to really implement this create function. So let's talk about exactly what that's going to be inside the next section. We've now got at least a stub put together for the logic that will create a new driver inside of our drivers collection. But I ended the last section by saying kind of mysteriously, there's this one thing we kind of take care of really quick. So let's talk about exactly what that is. If you recall, we looked at this diagram just a little bit ago to describe the different parts of an incoming HTTP request. And in this very particular case, I showed you a post request. So remember, post requests are associated with creating records or at least sending some information to some backend server of sorts. A post request has the option to include a request body, which contains some information about the record that should be created. In our case, we might have a request body that contains an email property with the email of the driver that we're trying to create. Now, this request body right here is a very interesting little thing in the world of Node and Express. And let's figure out exactly why it's so interesting. So I'm going to pull up another diagram really quick. Give me just a second. All right, here we go. So whenever we have an incoming post request to API/drivers, I'm going to expect that there is some type of body associated with that request. Something that says, hey, please create a new driver, and here is the email of the driver that you should use. Now, what's really important is to understand exactly how Node receives that body of the request. So when we make this request up here, up on the very top, Node says, aha, a new request, fantastic. But the key is that Node does not just instantaneously receive the entire request. Instead, it receives tiny chunks of it at a time. So when the new request is issued, there is some like initial boot up or handshaking phase, and then Node receives a little part of the request, and then another little part, and then another little part. And eventually it says, okay, I've got the entire incoming request. Now it's time to actually call the route handler. So the really interesting part of this entire process is that there is this kind of negotiation phase with the request body. By default, Express does not do a very good job of handling the body of the request. Like, it doesn't actually kind of parse that request body and end up as something that we can look at and access directly via JavaScript code that you are used to writing. Instead, we're going to use a tiny library called body parser to take the incoming parts of this request and convert it into something that we can actually make use of. Let's check out the documentation for this library and figure out exactly how it works. So inside of my browser, I'm going to navigate to npmjs.com, and then I'll do a search for body parser, and it should be parsing middleware. Okay, so you can read the documentation here all you want, but what the really important part is right here at the top. Parse incoming request bodies before your handlers, and after that body is parsed, it will be available as rec.body. So we know what rec is. It is the incoming request object. What the middleware does is it parses the body of the request and then places it on a property .body on the request itself. So that's going to be really important for us later on. If you'd like, you can continue to read a little bit more of the documentation in here. Totally up to you. But we're definitely going to go through all the setup. We're going to go through all of it right now. So let's get to it. As a quick aside, body parser used to be a default part of Express. It was just wired in, included by default, which totally made a lot of sense. But the library authors eventually said, well, we don't really like having these two libraries paired together. So they eventually made the decision to split them all off or split them into separate libraries. And so now, even though you really feel like if you're using Express, you should be able to just handle post requests, and not quite. You have to wire up this extra part to the application. So let's install this library. At the command line, we'll run npm install -- save body -parser. So do note there's a dash in there. You can verify over here on the right-hand side. Don't forget the dash between the two. Okay, so we'll install this thing, and now all we have to do is wire it up to our application. This body parser library is something that we call a middleware, and we're going to talk about exactly what middleware is in a little bit. And as a matter of fact, we're going to write our own middleware, which will be a lot of fun. But for right now, we'll just focus on kind of wiring this thing up and figuring out how it works. So inside of my app.js file, I'm going to require in the body parser library. So body parser, require body -parser like so. Then to wire up this middleware, as it's called, to our Express application, we'll call app.use body parser.json. And notice that we are invoking JSON. It is a function right here. So this JSON part right here says any incoming request, just assume that it is JSON and parse it into an object for us, which is exactly what we want because we are going to be working with JSON, which is essentially the absolute lingua franca of all APIs out there. So definitely want to be working with JSON. One thing that is extremely important, extremely important, And I'm going to tell you exactly why when we talk about middlewares in just a little bit. But what's extremely important is that you place this app.use call above the routes call. Okay, so app.use and then routes. This is right. This is not right. Okay, so we want to call routes second. I'm placing a ton of emphasis on this because it does really throw people off a lot. Okay, so our body parser JSON is now in place. Let's continue in the next section. We're going to do a little bit of additional code inside of our driver's controller. We'll figure out how to make a test request to our application, and we'll figure out exactly what does that rec.body property look like. So let's figure out exactly what that looks like in the next section. Now that we've got our body parser in place, we can wire up our request handler right here and at least get a little bit of an idea of how this thing works, especially the body parser library. So inside of here, let's just for right now, let's just console log rec.body. That's what the documentation said that would be populated with the result of the middleware. So let's console log it and just see what we get. After we console log it, we'll also send back a response of, let's do hi there again. Why not? Okay, so rather than try to make a post request from our browser, I think that probably what makes the most sense is to make a new test inside of our test directory in which we'll test the create function of our driver's controller. I think that definitely makes a lot of sense. So we can run the test and we'll expect to see rec.body in our terminal whenever we run the test. So we need to first make a test file for our driver's controller. Inside of my test directory, I'm going to make a new folder called controllers. And inside of there, we'll make a new file called drivers controller test.js. So this is going to have everything having to do with testing all the logic around our driver controller. We're going to also kind of incidentally test some of the logic that's set up inside of our router as well. So I'm not going to have a separate test for my router file. I'm just going to test everything from the driver's controller file. So everything from making the request to asserting that some new record was created in our database or whatever else ends up being appropriate. So let's put down some of the boilerplate for our test inside of the driver's controller file. All that boilerplate in here is going to look very similar to the app test that we just made a couple sections ago. So we'll first pull in assert. We'll then get our request object from the super test library. And then we'll pull in our app object. We now have to go up 2 directories to get access to our app because I'm now inside the controllers folder. So I'll go up 1 directory, up another, and then I'll get access to my app. Okay, let's define the describe block. So I'll describe my driver's controller. And then inside of here, we'll place our first it statement. So it, I'm going to say post to API/drivers creates a new driver. And then I'm going to make sure, because this is definitely going to be an asynchronous spec, to include my done callback. Now, in this single test, one more time, I'm going to kind of test everything having to do with making a post request to API/drivers. So I'm going to, I have a very descriptive it statement on here to make sure that it's really clear to any other engineer who reads this in the future exactly what this test does. So I'm making a post request to my route. Here is the result of that request. And we're going to follow this same kind of template where we have method, route, result in all of our other tests inside this file as well. So now inside of here, we can add some of the logic to make a request to our app. So we'll use that super test library to make a request to our app. This time around, we are not making a GET request. We are making a POST request. So I'll say .post to API/drivers. Remember, each of these chained on statements in here, like the .post, are configuration options. So I need to make sure that I also post along some data to be used by the controller to create this new driver. To send along some data with the request, I can use the .send function. So I'll send along an object that contains an email, test@test.com. I'm sending along the email right here, not because we have any code whatsoever that's going to make use of this just yet. I'm sending along an object that has the email of a driver because that's the schema that we had put together, right? We had said every driver that gets created must have an email. We defined the email flag and we said that was required at all times. So I'm passing along this .send with email right here just to be a little bit forward looking, because I know eventually we're going to have to make use of this thing, or we're going to have to provide an email, even though we don't necessarily require it just yet. The other thing to keep in mind here is that request, or the .send function on here, does not mean like send the request out. It means make a post request and also send along this information to the server. So you'll notice that there's a little bit of kind of a mismatch in API here. On the test side of things, the .send function is customizing the request that is being sent to our server. On our server side of things, however, the res.send function is what we use to send a response back to whoever made the request. So I just want to point out that difference in particular, because the function names are identical, but they have two completely different purposes. So then after sending that data along, we will end the request. This time around, we are not going to worry about any of the returned error or response objects just yet. Let's just call done. Let's just not really do anything. Let's just call done, let the test run. Remember, the only goal right now is I really want to see my console log inside of my driver's controller. I want to make sure that the object that we send along with the response body shows up on this rec.body property. That's all I really care about right now. Okay, so I think this is all we need to get started. Let's save this file and then flip over to our terminal. Looks like the test is running at least successfully. We don't actually have any assertions just yet, but that's okay. And we've got a console log of rec.body. So clearly, any data that we send along inside of a post request will be placed inside of rec.body with whatever was sent along with the post request. And that's pretty much it. So this is looking pretty good. We now know how to send data to our server, at least via our test interface over here. So at this point in time, we are receiving rec.body, or the email address of the driver we're trying to create, inside of our create function. So I think this is now time to move on to the Mongoose side of things. And we want to make sure that whenever someone calls this route right here, we will create a new driver making use of this rec.body object. So let's take care of that in the next section. I know that I just said that we were going to work on the controller side of our application now and receive the incoming driver and save them to the database. But I'm kind of thinking maybe it would be really nice to write the entire test around this request handler first, see the test fail, and then write the actual implementation. So right now, we just have the request making logic. We don't actually have any assertions in here. So how about instead, let's write in an assertion or two, and then go work on the controller itself, and then we can have a lot of confidence that the test is working properly. So let's go with that route. Maybe that'd be a little bit more fun. So as far as making an actual assertion in here, there's a couple different ways we can make. So what are the different ways we can test to make sure that this request was actually issued correctly and received by the server? I'm going to suggest 3 different possibilities. Okay, 3 different ways we could go about this. The first way that we could test this request is to look at the response object that comes back after the request is completed. We could look at the response, and maybe we will assume that the response will contain the driver who was just created, which totally makes sense, right? Like when a driver gets created, it totally makes sense to send that model back to whoever made the actual request to say hey, here's the record that was just created. That's totally reasonable. So we could look at the record that comes back and just assert that it exists. Hey, the request was completed successfully and we got a driver back. Clearly they must have been saved to the database. So that would be method number 1. Method number 2 would be a little bit more classic, a little bit closer to what we've been doing already as far as tests go. So method number 2 would be to maybe add in an assertion right here to look inside of our drivers collection and just assert that a driver with an email of test@test.com exists. So that would be another approach, number 2, that would be totally reasonable and very in line with what we've done so far. The third option, this one's definitely going to be kind of the most challenging one, would be to look at the number of drivers that we have inside of our drivers collection before the request is even made. So maybe right here, we take a count of all the drivers in our drivers collection and we say like, okay, currently 0 drivers inside of here. We then make the request, then we take another count. How many drivers are now in the collection? And we assert that there should now be 1 driver inside of there. So this would be the other route we could go. We can take a count beforehand and then take a count after the request has been made and assert that there has been 1 additional driver added onto the collection. So that's the 3 different ways we can go. I'm going to suggest that just to show you, because we've done the case in which we find a very particular email of a record, we've definitely done that several times before. I'm going to say that we'll give the count methodology a try here. So we'll count the number of drivers ahead of time and then count the number after the request has been completed, and we'll assert that 1 additional driver has been created. Now, maybe that's not the best test in the world, and I think maybe it's not the best because we're not actually asserting that a driver with the correct email was created. We're just asserting that a driver was created, period. So maybe it's not the best test, but I think I just want to show you some different methodologies for testing. So I think that's what we'll go with this time around. Okay, so let's do it. Our job is to get the count of drivers before the request is made, do the request, take the count afterwards, and then assert that there is a new driver or like 1 additional driver inside the collection. So the first thing we're going to have to do is import our driver model into this test file. So at the top, we will import driver, and we're going to do so not by requiring in the model. We'll do so by looking at Mongoose and getting direct access to the driver model this way. Now we also need to make sure that we require in Mongoose as well. So const mongoose equals require Mongoose like so. So you might be wondering, hey, why in the world are we getting access to the driver like this? Why are we not just requiring them in? Well, this goes very closely back to some of the discussion we had previously where I had mentioned that Express, Mocha, and Mongoose do not always play together very nicely. And so this is kind of a workaround for the fact that they don't really jive that well inside of a test environment. And like I said, we're going to see a couple instances of this where these things don't really work that well together. In this particular case, the reason that this stuff doesn't work well together and the real reason that we are accessing the driver model in this fashion is that Mocha kind of tends to try to require in these files more than one time. Essentially what happens is the driver file ends up getting executed more than one time, which means the driver model is going to be attempted to be created more than one time. The net result of that is that we end up with this big error message that says, hey, you're trying to declare a driver model when one has already been declared. So this is just a little bit of a workaround for that. Again, I don't want to go too deep into it. Just know that Mongoose, Mocha, and Express sometimes have a little bit of nastiness to them. Anyways, back to it. We've now got our driver model. So we're going to take a count on the driver collection. We've done this one time before. So we say driver.count. That is an asynchronous operation because we have to go over to Mongoose, over to Mongo and say, hey, in your driver collection, how many records do you have right now? So this is something that takes some amount of time to execute. So it does return a promise. So we're going to get back the count. Only after we get back the count will we make our request. So I'm going to take the entire request. I'm going to move it into the callback or into the .then statement for the driver count. Okay. So I'm adding in a couple little extra spaces in here just to make the syntax a little bit more legible. This is definitely some very highly nested logic that we've got. I'm also going to zoom out just a little bit so you can see all the way left and right. So now when we make our request, we know how many drivers we're starting off with by virtue of this count variable right here. So after we successfully make the request, we will now take a count on the number of drivers again. So inside of the .end, we'll say driver.count. Then we'll take in the new count as a variable called new count. And then inside of here, we will assert that count. So count right here is the starting count. It's the original counts, like the very first count, plus 1 is equal to new count. So basically we're saying if we started off with 0 drivers, add 1 to that, because only 1 should have been added, and that should be equal to the new count. And then finally, after the assertion, we'll call our done callback. And I'm also going to make sure that I clean up the .then outside of the count function. Okay, so again, a very nested statement. We take the initial count, we make the request, we take another count, we assert that the 2 are off by 1, essentially, and then we call our done callback. So I'm going to take out some of the new line characters in here now, just to compact everything down. Cool, so that's basically everything we need. Let's see how our test suite is doing at the terminal. So I'm going to flip back over and ouch, yep, we got a nice big failure inside of here. So it says schema hasn't been registered for model driver. Well, that's a little bit unexpected. Didn't I just say that the issue with all this stuff is that, you know, the models are getting required more than once? But what's this message? Clearly something is off here. Let's take a break, come back, and make sure that everything in our Mocha world, or excuse me, everything in our Mongoose world is taken care of, because clearly it is not very well set up right now. So let's take care of that in the next section. In the last section, we put together our first complete test around our Express application, something that tested not only the request or the request phase of things, but also the underlying Mongoose manipulations of the driver collection. But we saw a nice big error message, something about schema hasn't been registered for model driver yet. So use mongoose.model, name, and schema. So what this message really means right here is you are trying to get access to a model called driver, which we are in fact doing inside of our test file. Here's our driver controller test file, and we're trying to pull out the driver model. But it's saying you haven't registered anything called driver yet. So what's going on here? Well, this one is not the weirdest error in the world to troubleshoot. We created our driver model, but where did we require it to? Like where in our application have we required that model into so far? If your answer is nowhere, that would be absolutely correct. So we created the driver model, but we have not yet required it anywhere into our project. And so that is something that's very important to keep in mind. Sometimes inside of a Node application, super common, you'll have some files where you define them with some very useful code, but they don't necessarily export anything that you immediately need to make access to. You have to remember, in that case, that you require it into at least one location just to make sure that the code inside of it is actually executed. So to solve that error message, I'm going to open up my drivers controller. Because this is the location where we're going to work with our drivers most frequently, I'm going to import that model into this file. And just by requiring it in, that's going to ensure that the driver itself, all the code inside of there gets actually executed, and that should make the error that we saw inside of our test file go away. So inside of my drivers test file, I'll say const driver, require up1 directory into the models folder, and then get the driver. So let's save that and see how our test is doing now. Okay, so now it looks like we've got that deprecation warning around Mongoose's promise library, and it also appears that our test is not resolving at all. So let's figure out what's going on now. So at this point, if we check out our drivers test file, you'll notice that we are trying to get access to the actual drivers collection on our MongoDB database. But again, if you remember, we're a little bit short on setup. We have not yet hooked up Mongoose to an actual instance of MongoDB. So we need to make sure that, that Mongoose gets connected to MongoDB. To do so, we'll put a little bit of setup code inside of our app.js file. So yes, I know this is a lot of like flipping between files. Unfortunately, that is sometimes the nature of backend development. So I'm going to open up my top level app.js file. We will import Mongoose into this file, and then we will make sure that we connect to our MongoDB instance. So at the top, we will first require in Mongoose, and then we'll place our mongoose.connect statement. So we'll connect to MongoDB / localhost, and we're going to call this database Moober, like so. In previous instances, we would then hook up some event handlers to watch for success and error messages in that connection. This time around, I'm going to tell you right now that this connect statement is not the end of all of our troubles with connection with Mongoose. We're going to talk a lot about how production style applications work with MongoDB, and it's very tightly coupled around this line of code. So for right now, we're not going to put on any error or success message. We're just going to leave the connect statement there as is. And then the other thing that we're going to do is fix that deprecation notice about the promise that Mongoose uses. So we'll say mongoose.promise equals global.promise, like so. Okay, so let's see how our tests are doing now. I'll flip back over. And okay, well, down here, here we go. So now we are getting a unhandled promise rejection. In other words, the test is failing. We are making an assertion that is not correct. So what that means, this is the next little bit of troubleshooting. I know this just keeps going on and on. That now means that inside of our test file, the whole request is being executed successfully. We're getting all the way down to the assertion, but the count of drivers is not being increased. Whew, that's actually good news, because it means we need to move back over to our drivers controller and make the thing actually create a brand new driver. So let's take a quick break after all this troubleshooting of tiny little issues, come back in the next section and start working on the create function of our drivers controller. After troubleshooting a little setup issues inside the last section, we are now finally ready to work on our create handler for our driver create function. Now inside of here, we've got two lines of code, one for our existing just send back of dummy response right here. We definitely won't need this, so I'm going to take it out immediately. And the second thing we've got is that console log statement where we console log the value of rec.body. So this console log statement in here was being triggered by our test that we've already written. And we've seen that console log statement several times now. Here's that console log. So here's rec.body right here. It is the email of the driver that we are trying to create. So clearly it is correctly coming across. So our goal now is pretty straightforward. All we have to do is create a new driver, save it, and then send the driver that was just created, like the entire model, back in the response to whoever made this HTTP request. With the way that our test is currently written up, our test should immediately start passing once we wire this thing up. So I think we got pretty clear criteria for what we need to do moving forward from here. So the first thing I'm going to do is I'm going to get a reference to this rec.body property, and I'm going to refer to it as driver props, like so. So this driver props object represents the data or the properties that I want to use to create a new driver inside of my driver collection. We have several times now gone through how to create and save a record to our MongoDB collection. So we'll take our driver model, which we've already required in at the top of our controller. It's up here. We'll call create, and then we'll pass in the properties that we want to save. So driver props, like so. This returns a promise, so we'll chain on a .then. When it gets resolved, the callback inside the promise will be called with the driver who was just saved. So we will take that driver and we'll send the entire thing back to whoever made the HTTP request. So now in theory, after you make a post request to the create route of our application and include some email for this driver, we should be creating the driver and then saving them and sending them back to whoever made the actual request. So let's save this. To test it, all we should have to do is flip back over to our terminal and see our test passing. So we'll scroll all the way down, and yep, there we go, 2 tests passing. Fantastic. It actually works. Thank goodness. So it definitely took a lot of effort to just get to this point, like through all the setup that we had to do with Node and Express and Mongoose and Mocha and all that kind of great stuff. That is actually one of my larger complaints around Express in general, and really Node development in general. I've got a little bit more of a background around Ruby on Rails, and with Ruby on Rails, doing these very basic creation routes takes a fraction as much time. And so whenever people ask me questions about, well, hey, Steven, should I be using Ruby on Rails or should I be using Express? It really comes down to you. At the end of the day, I really do like having JavaScript all the way across the stack, but sometimes putting together these very basic routes, all that boilerplate setup you have to do is just a little bit of a pain in the rear, and Ruby on Rails definitely takes care of all of it for you in like the instant you generate your application. So total opinion there. I don't want to dissuade you from Node setup. Once you get everything rolling, development is awfully quick. And I think you're going to find that the remaining routes that we have to put together inside of our course are actually going to materialize like pretty darn quickly. So doing the edit and delete functions as well, we're going to do that very quickly. Anyways, just a quick aside. So our test is now passing. This definitely looks fantastic. Let's continue in the next section where we're going to figure out how to call this create route right here from an actual application and not just our test environment. Like, how do I, from a web app or a mobile app, how do I actually call this function create a driver? So let's figure out how to do that in the next section. We've got our first working and well-tested route inside of our application, but so far we've only actually kind of accessed it or called it directly from Mocha itself. So in this section, we're going to walk through the process of testing this ourselves manually. And we're going to figure out exactly how we call and invoke this function. To do so, we are going to be using a tiny program called Postman. Postman is an API client. It's made for making arbitrary HTTP requests to any given server that you might want to just make a request to and test out for fun. Depending on your definition of fun, I suppose. Anyways, let's first install Postman and then figure out exactly how it works. So inside of Google Chrome, it is a Chrome application, so I do have to be using Chrome to use it. I will open a new tab. I will find the Apps button. I'll click on Apps. And then as you can see, I've already got Postman installed on here. But if you do not yet have it installed, you can click on Web Store. We'll search for Postman up at the top left-hand side. And you'll find Postman REST client. That's exactly what we're looking for, except not that one. Let's just search for Postman. Okay, that's better. So we're looking for Postman. Under the apps section, you'll see Postman right here. I've already got it installed, so of course it doesn't give me the option to actually install it. I'm going to go ahead and launch it by clicking Launch App. So when you install Postman and launch it, it pops open with its own interface, completely separate from your Chrome browser. It takes a little bit to boot up. Eventually it'll get there. Hopefully it's faster for you. All right, there we are. So when you first start up Postman, you're going to see a view that looks a little bit like this. On the left-hand side, you get a history of all the different requests that you've made. And as you can see, I've tested out this endpoint several times on my own. So I don't really need to look at my history, so I'm going to turn it off just to give myself a little bit more screen space. There's a couple different super important areas of this window. Again, the point of this tool is to make HTTP requests, to any given web service you might want to access. So on the top left for me, what will be the middle left-hand side for you, you'll find a drop-down to select the type of request that you want to make. So inside of here, you can see a GET request, post, which is useful for us, put and delete, and you can see all the others that we have not yet discussed and probably won't really get to. So we want to make a post type request to our server. So I'm going to select from this dropdown, post, because that's the type of request we want to make. The URL that we want to make the request to is going to be the URL of our currently running server. So for us, it's going to be http://localhost:3050, so that's the port we're running on, /API/drivers. So this is where we are going to make our post request to. Now, before we go any further, we need to make sure that our server is actually running. So I don't know about you, but I did close out my server a while ago. So I'm going to flip back over to my terminal. I'm going to go into my project directory, and I'm going to start up my server by running node index.js. And we've done this once before very quickly. So here's my message running on port 3050, so everything should be going well at this point. So coming back over to Postman, if I make the request at this point, I'm going to not expect it to behave as I expect because I have not yet passed along an email to be used when I try to actually save the driver. To specify a body for the request or the email that should be used for this driver, I'll click on the body tab right here. And then I'm going to select the raw option on the right-hand side. And then from the dropdown, I'll select JSON. So make sure you select JSON on here, not JavaScript. We're looking for JSON. So by selecting these options, this means that we are trying to post some amount of JSON to this server that we are currently running. Whenever you make a post request using, say, jQuery or Axios or the Fetch API, that emulates, or really it's identical to the settings that we've specified on here. So it is a post request of type JSON or application/JSON. So now we need to pass along an object that's going to contain the email of the driver that we want to make. So inside of the body of the request, we will write in some amount of JSON. Remember, this is JSON in here. This is not JavaScript. With JSON, we must place double quotes. So I'm going to place double quotes. I'm going to specify the email property and then an email to use for my new driver. So very important, I'm going to say it very loudly to you right now. Make sure you have double quotes on both sides. It is required by JSON. We are specifying JSON here. JSON uses double quotes, not single quotes. So now that we've got all this in place, I'll click send and then scroll down a little bit, and here's my response. And all right, this looks like the model that came back. So you'll notice that the model that it should now be preserved inside of our MongoDB database has an email, the ID, and the driving flag, which has been defaulted to be false. So exactly what we would expect. Fantastic, so this definitely looks good. Now there's just two very small issues that I want to point out to you really quick. Two very small issues. The first is a little bit not too obvious. If we flip back over to our testing folder right here, and I open up my driver's test file, you'll recall that we are using driver.count inside of here to decide how many drivers or whether or not the request handler actually worked as we expected. But we are missing a very critical step inside of our test setup. We never added in a test helper file to drop the contents of our driver collection in between each test. So the result of that is that every single time we run our test suite, it is just adding on another driver to the pile. The way that our test is written right now is still going to work no matter how many drivers are in the collection, and that's why all of our tests are still passing. But chances are we don't want to keep accumulating drivers inside of our database, so we really need to make sure that we add in a little bit of logic inside of a test helper file to be sure that we drop our driver collection in between each run of our test suite. The other thing that I want to point out that is very closely related to handling creating drivers is if I come back to Postman and I delete the entire request body. So I'm just going to delete everything that's inside of there, and then I click send, you'll notice that I'm just stuck at loading right here. I'm just stuck there. Well, what's going on? I'm going to flip over to my terminal and pull open my running server. Here it is right here. So here's my running server, and you'll see that I've got a validation error, path email is required. So path email is required means we have that required flag inside of our schema for the email, right? We're saying a driver must have an email in order for them to be created. So clearly our server threw an error right here, which means it never got to that res.send statement inside the controller. Here's the controller right here. Here's the create function. We had said send a response back to the whoever's making a request to our API only in the case that the driver is successfully created. So if an invalid record is sent to our API, in this case one that doesn't have an email, the request just hangs instead of throwing an error or responding with an error status code. So clearly something is not working very well on the error handling side of our application as well. So that's our two big tasks in the short term. On the one hand, we need to figure out how to clean out our test database every time that it runs. And by the way, that's going to be a little bit harder than the previous times, so that's why it's going to be a big deal for us. And number two, we also need to figure out how to handle errors on our server a little bit more gracefully than we are right now. So let's get started on tackling both those challenges inside the next section. In the last section, we spoke about two really big issues that are currently confronting the development of our application. On the one hand, we still have to add in some logic to make sure we drop our collection of drivers after every test runs, so we don't just constantly accumulate drivers. And the other big issue is that we're currently not handling errors very gracefully inside of our application as well. So in this section, we're going to work on adding our test helper file and make sure that we drop our collection of drivers in between every run of our test suite. I did mention very briefly, however, that this time around, that logic was going to be just a little bit more tricky than how it was previously. And in fact, it really is. So let's talk about exactly why that's going to be such a little hassle. I want you to think very carefully for just a second about how you might be developing and actively working on this application as we're putting it together right now, right? Like just think about your day-to-day, how you would really work with this thing. You're probably sitting there like day-to-day, writing some code in, whatever it is, blah, 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 blah. And then maybe you run your test suite and the tests all run, you're all happy. And then you also flip over to Postman and maybe you like manually create a couple drivers and you look in the database and make sure that they're there. And then you come back over and you make a change, you save the file, your tests automatically rerun, and then you flip back over to RoboMongo and all of a sudden, hey, wait a minute, your driver collection just got dropped. So that is a huge issue with our development environment or our current development workflow. In the past, every single time that we saved a file, like when I say the past, every single other application we worked on, every time we saved a file, we would be dropping our collection of drivers. But in a real application, when you're developing it, sometimes you want your data to sit in there. So you can flip over to Postman or work on your React application and see the data sitting in the database and then not mysteriously see it wiped away every time your test suite reruns. So clearly there's a little bit of work to do here to make sure that sometimes when our tests run, all the data gets dropped, but when we're doing development, the data does not get dropped. So just to make sure it's really clear what I'm talking about here, this is kind of the setup that I'm talking about. On the one hand, when our server is running for us doing development or production, when our server starts up, we connect to our database and that's it. Don't do anything else. We can modify the database over time by accessing some API routes or what have you, but essentially just leave the database as is with all the data just sitting inside of there. On the other hand, when we're running our server to test our code, we want to start up the server, connect to the database, and then rapid fire drop our collection of drivers to make sure that the entire thing gets emptied out again and again and again between every single test run. We don't want this drop collection step to happen when we're running our server in the test environment. So again, clearly there needs to be some dichotomy or some separation between these two concerns here. So let's take a quick break, come back, and figure out how we are going to deal with this separation between our development environment and our test environment. In the last section, we spoke about the need to have a little bit of different behavior between our server when it's running in the development environment and when it's running in the test environment. So to handle this very different separation in here, or this very different manner in which we're going to treat our database, we are going to introduce the idea of an environment variable. An environment variable is a variable that is defined on your actual physical machine outside of the world of Node.js or outside of our running application. An environment variable is a global variable that can be referenced from inside of Node. Environment variables are traditionally used to customize the behavior or to encode some number of constants that we can access within our application. One of the most common environment variables that you'll make use of when developing Node applications is one called node_env, which is short for node environment. We use this global or this environment variable to specify whether or not our server is currently running in a development, test, production, or any other type of environment. We can use the value of this variable to make different design or different decisions within our application. In our case, we will look at the value of node_env to decide whether or not we want to empty out our entire collection of drivers. To get access to this environment variable from within our application, we can make reference to a variable process.env.node_env. The same is true of any other environment variable we access. They all get placed on this process.env object. So let's give this a shot. Let's see how it comes together. The first thing we need to do is make sure that we correctly set this environment variable whenever our server is ran. So I'm going to flip over to my code editor and I'm going to open up my package.json file. Inside of here, we have that test command right here. We can set environment variables to run just for specific commands when they're executed. To do so, before nodemon, we can say node_env equals test. Now, whenever we run our test suite, the node env variable will be equal to the string of test. And so that's exactly what we'll use throughout our entire application to decide exactly what we want to do with our database. So let's now flip over to our app.js file and we'll make use of that environment variable to customize exactly how our application behaves. I also want to pull up the diagram we were just looking at a second ago. So I had been saying, hey, when we're running in development, start up the server and just connect to the database. But when we're running in test, go ahead and drop our collection all we want. Now the very important thing to keep in mind here is that we've just got one copy of this database at any given time. So even though we've got this flag that we can look at now to decide whether or not we are currently working in a test environment, that doesn't necessarily mean that it makes this job of dropping our collection any easier, right? Like, we still don't know. So what we're going to do is we're going to wrap our connection statement in here with an if statement. We'll say if we are currently not in the test environment, then go ahead and connect to a database called Moober. And then here's the real key. Here's like the real buildup. Here's how we're going to make everything work. Inside of our test helper file, we will say always connect to a database called Moober_test. So to solve this whole issue of dropping our collection of drivers, rather than toggling whether or not we drop that collection at all, we will just use two separate databases. That's how we're going to solve this issue. So inside of our app.js file, if we are currently running in a not test environment, so if we're running like in the development environment or a production environment. So if process.env.nodenv is not equal to test, then connect to this database. So now whenever our application first boots up, whether or not it's in development, whether or not we're launching it from our command line with node index.js, or if we're running it in some future on a production machine, we'll come to this control statement right here. If we are not running in the test environment, then go ahead and connect to this database. If we are running in the test environment, however, don't connect to it at all. Just don't even touch it. Don't even try to access Mongoose from this line of code right here at all. Instead, we will add a test helper file to our application, which will be used to connect to Mongoose. The reason that we're going to place that statement or this connection string to this other database inside of a test helper file, rather than just doing it in here, is because it's going to be a little bit easier to make sure that our test suite only starts up once our connection to the database has been initiated. And so that's going back to the topic of how using Mocha with Express and Mongoose is sometimes a little bit of a pain in the rear. Mongoose and Mocha by default don't work together too fantastically, as I should say, they don't work together as nicely as I would really like, just personal preference. So let's go ahead and take care of that test helper file and just get it all done in one go. Inside of my test directory, I'm going to make a new file called test_helper.js. And inside of here, we'll place some logic to connect to our Mongoose database. Now note that we do not have to wrap this connection string with a variable to check, or excuse me, with an if statement to check if we're currently in the test environment. If the test helper file is being executed, yeah, it means we are in the test environment. So we don't have to explicitly check that variable. So inside of here, we'll require in Mongoose. Then we'll replace our before statement to connect to our database. So we'll say mongoose.connect, MongoDB, localhost, and this time around, rather than connecting to a database called Moober, we're going to go to Moober_test. So that's the magic. We're using two completely different databases. The Moober test database can get dropped all day long. We can drop it as many times as we want. Nothing bad is going to happen. We won't be touching any of our development data, which we might over time customize and have some data saved that we really want to stick around in between test runs. And we'll also place our handlers for looking at the connection status. So once the connection is open, we'll call our done callback. And if there's ever an error, we can launch a console warning statement of warning with the error message like so. So just to be 100% clear, I mentioned just a second ago that we were not going to place the kind of else statement in here, hey, if it's not test, connect to Moober test. We're not placing that inside of app.js explicitly because we only get access to this idea of the done callback inside of our test helper world. So by placing this connect statement for our test database inside of the test helper, we are able to say, hey Mocha, hold up, don't run any tests until the connection has been opened. Otherwise, if we were to completely forget that test helper file and locate all the connection logic inside of here, sometimes Mocha will execute our tests before the connection has been made to our database, which means all the tests are going to fail because the connection has not actually been made. Okay, so after that, let's place our before each statement to make sure we drop our collection of drivers. So this is going to look very similar to what we had previously. We'll pull our drivers collection off of mongoose.connection.collections. We'll call drivers.drop, and then we can call our done callback. And one other thing in here, we're also going to toss on a catch statement as well and place the done callback in there as well. The reason we've got the catch statement here for done is this handles the very first time that our test suite runs with this new database. So the very first time that our database runs, we do not yet have a drivers collection in existence at all. And so if we try to drop a collection that does not exist, an error would be thrown, which is totally fine. Like, we're totally okay with that error, but we do need to make sure that we continue on the test suite and let all the rest of the tests run. And that's why we add on the .catch statement for handling that case. So let's save this file. Our test should now be running after we restart our server. So I'm going to close everything out. We'll rerun npm run test. Okay, 2 tests passing. Just to make sure everything works, I'm going to resave this file, and I should see again 2 tests passing. Okay, fantastic. So now in theory, we have complete separation and divide between our development environment and our test environment, exactly what we would want. So that solves one of our 2 issues. The other issue we still have to resolve is making sure that we correctly deal with error handling whenever a request is made without some valid email being placed in here. So let's take care of that in the next section. Our application has 2 big issues. We just solved one of them, which had to do with testing with our database in a dev versus test environment. So now it's on to the second big problem, which is error handling. We had seen that if we made a post request to our driver's endpoint without any data attached to the request, it would just kind of hang and wouldn't resolve, even though the server clearly knew instantly that there was something wrong with the request. So we need to make sure that we do a better job of error handling with our Express server. So this is exactly what we're going to use middleware for. We've already used middleware once with the body parser library. So now we get to learn a little bit more about middleware, figure out how to write our own middleware from scratch to handle errors inside of our app. So let's start off by figuring out exactly what middleware is. Now, we've looked at this diagram once before already. We saw that there was the incoming request. It would go to Express, and then we had the outgoing response. So I've had a couple of boxes in here to represent exactly where middleware is inside of Express. Whenever a request comes into our application, any middleware that we write and register with Express will be automatically called with our request and response objects. And so this diagram is slightly misleading. It shows this outgoing request right here, outgoing response down here. But in fact, the response object, which we've already seen inside of our handler functions, is passed to every middleware as well. The purpose of a middleware function is to do absolutely anything that it wants to tweak or log or otherwise operate in some fashion on the incoming request and outgoing response objects. We can even view the handlers that we've been writing, like the route handlers inside of our controller, as middleware of sorts, because they take in the request and response objects and then operates on one of the 2. The middleware that we're going to be writing will receive the request and the response object and also any error object that comes along as well. And so, how does that kind of fit in the equation? Let's take a look at another diagram to figure out exactly how it's going to work out. So we're going to have the incoming request and response. It's going to go to our body parser middleware, which is going to process the request that's coming in some fashion and enhance it in some fashion by adding on that .body property. If we have any other middleware already registered, it'll go there as well. And then it'll end up going to our request handler. Now, in the case of our request that we have right now that results in an error, we're getting an error from our request handler when we try to save a driver without an email. And so that's represented on this diagram as this big boom. So if our error handler throws an error, it will automatically go on to the next middleware in the chain. So what we need to do is write a new middleware object or a new middleware function and make sure that it is executed after our router file, our router functions. So if anything goes wrong inside of our router function, it will be passed on to the next middleware in the chain. Inside of that next middleware in the chain, we will take in the error, we will form up a response that says something like, hey, something just went wrong, and then we'll send it back to whoever made the request. So that's our plan. We're going to make a middleware. We're going to make sure that it's wired up after our request handlers, And we'll make sure that if anything goes wrong inside the request handler, we tell the request to go on to the next middleware. So let's give it a shot. I'm going to start off by closing out a couple of different files that I have open right now because I've got just so many open. I know it gets confusing sometimes. And we're going to start off by working inside of our app.js file. So here's app.js. We'll define our middleware directly inside of this file. So I'm going to find my routes call. So remember, the routes call is where we set up all the different routes inside of our application. And we can really think of routes as being just like middleware. So to make sure that our error handling middleware is only executed after these route handlers, we'll define the middleware directly after the routes takes place, the routes assignment takes place. Remember, middleware makes, or order in which middleware is registered with Express makes a difference. It determines what order the middleware will be executed in. So because we put the body parser first, it is the first thing to execute, then the route handlers, and then our error handler, which we'll place right here. To declare an error handler, or a middleware of any type, we write out app.use, and then we pass in a function. So as you might be able to guess, based on the app.use with the body parser up here, we can use app.use to register any type of middleware with Express. The arguments that are passed to the middleware are a little bit confusing, but we'll walk through each one of them. There's an error object, a request, a response, and next. So let's talk about each of these. First is this error object right here. This error object is going to be really important for us. The error object will be populated, that is, it will be defined, if the previous middleware threw an error. And so that's exactly what's going on for us. The previous middleware in the chain, which is the request handler, we're expecting it to throw an error. Because it threw an error, or in the case that it does, I should say, this error object right here will be equal to the error that was thrown. So in theory, if this mongoose error message right here, the thing that said like, hey, I expected to see an email defined, if there was an error there, it will be this object right here. So before we do anything, let's just add in a console log for error. We can rerun the Postman test and then see the console log right here and just kind of see what goes on. But we'll do that in just a second. Let's talk about the other arguments here first. Rec and res are both exactly what they've been previously when we worked with them. It is the incoming request object and the outgoing response object. The last argument is probably the most interesting and possibly the most confusing out of all of them, next. So next is not like the others in any way. The first three are objects of some type. Like the first one is an error, but more or less object. Request and res, definitely objects. Next is a function. You can call next to forcibly go to the next middleware in the chain. So if we register multiple middleware with our application, we have to eventually pass control flow off to the next middleware in our chain. Express doesn't do that manually for us. It waits for you to call next. So once we say, okay, my middleware is all done processing everything that it needs, we can manually call next, and that will go and execute the next middleware in our chain. And so next is very aptly named. It literally means like, hey, next middleware, go to it. So for our middleware right here, we don't need to make access to next, or we don't need to call it at all. However, we will in our actual controller, as we'll see in just a moment. Okay, so let's restart our server really quick and use Postman to trigger this error message right here and just see what we're dealing with. So I'm going to first flip over to my terminal and restart my server. I'm going to run nodemon here from here on out so that we don't have to manually do any restarts of our server as well. So I'll say nodemon index.js. We'll start this up, which will start our server. There we go. So now I should be able to flip back to Postman. I'll send off the broken request. The request is still hanging. I'll flip back over and, I don't actually see anything in here about, necessarily handling a log message or, that console log with the error. I see the promise rejection warnings, which we had already been looking at, or we had already seen. But clearly something's, not quite hitting this middleware right here. Could it be perhaps next isn't getting called? Yes, in fact it is. That means that our previous middleware in the chain, the actual route handler itself, has to call next. If you ever expect a request to go on to the next middleware, you have to make sure that next is being called. Next is never automatically called in an express middleware for you. You have to make sure you call it manually. So to do so, we'll open up our drivers controller file. Here it is. We're going to scroll on down to our create function. Here we go. And I'm going to say if the create fails, if something goes wrong here. Remember, this is a promise. So if something goes wrong with a promise, it calls any function that is associated with the .catch statement. So I'm going to remove the semicolon down here on the end. I'm going to add on a .catch. I'm going to pass in the next callback. And lo and behold, the third argument to all of our request handlers up here is next, like so. So next is absolutely key for proper error handling inside of Express. It is the third argument on all of our request handlers. We get request, response, and next. We can manually call next if there's ever the case in which we're kind of doubting that this request handler is going to execute without any type of error. So by calling next, whenever driver.create throws an issue, next will be called. It'll go to the next middleware on the chain, which will be our error handling middleware. So let's give this another shot inside of Postman now. I'll flip back over to my terminal. Okay, it looks like everything restarted automatically thanks to NodeMon. I'll send the request, go back to the terminal, aha, and now we see the nice big error message. So this is what we have to work with. The big error message property that we're going to care about on here, if you go all the way to the bottom, you'll see a property that says message, and it gives the very reasonable message of driver validation failed. We could also look at the errors.email.message property, and that would tell us very directly exactly what went wrong. But I think for the purposes of our API, I feel totally fine passing back this error message right here of driver validation failed. In the context of an API, a little bit more generic error message like this, I think generally or definitely makes sense. We can just say, hey, there was something wrong with the request you just made. You need to figure out what's going wrong with it, and we'll kind of leave it up to our users of our API to consult any API docs we have or something like that to figure out exactly what's going on. So now the last thing we have to do to wrap up this entire middleware, I'm going to go back into the middleware. We don't need the console log anymore. Instead, whenever there's an error, we'll instantly send back a response of error.message. So remember the error object that we just logged, it had that .message property which said driver validation failed. So we're just going to take that whole message, put it in an object, and send it back to whoever made the request, and they can figure out what to do from there. The last thing I'm going to do is I'm going to set an HTTP status code on this. So actually let's test this in Postman first, and then we'll come back and do the status. So I'm going to cancel the current request. I'm going to make sure that my server restarted by saving this file. Okay, restarted. Cool, running on port 3050. I'll go back to Postman. I'll send the request off. And now we get the nice message here, validation failed, and it instantly resolved as soon as it knew something went wrong. So I just mentioned status, like the status code of the request. You'll notice that over on the right-hand side here, it says 200 OK, when clearly, well, the request is an error, like something went wrong. We don't want to tell people that the response or the status is OK when something went wrong with the request. So instead, what I'm going to do is I'm going to manually set a status of 422 on the response object. So this will give it a HTTP status code of 422. So I'm going to send the request off again. Now I've got a status of 422, which means unprocessable entity, which is a great status code to throw back whenever there is a validation error on the record itself. Always nice to throw the correct status code on here. Of course, it just makes these requests on your client side a little bit more predictable. Okay, so that's error handling and middleware inside of Express. Again, the big thing to remember here is the presence of that .next callback is what we use to make sure that we go to the next middleware on the chain. The benefit of this approach is that we've now got a rock solid method of handling any type of errors that are thrown inside of our controller functions. So on all the other route handlers that we define as well, we'll be sure to attach a .catch on each of them to specify what to do if something goes wrong with the actual database operation. Whew. All right. So this has taken a long time to get to this point, but we've finally finished up our first major route inside of our Express application, the ability to create drivers. So fortunately, everything from here on out generally gets pretty easy, and it's generally a lot of copy paste. We're going to be doing the exact same edit and delete function that's going to look very similar to what we've got right here. So let's start taking care of edit and delete inside the next section. Like I just said, now that create is done, implementing delete and edit is going to be remarkably straightforward. So trust me, these next two functions are going to be pretty easy, not that bad. We'll first start off with edit and then we'll move on over to delete, but in reality they're both going to be nearly identical. The implementation for each of them is going to be very similar to what we did for create. We'll first add a route to our routes file, and then we'll add a function to our controller. And that's it. We can go ahead and test both of them and we'll see how it goes. So we'll start off by opening up our routes file and adding a new route inside of here. So underneath our existing route that captures post requests, I'll add on a app.put statement. So remember, put requests are associated with attempting to edit data in some fashion. So because we are trying to update or edit an existing driver, I'm going to expect to see an HTTP request with a method of put. And then I want to see that request come into the route API/drivers. Now keep in mind, these routes that I'm designating, I can make absolutely any route that I want, anything that I could possibly imagine. But by convention, it's really nice to stick with, if this is like an API that we're working with, a /API namespace, and then the name of the resource that we're dealing with. Now there is one thing that's going to be slightly different in the case of put compared to post. When we have an incoming put request, we need to know which driver the request is attempting to modify. Rather than expect that ID or the ID of the record that we're trying to modify to be present in the body of the request, by convention, we usually put the ID in the URL itself. But since the ID of a record, we can never really know it ahead of time. Like I don't know what ID any of my records might have. So rather than try to write a very distinct single route handler for every possible ID, which would be total insanity, we instead are going to place a wildcard statement in here. So I'm going to put in :ID. That means match any route that is a put type request with a URL of API/drivers/anything. Anything. So this would match a put request of API drivers 000. Match it of 0001111. It'd match it if it was this. Or I don't know that. But it would not match like so. That is a different route. It does not have the last term in there to specify the actual ID catch. So now we can expect that whenever somebody makes a put request, they're going to put the exact ID of the driver that they're trying to update inside of the URL itself. Express will automatically parse the URL and place this ID into the request object. And we'll figure out exactly how to make use of that, because of course we're going to need to know which driver we're actually trying to get access to. So now whenever a put request comes into this URL, we're going to run drivers controller.edit. So we haven't defined that yet. We'll do so right now. So I'm going to flip on over to my driver's controller. Underneath the create function, we'll add on our edit function, which will be called with request, response, and next. Remember, next is for dealing with middleware. All right, so this is where knowledge of how Mongoose works is going to start to come into great play. We need to first take the update to the record that we're trying to apply. We need to take the ID of the record we're trying to find, and then we'll use Mongoose to find and update that record. Let's give it a shot. First, we're going to get access to the ID of the driver that we're trying to update. So I'll say const driver ID equals, and this is where that wildcard matcher that we just saw 2 seconds ago, that :ID, is going to come in handy. So to get access to this ID property right here, or this ID part of the string, whatever it might be, we can reference rec.params.id, like so. Notice that ID right here is only equal, it's only ID because that is exactly what we specified inside the connection string or the URL over here. So if I had put like driver ID over here, well then on this params object, it would have also been driver ID. So in other words, the two have to match up. So by convention, however, I usually end up going with just ID. The params object can have multiple different properties or multiple different wildcard matches on top of it. So if we had like ID and then also some other like, property or whatever, the params object would have also had params.property on there as well if the incoming request matched this URL pattern. All right, so that's the ID of the record we're trying to update. Now the update that we're trying to actually apply, like the updated attributes of the record, will be available again on the rec.body object, just as they were previously when we were creating a new driver. So of course, whenever we are editing a driver, we expect that the body of the request is going to have some number of updates to apply to the driver. So we'll capture those by again saying driver props is going to come from rec.body. Okay, so now it's time for the Mongoose stuff. We have gone over so many different ways of finding and updating records that are sitting inside of our database, but believe it or not, there's one that we still didn't even talk about. So we're going to cover that one right now because it's remarkably close to what we need for our operation here. We are trying to find a driver with a very particular ID and then update their properties or update some value that they have. So Mongoose gives us access to a function called find by ID and update. Remarkably well named. It does exactly what it says. You pass in an ID to find and then an object of how to update it. It'll find exactly one ID inside of our driver's collection and update it. That's pretty much it. So let's pass in the ID of the record to update in an object. Then as the second argument, we'll pass in the properties to update it with, which will be driver props. Now here's the one downside to this function, the one big downside. And so this is why I didn't quite introduce it much earlier, because you might be thinking, Steven, it kind of feels like I'd be using this thing all day. There is kind of a downside to it. And the downside is that it's .then, the function that we get here, you really would expect this thing to be called with the driver that was updated. In fact, it does not. It is not called with the driver who was updated. It is called with an object that gives you some statistics on what objects were updated. So in practice, it's not quite as useful as you would expect. But we do want to send the updated record back to our user or whoever made the HTTP request. So we will go back into the driver collection and find the driver who was just updated. So we'll say driver find by ID. We'll pass in the ID to find. Oops, driver ID. After that driver is found, we'll then take them and send them back to whoever made the request. And then finally, if absolutely anything goes wrong along this promise chain right here, if anything goes wrong, we will handle it by adding on our catch statement like so. So now, if anything goes wrong with the finding the actual record, we will place the catch statement here. Catch will get called if anything goes wrong. Next will be executed. It will go onto our error handling middleware and will show a nice error message to our user. Okay, so that's pretty much it for edit. Again, delete is going to look very similar. We should really test this thing ahead of time though, so let's take care of a quick test around this in the next section, and then we'll move on to delete. So I'll see you in just a second. Now that we've got our edit handler in place, let's put in a test to make sure that it's behaving the way as we would expect. So let's open up our test folder and find our drivers controller test file inside of there. Here we go. So underneath the existing if statement we have, we'll add on a new one, and we'll follow the exact same template. So a put to API drivers edits an existing driver if we follow the same template. So put to API drivers ID edits an existing, oops, I said user, I meant driver. We'll take in our done callback. And that's pretty much it as far as setup goes. So how in the world are we going to test this one? In the last case, we had done that count thing. So this time around, we're not editing or deleting records, so count's probably not what we want. I think that maybe the best way to do this is to create a driver, save it, like directly inside the test, like just raw save the thing, don't worry about the post. After that save is complete, we can then make a put request to our app to update the driver in some fashion, and then go back into the database, find that particular driver, and assert that the new property has been saved on them. So kind of a three-step process. Create a driver, edit the driver, then pull the driver back out of the database manually. Let's give it a shot. I think that we know all the syntax rules to make this happen, so I bet we can get it done pretty quickly. We'll make a driver, and we'll give them a default email of, how about rather than ttest@test.com, let's go with t@t.com. And I'll set their driving flag to start off as false. Let's shrink, there we go. So presumably, as a user or as a driver is using our app, they might be toggling their current driving status from true to false nonstop, right? They might be saying, okay, it's after lunch, I feel like driving for a couple of hours. I'm going to turn my driving flag to true. And then towards the end of the night, well, they want to go home, and so they'll flip their driving flag over to false. So I think that a reasonable test here is going to be to update that driving flag from false to true. So this is our driver. Let's save them to our database. So driver.save. And then after that comes back, I'm going to zoom back in here just to make sure everything's nice and legible. I just want to make sure you saw the end of this statement over here. So let's go back in. There we go. So after the driver has been saved, we will make our put request to our Express application. So we'll take our request helper. Remember, this is coming from Supertest right here. This is what allows us to very easily put together fake requests to our application. We'll make a put type request. And now here's the interesting part. What's going to be the URL that we're making the request to? We have to make sure that we reflect the ID of the driver that we're trying to update inside the URL. So I'm going to say API drivers /plus driver _ ID. And so that's going to have the effect of giving us a URL of API drivers and then the ID of the driver that we're trying to update. Now we can use a little bit of ES6 code right here to update this line. So if you want to stick with this, hey, totally fine, stick with it, totally fine. But if you want to use a little bit of ES6 code, we can update this string to instead be driver.id wrapped in curly braces and a $sign. And then instead of single quotes, we'll wrap the entire thing in backticks. Oops. So we've got backticks on either side instead of a single quote. And then we have $sign with an opening curly brace for the location where we want to refer to a JavaScript variable. So again, totally optional little piece of ES6 that you do not have to use if you don't want to. So that tells us which URL we're trying to access. We need to make sure that we also send along in the request body the update that we want to make to the driver as well. So this is going to be just the same as how we did with the post request up here in this other test. We'll add on a .send statement, and this will be the data that we want to send along inside the request. So I want to flip the driving flag from false over to true. Then we will end the request. The .end, by the way, is what actually kind of sends this request off and says we have no further customization to do to it. Then inside of here, we need to pull that driver out of our database and then make sure that the driving flag on them is set to true, because it should have just been flipped from false over to true. So we'll look at our driver collection. We'll find one driver with an email of t@t.com. And by the way, I'm specifically using that because that's the email that we just set on the driver that was just created. That, of course, is going to return a promise, so we can chain on a .then. We'll look at the driver who was found. We can assert that that driver is now driving. So we'll say, hey, is that equal to true? And then we'll call done. Notice that inside the assert statement right here, whenever assert is called, it's just looking for an error or a falsy value. So we are asserting something that should be equal to true. We could have just as easily said assert driver.driving, and that would have failed if driving was false, which is what we would have wanted. We want to say, hey, if that driving flag didn't get updated from false, then something went wrong. So we could just as easily written just this by itself, but I really like putting in the triple equals true right here because it makes it very clear to any other engineer in the future exactly what value we're looking for. This is a Boolean value. We are looking for this to be exactly equal to true, as opposed to just a truthy value. Okay, let's save this, run the spec, and see how we're doing. So I'm going to save. We'll flip back over to our terminal. There's our update. 3 tests passing. Yes, that's very good. Fantastic. All right, so this looks great. I'm very happy. We've got another working test inside of here, and our edit function is definitely working out. Let's take a quick break, come back, and do the delete function as well. Also, if you want to give the delete function a test by yourself or give it a shot by yourself, I encourage you to do so. Feel free to take a break between this video and the next one and put the delete function together. You can use everything that we did for put right now as a great template to work on the delete stuff. So if you want to give that a shot, I really encourage you to do so. Otherwise, I'll see you in the next section and we'll do the we'll do the delete stuff. So I'll see you in just a moment. If you gave a shot at putting delete together on yourself, hopefully you had a good time. Otherwise, we're going to go through the implementation of both delete and its respective test in this section and the next one. So let's get started. Again, it's going to look pretty darn similar to edit, so I think that we should be able to get through it pretty quickly. I'm inside of my routes file. Inside of here, I'll add on a route handler for the app.delete action. So if we get a delete request, it's going to match up with delete right here. I want to specifically look for a route of API/drivers/ID. And if we ever get a request with this URL of type delete, we will run the drivers controller.delete function. So let's flip over to our delete function inside of the drivers controller file. So here's my drivers controller file. I'll add on delete. This will be called with our request, our res, and our response objects, just as we had with the edit. So we can add in the rec, res, and next. And very similar to how we've been dealing with this before, we're going to take the ID off the params object. We will find the record with that ID and remove it. So let's get our driver ID from rec.params.id. And just like we saw with find by ID and update, there is also a method called find by ID and remove. So a very specialized function specifically for working with IDs. So let's say driver.find by ID and remove. Then we'll pass in an object with the driver's ID, and then we can chain on a .then. If this successfully finds and removes a driver, the .then statement will be called with the driver that gets removed. So one thing that I really like to do is to send back the record that got deleted whenever we make a delete request. Sometimes on front-end apps, it's kind of helpful to have that. So I like to include it in the response. Also, since this is a removal of a record, I'm going to assign it the status of 204. So an HTTP status code of 204, which means the record was successfully deleted. So we'll give it a res.status of 204, and we'll send back the driver that was deleted. And of course, just as previously, we'll add on our catch statement with next to make sure that if anything goes wrong with this request right here, or this operation on the database, we'll capture the error and send it on to the next middleware to be resolved nicely. Okay, so that's pretty much it for delete inside the controller. Let's take a quick break and then come back and take care of the test around delete. Now that we've got our implementation for deleting a driver put together, let's flip on over to our driver's controller test and add in a test for deleting a driver. So underneath the put test that we've already got in here, we'll add in another it statement. And this one will follow the exact same template as before. So delete to API drivers ID can delete a driver. So how about testing this one? How should we take it this time around? I think that maybe we could take a little bit of a hybrid approach on some of the previous testing methodologies we did, where we can create a driver, we can save it, and then maybe rather than trying to find a driver, maybe we could just assert that there are no drivers in our driver collection. That would definitely be one possible option, right? Like create a driver, save it. I would expect then to have exactly one driver, and then take a count or delete it, take a count and say, okay, no more drivers. The reason that I might not take that approach, however, is that if I ever decide that every single one of my tests seem to always need some default driver already existing in the database, maybe I would want to make a very common before each for every single one of my tests, where I would always make sure that I've got at least like 1, 2, 3, or 4 drivers sitting in my driver collection. So ever having a test of any kind asserting that there are exactly 0 drivers inside of a collection can sometimes be dangerous, because it might be down the line that you decide, well, I kind of want to have a default driver in that collection, but then all of a sudden your specs would break if you had been asserting that there were 0 drivers. So maybe that wouldn't be the best practice. Instead, we'll go with what might seem like a more logical approach. We'll make a new driver, we'll save them, we'll try to fetch them out of the database, and then we'll just assert that no driver with that particular email address was found. So let's give that a shot. Let's make our driver, and we'll give them an email. Let's give them a full email this time of test@test.com. We'll save the driver, add on our .then statement. We'll make our request to the app. We're going to make a delete type request this time. So previously we've used both get and put. This time around it's going to be a delete. And we need to specify a URL. Now again, I need to specify the ID of the record we want to delete in the URL. So I'm going to use a template string by using backticks again. So I'll put in my backticks /API/drivers, then my $, curly brace, and driver._ID. With the delete request, we don't actually have any post body or any body to the request whatsoever. So that's it. We just make the delete request and the server should basically take it from there. So now we will end the request. And now we can add in a operation to attempt to find the driver that we just saved and then deleted. So we'll say driver.find1, and we'll pass in the email, test@test.com. We can chain on our then. And inside of here, this driver, I'm going to expect it to be null because we did not find a driver with that particular email. So let's put in our assert of driver should be null. Like we didn't find anyone, too bad. So we will assert that, call done, and that should be it for our test. So let's flip on over to our test suite for passing, fantastic. Just to make sure it's passing as we would expect, I'm going to change driver from being null to asserting it's equal to an empty object. And so I definitely expect it not to be equal to an empty object. Yep, looks like everything fails as I would expect. So that definitely works out just a-okay. Okay, so fantastic. So I hope that it's starting to get a little bit evident that once you get one of these routes put together, all the other ones start to follow in kind. And in particular, a lot of the logic inside of the controller ends up being just absolute copies of a lot of the logic that we had already done in a lot of the tests that we've written throughout this entire course. When I was putting this app together for this course, I was really happy because it felt like we were able to reuse a ton of logic that we had already put together inside of some of the tests we've already written. So definitely good reuse of code in that regard. All right, that pretty much closes things out for create, update, and destroying records. We just have one big challenge left, and that is reading records out of the database. But remember, the reason it's so challenging is we need to somehow work in geolocation into this as well. So definitely going to be a fun and interesting topic to figure out how geolocation works with MongoDB. Let's tackle that topic in the next section. We've completed the route handlers for create, edit, and delete for our drivers collection. Now it's on to the most interesting and certainly the most complex route handler we're going to put together, the read or the fetch or the index route handler. Remember, the goal of this application is to show users a collection of all the different drivers who are located within some certain radius of them. So if we look up this mock-up of the application and figure that maybe we're sitting on this corner right here, we want to make sure that we only find drivers who are within a certain radius of our current location. So whenever someone makes a request to this last route we're going to put together to get a list of drivers, we want to make sure we require that the user passes in their current location. So we want to know exactly where they are. And then we will return to them all the different drivers who are located in some radius around them. So let's talk about exactly how we're going to use MongoDB to do that. First, I want to point out to you that Mongo uses longitude and latitude to track coordinates internally. Mongo has first-class support for longitude and latitude-based coordinate systems. So if we always make sure that we're dealing with longitudes and latitudes of our users and our drivers, we'll be able to make very fast queries and find users who are within a very certain location. As a little bit of a reminder of how basic geometry works, latitude records the distance in the y direction, while longitude returns the distance in the horizontal or east-west direction. The other thing I want to mention to you is that unlike many different mapping systems out there who traditionally record longitude, latitude coordinates in a ordered pair of latitude and longitude, Mongo uses the order longitude-latitude. So the order of all the coordinate pairs that we're always going to be seeing are in the x, y direction, as opposed to what is standard for a lot of mapping system, which is in the y, x direction, or latitude, longitude. So just remember, whenever you see a coordinate pair, it's always longitude, latitude, and you're going to be good to go. The last thing I want to talk about is the different mapping systems available inside of Mongo. So Mongo has support for two different orientation systems, or two different types of queries. It has support for both 2D and 2D sphere. In a 2D sort of world, Mongo considers your points, or your longitudes and latitudes, to be placed on a 2D plane. On a plane, the closest distance between any 2 points will be determined by the Pythagorean theorem. So take the square of the x distance, the square of the y distance, add them together, take the square root, and that is the true distance between points P and Q. So in the 2D world, it's just a very straightforward, simple calculation that assumes that the entire world is completely flat. Mongo also has a support for a 2D sphere type of coordinate system. In a 2D sphere world, the calculation of distance is a little bit more complex, but also far more realistic of how the world really works. For example, consider the points U and V as an extreme case. If I asked you to find the distance between U and V, I probably would not expect to see the straight line distance through this sphere from U to V, especially if I'm asking you about that distance in the context of like planet Earth, especially since we're doing like a mapping solution. The distance between a passenger who needs to be picked up in Uber and a driver who can get to them should not be calculated by considering the distance through the Earth, right? Like that doesn't make a lot of sense. So in a 2D sphere sort of world, the MongoDB calculates distances by considering the distance along the surface of the sphere. So much more how it's indicated by this point P to point Q with the red line. Or with U and V, it would be the distance along the surface of the sphere all the way around the outside to the opposite side, point V. So you'll see a lot of references to 2D and 2D sphere type coordinate systems in the MongoDB world. In general, 2D sphere, again, definitely a little bit more realistic, but there might be cases where you are not necessarily mapping distance between or around the Earth, and 2D system might work out a little bit better for you. In particular, the 2D system might make sense if you're considering distances over very small slices of the Earth. So if you've got like just, a couple square blocks or something like that, perhaps the 2D system might make a little bit more sense for you. Okay, so with this very brief overview of how MongoDB handles distances, let's continue in the next section and talk a little bit about exactly how MongoDB interprets coordinate pairs and how we relate them to our model schema. So let's talk about that in the next section. In the last section, we spoke a little bit about how MongoDB handles geography. We spoke a little bit about the differences between a 2D measurement system and a 2D sphere system. The next thing we're going to talk about is a little bit about how MongoDB internally represents these coordinates. So at some point in time, if we go back over to our driver model, which is located inside of our models folder, so here's our driver, it makes sense to assume that we're going to store a longitude and latitude for every single driver inside of our collection. So every single driver has some unique coordinate position inside the world, so it follows that we'll probably store a coordinate pair, like longitude and latitude, inside of the driver model itself. So the question very quickly becomes, how exactly are we going to store that data? Well, you might assume that we just say like, oh yeah, longitude, latitude, whatever. Well, not quite. MongoDB internally uses a system called GeoJSON to represent all the different geography that you can store. Let's check out the official documentation on GeoJSON and get a little bit better idea of exactly how it works. In my browser, I'm going to navigate to geojson.org. So this is the official webpage of GeoJSON, which is a format for actually storing location-based data in a JSON type structure. GeoJSON has this ability to not only support individual points, which would be like a single XY coordinate, but it can also represent lines, polygons, multi-point, all this different other kind of stuff. If you wanted to, say, find a polygon or find points within a very discrete polygon, maybe represented by a state, that'd be a great case for the polygon type of geography. Maybe a road would be represented by a line string, and certainly for us, the individual position of a driver could be represented by a point itself. So as far as storing a GeoJSON type point inside of a model, we can follow the same geometry example that they've got on this model right here. So under the geometry key, we will store a type point property and a coordinates property. The coordinates will represent the longitude and latitude of the driver's coordinate position. Now looking at this right here, we have to essentially store this data inside of our driver schema. And if you look at this very carefully, it looks like we've got a nested document in here of sorts. So when I look at this right here, the first thing my brain goes to is a sub-document. Remember, sub-documents are one of the very first things that we spoke about. It is a document that we will embed inside of a driver that will have its own individual schema. So let's put together some schema for a point inside of our driver. I'm going to change back over to my driver schema file, and we'll just define our sub-document in the form of something, maybe we'll call it like point schema inside of this file. So right above the driver schema, let's make a point schema. This will be a new schema that will have two properties, and you can know exactly what the two of them are by looking at the example of GeoJSON over here. We'll have a type and coordinates. So first we can represent the type. It will be of type string, and we'll default it to be a value of point. Next is the coordinate pair. So the coordinate pair is a set of longitude and latitude numbers inside of an array. So for the coordinates, we can represent that with a type of an array of numbers. Remember, we represent arrays of a certain type, or excuse me, not numbers, but singular number, just number by itself. So we represent array types by taking the type contained within the array and then wrapping it with an array. So this would be an array of numbers. Even though there's only two numbers in there, it's still going to be an array of numbers. We also have to specify an index on this property of 2D sphere. This index property right here is what tells MongoDB that this is a very special coordinate system, or a very special property right here that it should keep track of and consider to be an index that it can use for GeoJSON type queries. So now that we've defined our point schema, we can assign the point schema to the driver schema as an embedded document or a subdocument. In a previous example, we had broken out the point schema to be a completely separate file, but this time around, since it's a very tiny, compact little schema, I think it makes sense to just toss it into the driver model itself. So now as an additional property for the driver, we'll say that every driver has some geometry property, and it will be defined by the point schema, like so. Okay, this looks good. We've now defined our point schema and we've assigned it to the driver schema, so every driver has the ability to have a location. Let's continue in the next section and figure out exactly how we're going to make queries now based on the location of a current driver in the world. So let's figure that out in the next section. Now that we have the ability to record the location of every single driver who is registered inside of our database, we can write a query inside of a new route handler to find all of the drivers close to a very particular location. To do so, we're going to follow the exact same flow that we've used to add other other route handlers in the past. So we'll start off inside of our routes file, where we will define a new route to handle this query. The query will be represented by a GET type request. Traditionally, GET requests are associated with finding lists or any just displaying of data, and that's exactly what we're doing here. So we'll add on app.get API drivers, and then we'll map this to drivers controller.index. So traditionally, we call the route handler, or the function associated with it, that returns a list of records, the index function. So let's open up our drivers controller and define that function. By convention, I usually like to toss it up all the way at the top, so I'm going to put it right underneath greeting. I'm going to leave greeting around just so I want to leave it around just so we have a nice little starter function on here. It's always nice to leave around some tiny little cute piece of code, so we'll leave that for right now. So let's define index, which is going to take the request, the response, and the next function for our error handling. So now we need to figure out exactly how we're going to handle this query. How do we actually say, hey, give me all the drivers near this one point? Let's look at the Mongoose documentation and figure out exactly how that works. So inside of Google Chrome, I'm going to do a search for Mongoose. And I should probably do Mongoose.js, otherwise I'm going to get a bunch of pictures of mongooses. Okay, here's the documentation, very good. Let's read the docs. Then we'll go to the API reference on the left-hand side. So here's all the way at the bottom, API docs. And then we're going to search for specifically GeoNear. And yeah, if you recall, kind of hard to find things sometimes with search in these documentation. So we're looking for model.geonear. Here it is. I'm going to zoom in really quick just to make sure it's nice and legible. Okay, too legible. Sorry. There we go. All right, very good. So the GeoNear query is how we're going to look for a collection of records who are near a very particular point. Check out the argument list for GeoNear. The first argument is a GeoJSON object, so a point. Notice that you can also pass in a legacy coordinate pair. So I'm going to tell you right now, if you finish this course and decide to do anything with geography related to MongoDB, not the easiest thing in the world sometimes, just by virtue of the documentation. It used to be the case that MongoDB did not support GeoJSON and instead would locate all of its geography points using coordinate pairs like XY. So a lot of the documentation you'll find out there for working with MongoDB with geography typed locations is going to make a lot of references to legacy coordinate pairs, not GeoJSON. So whenever you're looking at documentation for GeoJSON queries or any type of geography query in Mongo, you'll want to make sure that it's written assuming that you're making use of GeoJSON. Fortunately, Mongoose has fantastic support going either way. So for us, we can pass in a GeoJSON coordinate rather than this legacy coordinate pair listed here. The second argument that we should definitely be aware of as well is an options object, which will be very important for us. We can check some of the documentation if you're at all clear, or excuse me, if you're at all interested to learn about all the different options, but there definitely are two options that we're definitely going to make use of. So let's give this a shot. I'm going to flip back over to my code editor. So here's our index function right here. We're going to make the initial query by writing out driver.geonear. So this says, look at the driver collection and run a GeoNear query over it. Then as the first argument, we're going to pass in a GeoJSON point. Remember, a GeoJSON point is an object that has a type and a coordinates property. So we're going to have a type. For us, we are looking at all the different coordinates using only points. So I'm just going to say point because we're looking specifically for a point. And then we can specify the coordinates that we want the query to be centered upon. So we're going to pass in coordinates. And we need to pass in the longitude and latitude of the point that we want to be centered on. So we'll pass in LNG and LAT as our coordinate. Now, of course, we have not yet defined longitude and latitude. We definitely have to do that. So we'll do that in just a moment. But I also want to toss the options object on here as the second object, as a second argument while we're working on the GeoNear query itself. So I'm going to put a comma, pointing that out in particular, comma at the end. And as a second argument to GeoNear, we're going to pass in two separate options. The first is a property called spherical. We're going to assign that to be true. So spherical means, yes, please assume this to be a spherical object that we're querying over. Of course, we are modeling people on an actual globe or an actual world, so we do want to factor in distance along the surface of the Earth in that calculation. Do note that MongoDB assumes that it is a perfect sphere, even though the Earth is not actually perfectly round. So if you're doing very precise calculation, well, you might want to consult the MongoDB documentation on that. The second property that we'll pass in as an option is the max distance property. It definitely makes sense in the context of an app like Uber. We want to make sure that if you look for someone in the city of like New York, you're not going to get a driver returned who's in Brazil, many, many, many countries away, many, many miles away, many kilometers away, literally on the other side of the globe. So we want to make sure that we only find drivers who are in a very particular distance of the center point, which is going to be our user. So for us, we'll say that we want all drivers who are within 200,000 units. The unit system that MongoDB uses is meters. So we can really read this as being 200,000 meters or 200 kilometers. 200 kilometers is definitely probably too much, yeah, but for our purposes of what we're trying to do right now, which is to just write a test around this, 200 kilometers is a good place to at least get started. If you were making any other type of application, like say find couches or cars for sale around me, I think that maybe 200 kilometers might be realistic if you really want to buy that car, right? So 200 kilometers, not the worst thing in the world. So that's it for the query itself. It does return a promise, so we will add on some .then and a .catch statement in a minute, but I also want to point your attention back to the longitude and latitude that we're going to pass to the query. So it makes sense that the center point for this query is going to come from whoever is making the request. We can't predict where a user is going to be standing when they want to find a list of drivers around them. So we are going to expect that the request object is going to contain the longitude and latitude that the user is looking for. Now, of course, a GET request, I shouldn't say of course, this is a little bit of trivia, a GET request, which is the way in which you access this index function right here, cannot contain a request body. So rather than looking at rec.body to get access to this longitude and latitude, we're going to look at the query string to get the longitude and latitude for our center point. A little bit about this line. I use a little bit of ES6 here, so I'm pulling the LNG and LAT objects or properties off of the query object. This rec.query right here is a reference to the query string in the URL. So the query string, just to be really clear, if I have a URL like google.com, and I put on that, you've probably seen this in URLs before, like a question mark, and then LNG equal to say 80, and LAT equal to, 20. Everything after the question mark is a query string. So Express does you a big favor by parsing this query string and storing all the different properties onto rec.query. So that's where these values are going to come from. We're going to expect that whenever someone wants to see a list of all the drivers, they will hit our API, put on a query string that contains the current longitude and latitude of the user, or technically any arbitrary longitude, latitude. It doesn't have to be necessarily their current location, but you get the idea. So again, it's really important to make sure that the URL is going to have the correct query string in it to get the origin point or the center point for our GeoNear query. All right, this looks like a great start right here. I think that we got everything we need in the short term. Let's take a quick break and then come back and start writing some tests around this query. And we also need to make sure that we put an actual response in from this query as well. We just put together our GeoNear query. Let's get started by first responding to the request in some fashion. So we want to make sure that we actually send a response back to whoever made this query. And then we'll write a test around it to make sure that it's behaving the way in which we expect. So I'm going to chain on a .then to the query. It's presumably going to be called or resolved with a list of drivers who are around the origin point, the longitude, latitude. Who knows what this object really looks like? Let's just console log it or just send it back for right now. So we'll just say res.send drivers, and we'll figure out what to do with it later. And we'll also put on some error handling with our catch with the next statement. Okay, so good start at least. Let's write a test around this query just to figure out how the darn thing works. So I'm going to flip over to my controller test file inside my test directory. Here we go. And going down to the bottom, I bet you can guess what's going to happen. Let's write our it statement. So it get to API drivers finds drivers in a location. All right, so testing strategy this time around. What do you think we should do? Considering the query, I think that there's two big things that I want to test around this. The first thing I want to test is to make sure that we find at least some drivers, right? Like this query actually works and returns some number of drivers. The other thing that I want to make sure of is that the max distance on here works as intended. So I want to make sure that I only find the drivers who are within a certain location or a certain distance of some origin point. So I think that maybe a good way to test this would be to create two different drivers who are located with completely different longitudes and latitudes, run the query, and then see which of the two we get back. Okay, so let's give that a shot. The first thing we'll do is create two different drivers and save them. So let's make one driver who is located in Seattle, Washington. We'll call them Seattle driver. And we'll give them an email of seattle@test.com. And then we also have to specify their geometry or their location in the world. So we'll specify that with the geometry property. It'll have a type of point and coordinates. I happen to have the coordinates of Seattle just written down as you might guess. So the coordinates of Seattle that we're going to use are -122, 4759902 and 47614768. Of course, we could just use like whole numbers here, so we could just go with -122. You could probably go that way a lot more easily now that I think about it, but whatever. If you want to write out the decimal, that's probably for the best. So this is our Seattle driver here. I'm going to shrink the font size just a couple more times so you can see the whole thing. There we go. That's our Seattle driver. Now we will also define a driver who will be located in Miami, Florida, which is on the complete opposite end of the United States. So definitely many, many, many kilometers, many miles away. So we'll say Miami driver is a new driver. They'll have an email of miami@test.com and a geometry with a type of point and coordinates of -80, 0.253. I think that's good enough. We don't have to do all the decimals. And 25.791. Okay, so these are our two drivers. Now we're going to have to save them, and then only after they've both been saved can we issue our query and then assert that we got the response back that we would expect. So remember how we save two different records in parallel? We'll use promise.all. So we'll say promise.all and then pass in an array of promises. So we'll call Seattle driver.save, Miami driver.save. So after both the Seattle driver and the Miami driver have been saved to our database, we'll add on our .then. And inside of here, this is where we're going to make our query. So this is where the action is going to happen. This is where everything comes to fruition. So inside of here, we'll make a request to our app. It'll be a GET request. And now here comes the fun part, the URL. So this is where we're going to have to specify the center point for the query itself. Like what should the query be originate around? What should the center point of trying to find drivers be located at? So we'll specify first off the route of API/drivers, and then the query string. So this is how we customize the query. We pass in a query string as the URL or inside the URL. So I'm going to say that it's going to have a longitude, and we're going to try to find the Miami driver here. So let's say a longitude of -80. Make sure you get the negative sign in there. So -80 and a latitude of 25. So we don't have the exact decimal points in here, but because this should find all the drivers who are located around this center point, I'm going to expect that these whole numbers are close enough, or these integers are close enough to the decimal points that we have here. So then we will end the request. We'll watch for an error and we'll get our response object back. So now let's console log the response. Let's just see what we get. I've got no idea. Maybe you know. So we'll console log the response and we'll call done. So let's save this, run the test, and see what happens. I'm going to flip on over to my test. Looks like the test runs. Here's our response object. And, interesting. I've got a 422 with a error text of no geo indices for geo near. Well, that's definitely not good. So this is one of the big gotchas around working with geography with MongoDB, especially in a test environment. So this right here is another one of my big complaints around working with Mongoose, Express, and Mocha. Kind of a pain sometimes. So let's take a quick break, come back, and figure out exactly why we're getting this error message right here. In the last section, we were able to make our query for finding all the drivers near a particular location, but we got back an error message that says no geo indices for geo near. So remember, when we were defining our schema for the driver, I'm going to flip back to our driver model file over here. Here it is. Inside of here, we defined our point schema, and we said there should be an index of 2D sphere placed on the coordinates. And it looks like the error message is definitely talking about indices, specifically like geography indices. So what's going on here exactly? Well, let's do a little bit of investigation. I'm going to open up RoboMongo really quick, and I'm going to connect to my local instance of Mongo. And I'm going to find my Moober and Moober test databases. So remember, we have two databases now, one for all of our test data and one for all of our development data. I'm going to open up Moober. I'm going to expand collections, drivers, and then indices. And inside of here, okay, yep, as expected, we have an indice or an index over our collection of geometry coordinates. And this is what, just to be really clear, this is what Mongo requires to have exist for any type of geography query to exist or to take place. So the error message that we're seeing specifically says, hey, this thing doesn't exist. The index isn't here. But we're looking at it and yeah, it is. What's going on, right? Well, let's look at Moober test because that's the database we're actually using when we make these queries. So I'm going to expand Moober test, collections, drivers, indices, and hey, wait a minute. Our Moober test collection only has an index over the ID. So what's going on here? What's happening? Well, this is a little bit of a big headache around, again, Mongoose and Mocha. So the issue here is that inside of our Mocha environment, we are dropping, I'm going to open up my test helper file inside the test directory. So here's test helper. In the test environment, we are dropping our drivers collection nonstop right before every single test. We just keep on dropping it over and over again. When we drop a collection, that kills all of the indexes inside of it as well. However, our driver schema, this index right here that we're placing on coordinates, is only created when the schema first loads up. So essentially, we've got a big order of operations problem. When our test suite loads up, when the test suite loads up, the index is created successfully, but then before every single test, we drop the collection and that index goes away and is never created again. So what we're going to do to fix this error is add on another step to our before each. So right after dropping our collection of drivers, we'll add on a .then statement. And inside of here, we're going to make sure that the correct index is in place over the drivers collection. So we'll say drivers.ensureIndex. I'm going to close the left-hand pane. And we're going to pass into that an object with a key of geometry.coordinates and a value of 2D sphere. I'm going to zoom out again for a second just to make sure you can see the whole thing. So there's a lot of parentheses floating around here. Do make sure you have the correct number of parentheses. So what this index function does right here is it makes sure before any of the tests are ran that an index is in place over the geometry.coordinates property on the driver's collection. So every single time that we drop the driver's collection, hey, just immediately go ahead and recreate the index. And so this is required right here to actually make our geography queries. So let's save this file and see how we're doing now with our test suite. I'm going to flip back over, scroll to the bottom. Okay, well, let's scroll up. Okay, so here's the new run right here. Well, we've now, unfortunately, still got another error. An error of field, near field must be point. Well, gee whiz. So these are two of the really big gotchas that you're going to run into whenever you're using MongoDB with Express. Excuse me, losing my words here. Let's figure out what this error message is in the next section. In the last section, we figured out one of the big gotchas around using MongoDB with Express and Mongoose. And let me tell you, I hate to toot my own horn too often with these courses that I make, but this is a really big gotcha right here. And so I really feel like you did the right thing picking up the course because, oh man, you can't imagine the amount of research I did for this course ahead of time to make sure that I gave you like the very direct, clear way of doing these GeoJSON queries. There is a lot of conflicting documentation online and just tons and tons of Stack Overflow posts asking exactly how to do this stuff. As a matter of fact, if you're at all interested, feel free, like really feel free to write a blog post about all the setup that went into doing these GeoJSON queries. I bet you would be a pretty darn popular blog post. All right, anyways, looking back at our terminal, if we look at our test output, we're still getting an error message here, but this time around it is near field must be point. So this one, another big gotcha. Yep, another big gotcha. What could this one be? Well, I'm going to point us right to it, save us a little bit of time. Inside of our driver's controller, we have our index function. And if you recall, we looked at the query string and we pulled off a longitude and latitude, and then immediately passed that as coordinates to the GeoNear query. So here's the big gotcha. Here's the one that will really bite you in the rear, not gonna lie. When we pull variables out of the query string, even though to you and me, they look like numbers, right? They look like numbers. When we made that query string, yep, -80 and 25. They sure look like numbers to you and me, right? Well, Express doesn't know that. Express thinks that they're strings. And so the error message that we're getting about near field must be point means the longitude and latitude that were passed into the query are strings and not numbers. So to make sure that we get a number out of both of these strings, longitude and latitude, we're going to call the parse float function. Parse float is built into JavaScript, so we don't need to require anything, nothing like that. What parse float does is it takes a string and it does its best to pull a full decimal value out of that string. And so for us, this is exactly what we want. So we'll call parse float on both longitude and latitude. So let's check our test now, one more time. And scroll back up, up. And okay, so now we at least don't have an error, but our body is empty. So still have a little bit of an issue going on. Let's take a break, come back in the next section and do a little bit of troubleshooting to figure out what the heck's going on now. We're now able to successfully make a query, but the query comes back with an empty body. In other words, no drivers were actually found. So what's going on this time? Well, this one you might be able to chalk up to me. It might be my fault this time around. My greatest apologies to you. I'm sure when you guys were reading this, you were all screaming at me, Steven, you can't spell at all. I'm sorry, talking and typing sometimes is a little bit challenging. So the issue is I've got a big typo in geometry in both of these. So geometry and geometry. Definitely my mistake. Got to check the spelling on there. So we will fix the spelling, save the file, and flip back over to our terminal. Let's see what we've got now. If I scroll back up, all right, so much better. So now we've got, under the body property is what we're really looking at here, but we can look at text to get a JSON representation of what's getting sent back. So the body has an array with a single argument inside of it with a distance property. The distance is the distance to this record in meters. So this driver right here, you can see the full driver right here, is recorded as the record that was found, and the distance to it is 91 kilometers or 91,000 meters. So that's pretty much it. Definitely worked out. Not only did we find the closest driver to the origin point of our query, but also, very importantly, the max distance that we set kicked in, and we did not get Seattle back in our result set. So as far as our test goes, I think that there's two big things that we want to make an assertion about. First off, the request body only should have a single record inside of it. We want to make sure we only get back the driver from Miami, so we're going to assert that there's just one record. Second, we'll look at the email of that record and assert that it is miami@test.com. So to get access to that email, by the way, because it's definitely a very nested property, we're going to look at response.body at 0.object.email. I know this is like, array object, but it is really just an object. Okay, so let's give it a shot. Let's just do it. So inside of here, we'll replace this with assert response.body.length. There should only be one record returned, okay? And then we'll assert that response.body at 0.obj.email is equal to miami@test.com. So let's run our test now and see how we're doing. Scroll down the bottom. Test runs, 5 tests passing, fantastic. Let's break our test just to make sure everything is working as intended. And okay, looks good. Test fails exactly what we want. So I'm going to change that back to a length of 1. And that's it for GeoJSON queries. I know that maybe not a lot of syntax floating around here, but again, there is so much conflicting documentation online around GeoJSON queries. So I hope you really enjoyed walking through that last query. This application was really a pleasure to put together. I hope you enjoyed working through it. Definitely was very fun going through not only the MongoDB stuff, but also the Express stuff on the side. So I hope you had just as much fun as I did, and I hope you learned a lot. Thanks so much.